Yeah, whoa, okay, you got it. Hey folks, all right, thanks for being here. We're gonna get started in like a minute or so. So I know a lot of people are gonna be coming in. Happens this year just like this same way, right? Everybody's outside, they're downstairs, then they are notified or they realize that the keynotes are going on up on the 4th floor, and then everybody will come into the room. You'll notice that the configuration is a little different this year. Things have changed, right? We're in a different world from the time we were here last in person. So a year and a half or 2 years from 2019, a lot can change. So anyway, a lot certainly has changed. We're gonna go live in about 1 minute, okay? We'll go live. We're live streaming this as well. So we are live streaming this across social media outlets. So if you follow us on Twitter, LinkedIn, Facebook, everything that you see here is gonna be live streamed to those platforms. So if you have people that weren't able to be here, you might want to notify them that, again, if they want to catch the keynotes, they're welcome to. We're notifying people as well, so if they already follow us on those platforms, they can consume the content, they can watch. If you know of people that may not want to follow us on Twitter or like us on Facebook or just find our pages, they can, again, watch all of this live. So that's part of, certainly a way that we've changed is that live streaming most of this. And then all the sessions today will be live streamed to the virtual platform. So people that couldn't make it or didn't feel comfortable, we understand there are a lot of those, can pretty much watch all the content today on the virtual platform. So obviously we've never done that before, so that's new too. So anyway, okay, we'll go ahead and get started in just a minute. We'll give people another minute to come in. I know we're wrestling people downstairs too. So we are recording today. So this will be available. All the talks are being recorded, and we'll move quickly to edit the talks post-event and try to get them up on our YouTube channel about a week after, no later than a week after the event. That's the general goal. Don't always move that quickly, but we'll certainly try to move as quickly as possible. So be on the lookout for the talks. We hear from a lot of people that, hey, there are multiple talks going on at the same time that I really want to attend. What do I do? Or are they being recorded? Will they be recorded? So yes, they will. So that's something new too. And we've never recorded all the talks, but we will this year as well. Okay, let's go ahead and go live. What time do we have? I didn't even bring my watch up here. 8:50. Okay, all right. So let's see. We're about 5. We said we get started at 8:45. We're going to get started at 8:50. I'll talk quickly. I'm going to yield the stage to Major League Hacking in just a minute to talk about their open source awards. But before we do, just a few housekeeping things, general welcome. I do want to welcome you to All Things Open 2021. How many were here yesterday? Oh, a good number of you. Very good. Thanks for coming back today, and I hope you come back tomorrow as well. The event yesterday was great. We used day one, for those of you that have been here before, as sort of a kickoff. We do half day of programming, inclusion and diversity. It's a very important topic to us. It always has been. That went well, super, super well yesterday. So those of you that were here and attended that program, you're aware of that. You know that that went very well. So, but we're very happy to have you back. But again, I do want to thank everybody that was here yesterday, but I want to welcome you this morning. So thanks for coming back on Monday. And if you're here, this is your first day. Welcome back in right at 2 years, right? It's our first time back together. We did a meetup on September the 15th about a month ago, and that was our first program in person in a year, basically a year and a half or thereabouts. It felt really good. So, I'll say here the same thing I said there. It's great to see your face, even if it's half your face and you've got a mask on. I know we've got safety protocols in place, so thank you for abiding by the safety protocols and things like that. That's very important to us too. We didn't want someone coming and getting sick, or we just didn't want to take any chances. We didn't want that happening here while you're on site with us. So thanks to everybody for, again, acknowledging the safety protocols and going along and sort of abiding by the protocols. But thank you. That's very different than 2019 for sure. I do want to acknowledge our sponsors. They're great. We have some of the best partners in the world. We're just very, very grateful for them. The last 2 years, it's been, I'm going to acknowledge the elephant in the room, right? There's an 800-pound, one that's bigger than that in the room, but it is COVID, and the world has changed. So much has changed, both personally and professionally, maybe with the company that you work with or work for. Maybe if you run a company, you know what I'm talking about. And then, even with your family, I know we have 2 small kids. Things have changed so drastically over the last year and a half. Sometimes it's hard to wrap your head around, frankly, all the changes and everything. Now that we're slowly coming back online, I do think that, the migration back online to a more normal, what we would all refer to as normal, it's going to take a little bit of time. It's going to be a slow migration back, I think, but we are going to get there. So this is the start of it. We're in the beginning stages. But again, I want to thank you all for kind of not assuming some risk, but certainly coming on site to be with us and taking a chance and assuming that the protocols were going to be good and trusting us and things like that. So thank you, thank you. Our sponsors are making all this possible. Without them, we wouldn't be able to do this. We wouldn't be able to do the live streaming. We wouldn't be able to do the on-site production and just hosting and everything like that. So our sponsors are the absolute best. I do want to thank the ATO team. They've helped to make this happen. I work with them daily. They're amazing, really great people, but I do want to acknowledge all of our volunteers as well. A number, even of you, might have been a volunteer or you might be volunteering in the days ahead. I want to thank our volunteers too. And I want to thank our speakers. Our speakers, both virtual speakers and on-site speakers, it takes time to put a talk together, to write slides, to deliver a presentation as well. So we never take for granted the amount of work that goes into it, submitting a talk, putting yourself out there. Your talk might be accepted, it may not. That takes courage, that takes time, and so we always acknowledge our speakers, and I just want to tell you how thankful we are for them. Again, COVID-19, thank you for acknowledging the safety protocols. I know I said that, but it does bear repeating because it's so visible this year. I hope in future years and with future events, it's not as visible and it's not so top of mind, and we don't have to be quite as concerned with it moving forward as we are now. But thank you again for that. By the way, let's see, Damon, can we bring up an image of the mobile app sign? Just want to bring this up. So we are playing, there is a gamification component to today. So I talked about this at the event yesterday, but if you download the on-site mobile app for the on-site program here, and the sign will tell you how to do that. Follow those instructions. We actually have the app with a company called EventMobi. We've used them multiple years. They're a really good company. But download that app, and it has the schedule and speakers. But what you do is, as you progress through the day, we will give you codes, and then our exhibitors, if you visit tables, they will give you a code that you can put in the appropriate field within the app. There's a gamification component to the app. And when we give you a code or you get a code from a sponsor table or an exhibit table, put that into the app. Once you do and you click submit, you'll be awarded points. And the people that finish with the most points today actually win really great prizes. So if you haven't seen the prizes, the gentleman that won the MacBook Pro yesterday, I wish I was wearing a GoPro to capture his expression. I don't know if he didn't think like, hey, are they really giving away MacBook Pro? But when he won it, he realized, no, actually it was random, it was fair, and he was walking away with the brand new MacBook Pro. We're giving away not only a MacBook Pro, but we're giving away System 76 Linux machines today, and we're giving away a bunch of other stuff that we would want to own. That's always our barometer. We give things away and make it available to you, things that we would want to own ourselves. So check out the app, check out the prizes, and here's what we're rewarding is obviously attending this morning and then attending the wrap-up session at the end of the day, attending the RIoT demo night tonight. If you attend that session, you'll be given a code there. You can enter it into your app. As you visit our sponsors and our partners and our nonprofits out at booths, each of them has a code that they can give you, and it's just entered into your app. But that's the only thing, those are the only things that you can actually get points for. We didn't want to do sessions. We didn't want to overly complicate it, and et cetera. We just didn't want to make it too complicated. So we've really simplified it. But the code this morning is just MARS1, M-A-R-S-1, MARS1. So for the keynote block, enter MARS1, and if you submit that MARS1, M-A-R-S-1, that should get you the points for the keynote block, okay? So this is something new. We wanted to create some engagement. We always have great engagement, but we wanted to encourage engagement and participation. So we're trying it. We're going to see how it goes. And again, if you have any questions, please let us know. But you have to download the app first, and certainly I would encourage you to do that. We've got book signings today starting at 11:30 down on 2. If you've attended ATO in the past, we've always done book signings on 3, right out by the registration table, right? Registration flips to book signing. We're not going to do that this year to maintain the distance. we are going to actually put all the book signings down on the second floor. So we've got a bunch of books. Brent Laster is signing this morning. He's signing 2 books. We've also got the poster giveaway down on 2, starting at 11:30. So what we're doing is go to the first block of breakouts, and then after the first block of breakouts, you can head down on the second floor. We don't have any sessions going on down there today. We've cleared that space. We've got tables. It's a breakout space. It's a networking space, and then lunch. So we've tried to maintain the opportunities for distance and the distance between attendees, et cetera. But go down on the second floor if you want to get free books, and Brent will be down there signing 2 of his books. But those start at 11:30. We've got book signings going on all across the day. So we have book signing schedules on the rockets. So if you see a rocket, we've got 2 rockets positioned down on 3. Grab a daily schedule, grab a book signing schedule, and that will tell you when those book signings take place. But they're happening across the day. Free books, the authors are signing those books. I would encourage you to do that. Okay, so with all that said, I'm going to ask John to come up. John's with Major League Hacking. It's an organization that we've wanted to partner with for, I don't know, about 5 years. So I'm thrilled to let you all know that we are partnering with them this year. They're here live. They've got a booth right out in front of this room, the ballroom that we're in. So I would encourage you to go out, talk to them. But they were accepting nominations for open source awards, and they're going to announce those open source award winners here. They're also going to make an announcement at tomorrow's keynote block session, Tuesday morning. But I think you're going to announce 1 or 2 of the winners today. So I'll yield to John.
Hello, everyone. Good morning. It's good to see so many people. This is my first conference in 2 years. I'm so excited to be here. I'm John. I'm one of the co-founders of Major League Hacking. As Todd said, we're right outside over there with a big, colorful booth. Come say hi. If you haven't heard of us before, we work with hundreds of thousands of early career developers all over the world to help them level up their skills and get jobs in the industry. A lot of you probably remember back how hard it was to get that first job or internship because a lot of them look for professional, coding experience. We've found that open source is one of the most accessible ways for people who are early in their careers to get that experience. And we actually created a program that gives students support and training and mentorship over the course of 12 weeks to actually work on production level open source code and then get a job with a lot of our partners. It's really incredible. There's a lot of really heartwarming stories there. And that's why we're here at ATO. We felt like we wanted to get more involved with the wider open source community and meet a lot of the faces that we've been working with over the last couple of years on this fellowship program. So as Todd mentioned, we partnered with ATO to do these open source awards. We have 3 categories of the awards this year. There's the Diversity and Inclusion Award for the project that has done the most work in building a more inclusive, welcoming world and open source ecosystem. We have our Next Generation Award, which is about the project that has done the most to build the next generation of open source. We care a lot about getting young people in that. And then we have the Community Award, which is the project that's done the most to give back to the wider open source ecosystem and community, and as an extension of that, the world. We're going to be announcing 1 of them today and 2 of them tomorrow. The one that we'll be announcing today is the Community Award. The project that we and our judges ended up selecting is kind of novel in that it is bringing open source to non-technical people. I think a lot of us think of open source as this highly technical code, focused discipline. But this project has done an immense amount of work creating tools that allow non-technical people to contribute data and information and perspective on the world in an open way, right? And that's really, really important, both in terms of general accessibility, but also in terms of building open source. And so that project, let's get a little drum roll here. We can stomp our feet or something. I like interactive, There we go, I love it. So the project that wins the Community Award is Mapillary. Give them a round of applause, yeah. Awesome. So Mapillary is a really cool open source project that allows a community of people to create their own street view. So anyone can submit photos, video, etc., and they all get kind of put together through this piece of software to create an interactive street view that can be part of things like OpenStreetMaps or similar projects. It's a really impressive piece of technology and a really cool community of people. If you look at who actually contributes to it, it's folks all around the world, very varying levels of technology and very varying levels of technical accessibility, and they've done a lot of work there to not only bring people into kind of this open data community, but also create open source tools that reflect that. And a number of our fellows actually had the chance to contribute to Mapillary over the last year, and it was a really amazing experience. So I want to congratulate them. We're not going to bring anyone up, for COVID reasons, but we'll be announcing this award later and giving out our beautiful little brick, which is way heavier than it looks. And tomorrow we'll be announcing the Next Gen and Diversity and Inclusion Awards. So thank you all so much. Come say hi at the booth out there. We have snacks, we have swag, we have a lot of friendly people. Thank you for having us.
Okay, so John, thank you very much. Again, we've wanted to partner with Major League Hacking for a number of years, so we're pleased as punch, as my grandmother used to say, that to actually have them here on site. So thank you for being here with us today. Wonderful, wonderful. Okay, with that said, we're going to now go to our first keynote speaker, which is really the reason you're here, right? You didn't come here to hear me speak. You came here to actually hear the content and speakers. We've got a great lineup of keynote talks. The talk topics are amazing, and our speakers are world-class. They're some of the best technologists on planet Earth, and we're just pleased to have them here. So our first speaker, now again, this year's event is hybrid, right? This is a different way of doing things. We're in a new era, a new world. So our first keynote speaker is Chris Wright, CTO of Red Hat. He's coming to us remote. I think he's coming to us from Boston, if I'm not mistaken. So I believe we're going to pull Chris up. And Chris is going to be speaking, I think, for about the next 10 minutes or so, 15 minutes, on open source to infinity and beyond. That's the topic of the talk. But he's coming to us from Boston. And then the three speakers that follow Chris will actually be here on this stage live. So again, that's part of what we meant by hybrid event. And again, this is events and conferences in 2021. But Chris, we're thrilled to have you here. And we really appreciate you joining. Red Hat is a long-term partner of All Things Open, obviously. Their worldwide headquarters about 2 blocks from here. This convention center is actually in the shadow of the Red Hat building, the actual Red Hat. So we've truly enjoyed the relationship. And again, Chris has been a speaker here. He was actually spoke on this stage the last time we were in person in 2019. So it's a thrill to have him back. And we're just very, very happy to have him here. So with all that, I'm now going to yield the stage and yield the screens to Chris. And I'll get off, and we will bring Chris up. And I think Chris is ready to go. He should be.
All right. Good morning, everybody. And welcome to All Things Open 2021. Obviously, I'm sorry I can't be there in person with you. But for those who are on site, I hope you're able to enjoy Raleigh this week. I know the city has changed a lot in the last few decades. Personally, I recall my first visit in 2005, and the awesome walkable restaurants and bar scene in downtown Raleigh wasn't really a thing. So I hope you're able to get out and enjoy. And again, sorry I can't be there with you. Now, as most of you know, our headquarters is in Raleigh, and just like the city, a lot has changed at Red Hat since our founding in 1993. And certainly, a lot has changed with open source since then as well. To kick off the All Things Open event, I'm going to spend a few minutes discussing the current state of enterprise open source, what I see as important trends and topics that impact all of us. Now, you might remember 10 years ago, back in 2011, Marc Andreessen famously proclaimed that software is eating the world. Andreessen wanted everyone to know that software companies were poised to take over major pieces of the economy, and that industries far and wide were going to be disrupted by Silicon Valley software companies. Several years ago, it became clear to me that it's really open source software that's eating the world. Now, did you know that almost 99% of audited code bases contain some amount of open source code today? That's according to the State of Application Security 2021 Forrester Report. And research we did this year with Illuminos, a market research firm, found that 90% of IT leaders said that they're using enterprise open source technologies. And this is astounding to me, because when I started at Red Hat nearly 16 years ago, we had about 1,000 people. And to think that we started so small, and today open source is so predominant across organizations and industries, it's truly humbling. And to now be able to say that we're a global company helping people transition to open source at a scale that, when compared with the early days, I never thought possible, it just floors me. Red Hat has about 18,000 employees in more than 40 countries. And we're proud to say that more than 90% of the Fortune 500 use Red Hat products and solutions. So that is a pretty strong data point that open source software really is eating the world. A shining star of the open source community today has been Kubernetes, which you can see in its massive impact inside enterprises. In response to our 2021 survey, IT leaders told us that Kubernetes is important to their cloud application strategies, and they're going to increase its use over the next year. Just look at the velocity of change and speed of development in the Kubernetes upstream. We've got about 1.7 million lines of code, nearly 4,000 committers, and more than one change every hour, every day. Over 3 years, nearly 70% of the code has changed. And it's almost unbelievable to think that more than half of the entire project has changed in just the last year. So all that velocity with Kubernetes is a proxy for its growing importance in the industry. I like to say that Kubernetes is to cloud as IP was to networking and Linux is to the OS. In other words, an abstraction layer that truly enables innovation above and below, enabling what Vint Cerf calls permissionless innovation. Kubernetes provides container orchestration on top of an infrastructure abstraction, whether you're using bare metal, VMs, on-premises systems, or public cloud. And that infrastructure world continues to evolve, whether it's new hardware or cloud infrastructure services. It's also the foundation for higher level abstractions, such as applications, functions, and services. A lot of community activity swirls around that nucleus of Kubernetes. And applications, be it in-house development or ISV applications, are evolving rapidly, taking advantage of that cube layer below. Kubernetes has emerged as a focal point for the industry. And I would go so far as to say the de facto standard for cloud innovation. Another big trend in open source is edge computing. Edge computing is the ability to generate insights from data and act on these locally where it matters. Since the computing takes place at or near the physical location of either the user or the source of data, it results in lower latency and saves bandwidth. To me, edge computing offers the ability to give life to the transformative use cases that businesses are dreaming up today and bring real-time decision-making to last-mile locales. These can include like a far-flung factory with automated manufacturing, or a train roaring down the tracks giving off terabytes of data, someone's connected home with computing that provides both comfort and security, or an automobile speeding along the highway using automated driving features. Or even in space. Who thought we'd be running Kubernetes in space? But we are on the International Space Station. And of course, you know that Linux is on Mars. Maybe we can now say that open source software is eating the universe? All right. I'm being a bit grandiose, but back here on Earth, edge computing is definitely garnering a lot of attention. But with the opportunities that edge computing brings, there are also complexities that need to be taken into consideration as you build out an infrastructure to support these use cases. The first is the challenge of distributed scale. Edge deployments, which can range from hundreds to hundreds of thousands of nodes and clusters, need to be managed in locations where there may be minimal to no IT staff and differing forms of connectivity, some reliable, some intermittent. So there needs to be a centralized way to deploy and manage both the infrastructure and applications, and a way for distributed nodes to tolerate being disconnected. Second, we know it takes an ecosystem of collaborators to build an entire edge stack, which means that developers to target that edge requires some level of commonality that we get from platforms like Linux and Kubernetes. And the third main challenge is around the variability encountered at edge locations. In a central data center, you pretty much have control and know the environment you are operating in. At the edge, sites can vary in size, network connectivity back to the central data center, power and cooling, environmental exposure, and even public access to the edge nodes, raising real security concerns. So you need a solution that provides a flexible set of options to meet the needs of different locations. At Red Hat, we're extending our open hybrid cloud strategy to the edge. Edge computing does not exist without the hybrid cloud. We believe an essential element of your technology story is a single horizontal open hybrid cloud platform. It's the platform that allows you to connect the core to wherever your workloads need to go on the edge, both for today and tomorrow. A platform that can handle any workload, any footprint, at any location. In fact, I believe the rise of edge computing will soon challenge cloud computing for the footprint where most computing happens. A really cool edge use case that's not new in itself, but represents where Red Hat is heading, is bringing Linux into automobiles. This use case is exciting and also brings with it a lot of challenges, including the space and power constraints, or a specialized form factor and the ruggedized requirements, and specifically crucial safety and security concerns, not to mention the data involved. Two automotive consortiums say that the average connected vehicle will produce up to 30 terabytes of data in a single day of driving, and that's their low estimate. So the more we keep moving computing and open source software farther and farther out to the edge, from automated manufacturing to automobiles and 18-wheelers to everything aerospace, the level of complexity will rise and the margin for error will shrink. At this point, I want to mention the hardware evolution that's having a big impact on open source. We're going to need to ensure that our hardware can deliver accelerators to help create better performance for specific applications, including edge use cases. And you see hardware is innovating at a pace that's staggering. It's got to keep up in order to support the different types of workloads, the demands for new capabilities, and address the constraints, like I mentioned earlier, for the automotive edge use cases, which is just one example. So yes, with the edge, there are challenges, but there's no doubt in my mind that edge's promise will continue to propel it forward. Let's talk about data a little more and where AI comes into the picture. Of course, we all know about the criticality of data, and it's only going to grow as we move forward, both in its importance and its size. According to the Linux Foundation, 175 zettabytes of data will be generated by 2025, which is 10 times more than in 2016. To me, Data is the central actor in any conversation about the future, whether collecting and curating data to build more powerful insights, create new products, or better serve your customer base. And the combination of data and AI are going to be infused into every aspect of computing. From recommendations for developers, how they write and pull code, to implement like internal implementation details, to computer vision and intelligence. The list just goes on and on. In short, AI is going to be pervasive for the next generation of every single thing we're going to build. It's not just the software. It's software connected with data in motion and process, persisted. That will be the future. So we could probably update our open source software is eating the world mantra to say AI is eating software. These systems are going to be complex, and automation is going to be key to managing that complexity. But at a certain scale, a massive scale with tremendous complexities, intelligent automation is required. It's a term I like to use. It's where intelligence is infused into operations and the developer pipeline, providing dynamic analysis of code and intelligence around the stacks you combine, for instance. This is an exciting area for the open source community because it's our future. When it comes to open source trends, we have to talk about security. This year, there's been a wave of attacks on companies, as well as a very important executive order from the US president on cybersecurity. The truth is, the attacks are not going to stop, and open source is right in the middle of the action. In 2021, there was a 650% year-over-year increase in software supply chain attacks aimed at exploiting weaknesses in upstream open source ecosystems, according to this year's State of the Software Supply Chain report. A question we're grappling with, as noted by Luke Hines, a fellow Red Hatter who's working on supply chain security, is how do you secure a supply chain for a product that has no physical form, no box to lock, and is created in an environment where anyone can contribute to it? This is the practical reality of open source that's at odds with knowing exactly where all your code is coming from. The threat landscape continues to change, and we have to keep up. SigStore is a recent example of open source community activity that helps us address software supply chain concerns. It offers a method to enhance security for software supply chains in an open, transparent, and accessible manner. SigStore is intended to make cryptographic signing easier and available to all at no cost. So far, the community counts more than 675 commits, 465 members, 20 organizations, and it's growing. But there's more happening in this space. Just last week, for instance, the Linux Foundation announced reinvigorated efforts in OpenSSF to secure software supply chains with new membership and commitment to collaboration in this really critical area. And lastly, I'd point out that in our experience with Red Hat Enterprise Linux, we were able to address trust and security concerns with our customer base. So 95% of the Fortune 500 felt comfortable with Linux. This is not, however, a mission accomplished moment. Our collective work on security remains crucial as the open source community continues to create new software that will change the world. To close, I'd like to talk about Operate First, community work that we initiated and are growing with the aim to develop and deliver open source cloud operations at scale. We all know that the mantra of upstream first is fundamental in creating sustainable community software projects. Operate First is a variation on that theme, bringing open source community innovation to the operationalization of software. The cloud has clearly demonstrated that software has latent value that is really realized when operated. Therefore, the layer used for the operationalization of software also has real value. In fact, that layer, which itself is actually software, contains important knowledge and value of how to operate, period, and how to operate at scale. When delivered as a proprietary layer, however, we lose the ability for communities to share their knowledge of operations, learn from each other, and evolve the operationalization of software along with that core software itself. So open source has to evolve to include the cloud-like operationalization of software. And that's the goal of Operate First, to ensure that the community is included in the operationalization of open source software. The way we're doing that is leveraging a community cloud we've initiated with others at Massachusetts Open Cloud. And Operate First cannot be successful if we don't get communities involved. So come join us and check out what we're working on. All of that is the spirit of an open approach, which has brought us here today. It's that same open approach that will help us explore the edge, changes in hardware, data and AI, open source security, and even operating open source code here on Earth, in space, and to infinity and beyond. So with that, I wish you a great All Things Open. Thank you.
Thanks, Chris. Thank you very much. All right, folks, that was great talk. Chris, again, thank you very, very much. I love Chris's reference to space, right? Because Adam is going to speak here shortly, and Adam is responsible for the mission to Mars and responsible for getting us to space and working with the open source community to actually enable a lot of that. So his references were very relevant, and they were honestly very cool because they were kind of a sign of things to come, things that are on their way later in this keynote block. You're going to hear from the person himself that is responsible for a lot of that, getting us to space and using open source to do it. So kind of cool. Okay, so with all that said, our second speaker is Demetris Cheatham. Demetris, come on up. I think you're next. And we're going to talk about open inclusion and diversity in open source. It's a topic that we covered in depth yesterday at the Inclusion and Diversity Program. And it's one that we'll continue to cover as we move forward with this event. We feel like it's a very important one, and we're going to continue to focus on it. So she's going to get mic'd up, and then we're going to bring her up. And then again, Nader Dabit. Nader is over here. He's sitting, patiently waiting for his turn at the mic. So Nader will follow Demetris, and then Adam will follow Nader. So that's actually the sequence. So by all means, stay around, and these keynote talks and the topics are fantastic. So is everybody doing okay? Everybody doing cool? I see lots of thumbs up. That's cool. That's awesome. It's so good to have you here. I cannot thank you enough for being here. Again, things have changed. We live in a different world. We're coming back to normal. Hopefully, we're on our way. But again, we're in the early stages, right? So everybody's still acclimating. Many of you, this is probably your first event seeing people in person, maybe in a group setting like this, for a year and a half. For literally a year and a half. So I'm sure it feels maybe not strange, but it feels new. But we really appreciate you all, again, sticking with us and coming out and joining us. So it's so good to see your faces, even if I'm seeing half of them. So they look great, and we're very, very grateful to have you here. So Demetris, I'll yield to you, okay? You're up, and thank you so much for being here.
Thank you so much, Todd. Hello, everyone. I am here today to talk about two of my favorite things: diversity and inclusion, and open source. And I promise you, I'm not just saying that because that's literally my job. Speaking of my job, I'm the Senior Director for Diversity and Inclusion Strategy at GitHub. I remember when I was applying for this job and I was going through my interview process, and I was meeting with Erica Bresham. And Erica was telling me how GitHub takes this very holistic approach to diversity and inclusion. She was sharing how it's embedded across the entire strategy, the entire business strategy, from its people, which is its HR functions, platform, philanthropy, and policy. And so Erica asked me that question that we all know is coming during the interview. She said, Demetris, why do you want to join GitHub? And so I had just heard about this amazing platform that had then 50 million developers. Now we're at 65 million developers. And in that moment, I said, I want to join GitHub because I want to open source diversity and inclusion. And I have to humbly say that it was a great answer because I'm here. So what does open source and diversity and inclusion mean? To figure that out, I just started talking to so many people across the entire open source ecosystem. Several of you that are in this room right now, but it was so many conversations. And throughout those conversations, there were some themes that just kept coming up over and over again. So one of the themes was inclusion happens at the community level. You see, when someone comes into open source, those first few interactions they have within communities, it really sets the tone for whether they feel welcome and they say, open source, these are my people. I'm here to stay for life. Or if they have some not so good experiences, so they come in, try to participate, and they say, this isn't for me, and we often lose them for good. The second thing was that maintainers are really the ones, those community leaders, that sets the tone for inclusion. You see, you think about maintainers as being the one that drives those day-to-day interactions. It's almost like a manager to a team. It's really there where inclusion happens. But one of the things about it, those maintainers said, we have tons of resources that tell us how to drive inclusion. They were like, we have podcasts, we have checklists, training, events, conferences, you name it. Everybody's throwing something at us to tell us how to drive inclusion. So I said, well, if resources isn't the issue, what's happening? And this is where the conversation started to differ a little bit. The maintainers of small communities said, yes, we have the resources, and we have the influence, meaning we're touching most of our community members, at least on a daily or a weekly basis, but there's a conflict that we have, a competing priority. We don't have the time to focus on it. We know it's critically important, but when you're first starting a community, you're just trying to focus on getting as many contributors to your communities as possible. What they shared was that we need hands on the keyboard. So while we know it's important, we just have to focus on other things at this time. So then I started talking to maintainers of larger communities, and they said, Demetris, you're right. We have the resources now, we have the bandwidth, but there comes a certain tipping point when your community becomes too large for you to easily influence the culture. So the later you start, the harder it is. So now you have these two tensions, right? You have the people that need to be focusing on and driving inclusion. They need to focus on it at a time when they just don't have the time or the space or the capacity to do it. But one thing that we heard, whether it was from large communities, small communities, well-resourced, under-resourced, they said one thing that we know. There are still some significant barriers to access for people to even get to open source. You see, we can build the most amazing communities possible. They can be so welcoming, but if the gate is too high for people to even get to our communities, what are we really doing here? So we can't fall into that myth of if we build it, they will come. We have to help them get there with us. So with all of these themes in mind, we are pleased to announce All In. All In is an open source community whose mission is to advance open source diversity and inclusion in open source by focusing on access, community, equity, and data. But we know that we have to do this open source community openly, transparently, and more importantly, in collaboration with all of you. So here's what we've been up to and what we're committed to doing over the course of the next year. We are launching an open source, we've actually already launched an open source diversity, equity, and inclusion survey. We are embarking on a maintainers listening tour, and so for those of you that were here yesterday and tuned in yesterday, you heard some of our preliminary findings from that. And we are having an all-in 12-month pilot focusing on students and maintainers. So today I'm going to talk to you about where we are with all three of them. So the open source diversity, equity, and inclusion survey, when we started thinking about All In, we realized that we just didn't have a lot of data around DEI across the open source ecosystem. There's been several surveys that have been launched for specific communities, but we really didn't have a good grasp of what was happening on the big picture. So we partnered with the Linux Foundation, and back in July, we launched this survey. We had thousands of people who responded, which resulted in a great survey sample of 2,350 completed surveys. So what did we find amongst that survey? Here's one thing that we have to celebrate. Out of the people that responded to this statement, I feel welcome in open source, 82% agreed with that statement. That's good news, right? Something to celebrate. I can tell you there are companies that would be thrilled if they could get 82% agreement on their engagement surveys. So many would stop there. But that's not the purpose of diversity and inclusion. That's not what we do. We want to give voice to the 18%, the almost 1 in 5 who do not feel welcome in open source. What are their stories? What are their experiences? Because it's those stories and experiences that might be keeping thousands of others from even attempting to join open source. That's where the work really begins to start. That's where we have to begin the conversations. We want to know what the 25% of people who are with disabilities, how are they feeling? We want to know the 26% of women who do not feel welcome in open source. What are their stories? What about the 29% of persons of color here in North America and the staggering 38% that identify as non-binary or a third gender? Why are they not feeling welcome in open source? That's where we have to begin the conversation. Here are some of the things that we heard from those that do not feel welcome. A lot of them felt that when they come into a community and if they lack the technical skills and knowledge, especially to contribute to code, they're made to feel inferior. We heard comments that said that if I'm not white, if I'm not male, if I'm not highly educated, if I'm not rich, that they're not wanting me to participate in their communities. We also heard that a lack of response or rejections to contributions, this is something that was really, really bothering people and making them feel unwelcome. They said that their contributions were rejected or just flat out ignored. When you ignore someone's contributions or their comments, they said that they feel invisible. It's not about their code at that point. It's just about, can you see me? 46% said that they have experienced some type of language that is making them uncomfortable. So all types of stereotypes or rejections, microaggressions, cultural barriers, they are experiencing these things, so either we're not speaking to them or we're speaking to them in a way that is making them feel uncomfortable. We have to start thinking about and addressing these concerns because that's where people are feeling unwelcome. Those are the stories that are getting repeated over and over again in open source. We have to get to a point where inclusion is the norm, not the exception. We have to get to a place where things like community hospitality is something that the open source community does it so well, where you receive an email or some type of notification when you join a community that says, welcome to our community. We see you, we hear you, your contributions are appreciated, your voice is needed. And I have to mention that the open source community uses GitHub Actions to do that. We also have to get to the place where tools, such as one that Sean Goggins from the Chaos community has introduced me to, where it is able to assess the community health across language, where if you're a maintainer or a community leader, you can run a report and in real time get an understanding of the conversations that are happening. And it flags potential non-inclusive conversations. So then you can take a deeper dive into it and say, is this something that I need to intervene? Is this something that I need to de-escalate? Those tools have to be in the hands of all maintainers, and we have to make sure that they're not cost prohibitive. In my opinion, they should be free. Inclusion language scans, accessibility audits, enforced codes of conduct, unbiased training for community leaders. These are the things that have to become the norm. So yeah, we're going to build it, but we're also going to make sure that we're addressing those barriers and those things that are making our communities not inclusive as well, so that they will come. So again, I mentioned the Maintainers Listening Tour. If you didn't see it yesterday, definitely check out the recording. But this is a series of individual interviews, focus groups, and online feedback that anyone can go onto our website and give us feedback if you're not able to make the interview or the focus group. Check out your agenda, because later today we're actually going to be hosting a Maintainers Listening Tour focus group here as part of this conference as well. We are going to make sure that we take that feedback from the Maintainers Listening Tour, and we are going to launch a 12-month pilot called All In for Maintainers. We're waiting to finalize that program design because we want to build that program with maintainers, not for maintainers. That's what open source community means. We do it in collaboration with the folks that we are really, really trying to help and to engage. We need that partnership. So I'll spend the rest of my time talking about this other 12-month pilot that we've launched 2 months ago, All In for Students. And I can tell you all, the students that are a part of this program are freaking amazing, amazing, amazing. These are students that attend historically Black colleges and universities, as well as a school that is right here in North Carolina that was founded for the education of the Native and Indigenous population. And so what these students are undergoing is this semester, they're receiving open source education, which is Open Source 101 that was generously provided by the Linux Foundation, and they're receiving professional development curriculum. They're learning things like resume writing, interviewing skills, but also those things that will help them really just hit the ground running when they join a tech company or when they join an open source community. Things around how to, understand your personal story and sell your personal story. The power of collaborations. What do you do when you are the only one? How do you make sure you're giving great feedback and receiving great feedback? How to deal with microaggressions and stereotypes. How to make sure you can find an ally and identify an ally, and how you can even be a better ally. These are the things that we're talking to them about in that professional development education. And then next semester, they will be undergoing a 12-week project, either with a corporate partner or an open source community. And we're doing that in partnership with Major League Hacking, MLH. So the students will be getting real-time experience. The whole goal of this program is that with that open source education and that technical experience, these students will be prepared for summer internships at some of our corporate partners. We were very, very intentional about the schools that we selected for this program. We went to the schools that often do not show up on any company's radar. We were also very intentional about the students that were selected to participate in this program. We wanted the students who are hardworking, who are dedicated, but life happens. The students in these programs, some of them commute 2 hours every day back and forth to school because they can't afford to live on campus. Several of them are caregivers, especially during this pandemic. We have parents that are in this program. We also have students who are athletes, who are working full-time. They're on full-time scholarship. They are active duty military or military reserves. These are students that have other responsibilities in which their GPA may not be an indicator of their aptitude for success. We wanted to go all in on those students that if you just open the door just a little bit for them, we know that they have the ability to succeed. And one of the things that I like to say that I'm proud of with All In, we've wrapped them into community. We have some amazing organizations who are supporting this program. We have the universities, we have the companies, which are GitHub, Red Hat, Microsoft, Fidelity, Cisco, Intel. They said we are all in for these students. Organizations like the Chaos Project, the Linux Foundation, Major League Hacking, All Things Open. Todd generously provided every student free access to be able to attend this conference. This is what open source and diversity and inclusion looks like. And I have to tell you, I asked the GitHub amazing design team, I said, do we have room for more logos? They said, we have tons of room. So I can't wait to come back here next year and talk to you all and have a lot more logos as well as names of each and every one of you who are going to join us in this community. But let me be very, very clear. All In is not a program. It's not a set of programs. It's not initiatives. All In is a community. And a community is made up of people who are dedicated, who are willing to provide their resources, their thought leadership, their empathy, their compassion. It's made up of people like all of you, and we need you. Remember when I talked to you earlier about maintainers and what they said when they are first starting a community? They need hands on the keyboard. Well, we need hands on the keyboard. So please, please, please join us. Here's how you can join the community. Go to our website. It's a landing page right now. Full website is coming in about a week. allinopensource.org. Join the community. Attend a maintainers focus group or a listening tour, or fill out the async form that's up there. Become a corporate partner. If you know that your company would love to participate in a program like All In for Students, we want to hear from you. We want the introductions. We are taking all meetings, and contribute where it counts in whatever way that is useful for you. So with that, I want you all to really hear the invitation to join us on this journey. Let's get to work, you all. Let's open source diversity and inclusion. Thank you.
You do a great job. I hate following Demetris now, right? Now it's like, oh, hey, it's Todd. Anyway, great talk, Demetris, and wonderful topic as well. Okay, so I want to thank again our first two keynote speakers. We've got Nader Dabit coming up now. Folks, we have, part of what we want to do with our keynotes are high-level topics that have a direct impact on you now, or are going to have a direct impact on you within the very near future, or are, in this case, impacting you and you may not even realize it. And Web3 is something that I'm personally following very closely. I followed it for a while. I'm super interested in this topic. Nader is at the forefront of this topic, and it's one, in my opinion, that's going to impact you in ways that you may not even realize. So I'm thrilled to have Nader here today. Topic of his talk, the title is The Blueprint, How Web3 is Reshaping the Internet. I'm looking forward to this. He's actually going to deliver a talk later today as well on creating decentralized apps, or dApps, if you've ever heard the term. And I think that's later today, I think at 2 o'clock maybe, Eastern time. So he's going to do an extended talk a little bit later today. But Nader, come on up. I'm eagerly anticipating this topic, and it's one I've looked forward to for a while. So thanks for being here.
Thank you.
Yep.
All right, so I want to see if I can get my slides up and running, and we'll kick this off. I want to mirror my screen. Here. I can pull it up. There we go.
And then do you have presenter view?
Yes.
You want to, yeah, keep it that way. That's right.
Oh, it is, right?
Yes.
Here, yeah. Yeah, maybe that. Oh, okay.
Patience. This is live TV, right? Again, I joked yesterday, we had an issue at the Inclusion and Diversity event, and there was a bit of a delay. And we also tried to give away a prize at the end. It literally took us 10 tries. And so that was a way to verify that, in fact, what we were doing was valid and it was real and it was real time. But there's a reason why live TV has become almost a cliche, right? Because you know when something is live. That's why a lot of people don't do live demos, frankly. In their presentations, most people steer away from live demos because when you're live, anything can happen. And, so anyway, anything can happen when you're live, and we're live here. So here we go. But thanks for your all's patience.
There you go, yeah. It's all good. Oh. Yeah, swap those around. Here we go. Thank you for your patience. My name is Nader Dabit, and I've been a software developer for about 10 years. My last 3 years, a little over 3 years, maybe 3.5, I was at AWS working on the front-end web and mobile team, and I recently transitioned into the Web3 space about 6 months ago. Really completely different shift in my career, and I've really had a fun time doing it. And I kind of want to talk about the reasons why someone like me would turn down, other interesting offers and more quote-unquote like secure types of jobs to kind of take a role at a startup that was really only about a month old. So my talk is called The Blueprint, and I want to talk about how Web3 is reshaping the internet, and kind of these are my perspectives, of course, and this is just kind of, a lot of the interesting stuff that I am having fun working with. So I kind of want to go over that today with you all. So a lot of times you will hear the terms Web3 and decentralized web kind of like tossed around, with each other. So a lot of times when you hear Web3, you'll also hear decentralized web and vice versa. So really what I want to talk about today is kind of like what all this means and what types of applications are being built and what the future of a lot of these platforms is kind of looking like. So before we kind of talk about Web3, let's talk about why this term even exists, because this is actually really kind of new to me as well. I just started kind of understanding and hearing about people partitioning the history of the web into 3 separate time frames, I guess you could say. Web 1, the read-only web, this was kind of like the early web where most people were not creators. If you were a creator, you were typically like a developer. And the average person like myself or you would be just reading information, reading text. This was the web up until around 2003, 2004, 2005-ish, when we then started seeing more dynamic applications being built. So Web 2.0 is kind of like where we are today, where we have millions of users that are actually starting to become creators, because you no longer need to be a developer to be a creator. You can just use a platform like TikTok, YouTube, Instagram, all these different applications that are out there, even blogging platforms, and you could think of WordPress. It enables developers to build platforms that enable users to be creators themselves. And while the internet has really thrived because of a lot of the really interesting stuff that has happened over the last few years, one of the underlying fundamental reasons that it's thrived is because of native protocols that we kind of use every day as developers. So a lot of these protocols are things that we might even take for granted at this point. Protocols like HTTP, FTP, SSH, TCP. One of the reasons that these protocols have really been so successful is because they are widely adopted and they're not subject to change. So if I build a site using HTTP, I can trust that anybody in the world can access it and use it without any centralized intermediary. We can just trust that it's going to work. And while we had the ability to do things like upload text files, attach them to addresses, make them accessible, there were a couple of major pieces of native functionality that were missing. Do you have any water, by the way? Okay, thank you. My mouth is getting a little dry. So yeah, while we had the ability to do all this stuff, there were a couple of major pieces of functionality that were missing. Native payments and native state. And to get around this, we typically have built over the course of the last few or dozen or so years, massively complex infrastructure to enable these things. So imagine sending a payment from here in the United States to someone back in my father's hometown of Ramallah, Palestine. Imagine all of the complex infrastructure that needs to be put in place just for me to walk into a bank, send money and have someone there be able to take it out and use it. Not only do you have to think about the banking system itself, but all the software like PayPal, Stripe, all these things that have to be put in place. And when you kind of put all of it together, it really becomes this massively complex web of infrastructure. In addition to that, native state is something that you can now do with smart contracts. So in order to deal with state in the past, what we've basically done is we build a server in our living room or in our garage, or maybe we spin up a server on some cloud provider somewhere. And we have now a database that we store things in. Now, there are a lot of really great things about this, but there are a few drawbacks as well. We typically have a single point of failure. So if anything happens to this database, it goes down, our entire application goes down. We also don't have full control over, thank you, over this infrastructure a lot of times. Things happen that are outside of our control that take down our applications. So to put it simply, you could think of Web3 as the stack of protocols that enable developers to build fully decentralized applications. And I really like this definition because it kind of puts it very concisely, because when you start listening to people talking about Web3, they often, vary from all types of different things that they try to put into the category of Web3. A lot of it's cryptic, a lot of it has to do with software, but a lot of it has nothing to do with software at all. So what are the characteristics of some of these applications? Well, you'll hear the term decentralized thrown around a lot, and I think that it's very, very important though, because a lot of the ideas around decentralization not only have to do with the types of applications that we're building, but also the types of communities and companies and things being organized in a way that are decentralized. And we're not only decentralizing all of the infrastructure, but we're also decentralizing the ownership of the applications itself. So when you think of a typical web startup or Fortune 500 tech company, you often have ownership that is centered into a small minority of people. Typically, a small percentage of people own a large majority of the company. And a lot of the developers and things like that have been working on the application of the company typically don't hold a ton of ownership there. Another characteristic is this idea of programmable digital money. So with the smart contract, you can easily transact payments between two parties with just a few lines of code. Self-sovereign identity. Individuals should own and control their identity without any intervening centralized authority. Distributed, trustless, and robust infrastructure, meaning that if one of my servers goes down or a dozen servers go down, we want our application to still be up and running. And having to do with all things open, really, this idea of open source software is really great, but what if we could have open source backends and open backends that anyone can build upon, and we can now have programmable backends that not only the company that built this application can use, but any developer could then start using and plugging together building like Lego blocks kind of. And this leads to applications being able to compete on backends for front ends. So if there are multiple backends that are all accessible for anyone to use and build upon, that means that we as front-end developers, because I'm really a front-end developer, can kind of build out interesting new applications of this backend or new experiences on top of this backend. And one of the characteristics you'll often see is that a lot of the way that these applications are enabled are through tokenization. So what are some of the types of applications that I'm talking about here? Well, gaming is a really interesting use case because you actually see really, really successful companies already being built in this way. So taking it back to, this isn't really like a Web3 game, but let's look at Fortnite as an interesting case study. If you have used Fortnite or you have children like myself that play Fortnite, when Fortnite first came out, it was really interesting because it was free. And we just downloaded it and I was like, yes, this is awesome. It's a free game. I don't have to pay 80 or 90 bucks for it. But in reality, if you have kids, you know that 80 or 90 bucks would have been a lot cheaper than all of the money you spent buying in-game currency or in-game skins. And all of this money starts adding up. We've spent hundreds of dollars and maybe even more buying in-game currency and skins, which is fine, I guess. But 100% of this money is going to this centralized platform, and when we're done using this application and my child outgrows it, we don't have anything to show for it other than a good time, which I guess is fine. But what if we can kind of make this more interesting and more valuable for the users that are taking time out of their day to interact with these applications? Well, Axie Infinity is a Web3 game that kind of does just this. People that play the game can not only earn currency from within the game that is then able to be sold on a liquid market, but any items that they buy within the game, they get to keep. And only 4.25% of the transaction costs go back to the platform, and 95% of the money being spent within the platform goes back to the users. Now, this has been really interesting because a lot of people playing this game outside of the United States in places where maybe they don't make the type of money that you see being made here have been able to actually quit their jobs and play Axie Infinity full time. Philippines is a country where there's a lot of an Axie Infinity community there. A lot of people there in other parts of Asia especially have done this. And more interestingly enough, even if you are living here or anywhere and you want to play this game, when you are done playing it, you can then have these digital assets that you can resell on a, again, liquid market, and then you have kind of more incentive to play this game maybe versus other games. And this isn't just kind of like a theoretical thing. Axie Infinity has over 2 million daily active users, and their growth has continued to skyrocket, especially in the last 2 or 3 months. They've had over $500 and $750 million per month, respectively, of revenue generated through this game. Again, 95% of that money going back to the users playing the game. Now, not everyone is bought into Web3 gaming yet, but you're starting to kind of see this domino effect of people that are in gaming. So, for instance, the founder of Zynga said play to earn and play to win is the next evolution of freemium. And Ryan Watt, the head of YouTube Gaming, said that I'm bullish on NFTs. NFTs are kind of how the in-game assets are often transferred, along with ERC20 tokens, which are kind of like, I would say, cryptocurrency built on Ethereum. And we're going to talk about a little bit around some of the environmental impact around digital currencies at the end of this talk, if you're interested in that as well. So like gaming is one interesting application of this. You're also seeing like the Web3ification of a lot of other Web2 quote unquote types of applications. So for instance, Spotify. Almost all of the money that's sent to Spotify does not go to the creators. It goes to other parties like the actual Spotify shareholders, and oftentimes to the record label people that have kind of like created the different contracts with the artists. Audius is geared more towards having the ability to pay the creators directly and having audiences be able to support them directly as well. So as a creator, not only can you have the ability to earn the typical revenue streams that you would from streaming, but you can also make extra money by having a streaming track that is trending that week. As a user of the actual app, you can create a playlist, and if people use it a lot, you also get paid in the digital token, which is Audius. But the most interesting aspect right now to me around Audius is that they are creating this like fan club thing. And when you think of something like OnlyFans, imagine that being applied to creators that are, focused on music. So you as a creator can maybe create content, especially for your fans, that they can access it earlier than everyone else. And it's kind of like this direct to creator from the consumer platform, which is pretty interesting. And they have over 5.5 or 6 million monthly active users and over 100,000 artists already. Blogging, mirror.xyz is pretty interesting. It's starting to gain popularity as well. It allows people that are writing to earn tokens, but it also allows them to do crowdfunding directly from within the platform. And we've now seen multi-million-dollar companies crowdfunded from a blog post. So people are writing a blog post, they have the ability to raise funds directly, and not only are they, of course, getting that money, but people are essentially able to invest directly in someone's idea through a blog, which is really interesting to me. DeFi and stable currencies are really kind of what people think about when they hear about smart contracts a lot of times. So why does this even matter? Well, a lot of my family is in the Middle East, and we've seen a lot of economic refugees directly from people either within our family or close to our family because of the political crisis happening there. Inflation over 90% over the last 2 years. Of course, you've probably heard of Venezuela and other parts of the world that have it even worse. Well, when I heard of cryptocurrency, I typically thought of Bitcoin going up and down every day and forests burning, when in reality, there are actual stable coins that are pegged to assets in the real world, like the US dollar. And there are many, and almost all of the smart contract platforms are using environmentally friendly consensus mechanisms. So if you are someone that lives in Lebanon and you don't want your money to not only go down in value, but also not be locked in the bank, which is kind of what is happening, you can choose, if you're working digitally in a Web3 company, to get paid in stable coins. These coins will be pegged to a currency like the US dollar, which is very empowering. Another thing that's very empowering is the idea of helping the 1.7 billion or so people in the world that are unbanked, meaning that they are not allowed to open a bank account. Why are these people not allowed to open a bank account or have access? Well, there's a lot of reasons, but I think the number one reason is discrimination. So if you look at the Global Gender Report of 2020, they noted after their research that 72 countries still don't allow women from specific social groups to even open a bank account, much less participate in the banking, borrowing and lending and all of the other stuff that you typically would like to do to kind of have, a normal or whatever life. Well, there are a lot of Web3 companies. Okay, yeah, there are a lot of Web3 companies that allow people to get paid directly in digital currency. So for instance, at the Graph protocol, which I work with closely at Edge and Node, we've given away over $100 million in grants that go to anyone that can either create blog posts, create open source, do anything to kind of help the Web3 and the Graph ecosystem come along, and we can pay them in these digital tokens. And then they can use these tokens in DeFi protocols like Curve, Uniswap, and Aave to earn interest and do all of the other banking stuff without any gatekeeping, I would say, at all. So, you hear about stable coins and crypto. This is kind of the interesting part of that to me. Social media is something that's still coming along. I don't think we've seen the actual true application of social media in Web3, but we definitely can do better than what we're doing in Web 2. Web 2 social media is built with the sole purpose of exploitation of user data, and we now have a lot of situations where we're essentially seeing surveillance capitalism in real time in our day-to-day lives. It's built by using advertising as a way to create as many clicks as possible by kind of following you around in your life and trying to figure ways out to essentially manipulate you. And also the platforms in general don't give any ownership to the user. So if I go on Facebook or Instagram and I build an audience of 10 million people, they're making a ton of money off of advertising. The only thing I'm able to do is maybe sell a milkshake or diet shake or something online. It's not very empowering to the users. So I think what you're seeing now in social media in Web3, we're starting to see ideas that are going to come into fruition, I think, over the next few years. That's going to change the way we think about Web3. I mean, the way we think, change the way we think about ownership by applying these Web3 ideas. So a glimpse of this is the idea of paying users to use a platform. So Super Rare is a digital art platform that allows people to upload and sell digital artwork in the form of NFTs. They did an airdrop to anyone that had been using the platform over the first course of X number of months or years. And if you had just used the platform, they took a lot of the money that they had made and actually created a token and then just airdropped it to anyone that had used the platform. So if you had just logged into this app, you would have been paid anywhere between a few thousand to tens of thousands of dollars. There was even one person that tweeted out that they had somehow been airdropped like almost $100,000 US from using this platform. It turns the idea of where the ownership is on its head, typically moving it more towards a distributed form of ownership. Gitcoin is another good example. Gitcoin is a platform that allows developers to get paid for helping out with open source. So instead of just contributing to open source, which is what a lot of us do because it's great and we maybe have enough money and time and whatever to do that, but let's say you live somewhere where you actually would like to get paid for that and there's nothing wrong with getting paid. You can actually get paid for your open source contributions, which is pretty interesting. I'm getting kind of close to being there on time, so I'm going to kind of jump through the rest of these. But with the idea of NFTs being kind of still fairly new, and to me when I first heard about them, I thought they were really stupid. I saw that this person named Takawa Shunsuke He is a digital artist in Japan, and he uses a lot of generative art software. He created a project called Generative Masks, and he used p5.js in 432 lines of code, and he sold a 10,000 unit NFT collection to his network, to his audience on Twitter, and he raised $3 million, and he gave all of that back to his community. He also programmed in a royalty of 10%, so anytime someone sold any of these items, 10% of the money went back to the community as well. So it was like a really cool way to kind of generate money, but also give people a form of ownership, because if you bought one of these, you could resell it on the open market. I think it's worth about twice as much as it was the day that it launched. So it gives people, I think, ways to kind of create this idea of raising money, but also giving back to the community and giving people that want to participate in giving something to show for it as well. And it just really creates new incentives, I would say, for ways of doing things. So with Web3 social media, I think it's going to combine a lot of the ideas I just talked about. We're starting to see Jack from Twitter play around with this idea of decentralized Twitter. We're also seeing the founder of Aave, which is one of the most widely used DeFi protocols, multi-billion-dollar protocols, exploring and building now a decentralized Twitter. But I think we're going to see, a handful of decentralized, tokenized social media apps come out in the next couple of years, and I have no idea what that's going to look like. And then the last thing I want to kind of quickly cover is this idea of web infrastructure. So when I think of web infrastructure, I typically think of something like AWS or GCP, where I used to work at AWS. Well, there are also these decentralized and distributed tokenized web infrastructure protocols that are trying to build out what you would typically think of as like serverless infrastructure, but do so more efficiently. So one of the protocols, this is the one I work with closely, is the Graph protocol. It's a decentralized network of nodes that allow developers to build APIs that index and allow the querying of blockchain data. It's now hit over 1 billion queries per day, and it's used by a lot of applications in Web3. Ceramic Network is an off-chain data solution. So instead of storing all of your information on-chain, a lot of times you need off-chain data, like a database. LivePeer is 10 to 50x cheaper for doing live video streaming than something like AWS, and they have a lot of users and a lot of participants in the network, and they have their own token as well. IPFS and Arweave are decentralized storage solutions. Radical is a decentralized Git provider. Identity works a lot different than what we're used to in the Web 2 world. Again, instead of handing over our email and our phone number, you typically have a way to identify yourself anonymously if you choose to, using something called a wallet for the most part. And a wallet is really just kind of like an abstraction over public key encryption, where you can create your wallet by getting a private key. The private key mathematically derives a public key, which mathematically derives an address. And your address is your identifier, and you can log in using a wallet without having to kind of hand over your personal information. And finally, IDX is a protocol for setting up user profiles if you do choose to do that, but you have full control over it. Instead of giving the application your information, you point the application to your IDX profile for wherever you would like to use that. So to wrap things up, in addition to some of those things, there are also DAOs, which are decentralized autonomous organizations, which are really interesting to me. The tokenization of physical assets and making them liquid. So for me, a really interesting implementation of this would be something like tokenizing a piece of real estate in New York and allowing anyone to buy into it and sell out of it really easily and really inexpensively. So if I want to buy $100 in a building in Shanghai, and someone in Shanghai wants to buy $50 in a building in New York, people are building out these exchanges that enable this and enable people to lower the barrier to entry to financial participation. So the biggest concern I had when coming into this space was environmental concerns. I thought that pretty much crypto is burning the world down. I found out that almost every single smart contract platform is already using or moving towards environmentally friendly consensus mechanisms, except for Ethereum, which is moving towards the environmentally friendly consensus. It's already been merged on a test network, and it should be merged to the mainnet in about 6 months or so. So at that point, really it will be, in my opinion, as efficient or more energy efficient than using the typical wasteful banking system that we have today? Well, that's up for discussion, but really I think that the main concern I have right now is Bitcoin. Bitcoin still uses an environmentally unfriendly consensus mechanism called proof of work, and I'm just not a big fan of it. But I typically wouldn't even consider like Bitcoin part of the Web3 space. So anyway, to wrap it up, one of my favorite sayings from Jay-Z is, I'm not a businessman, I'm not a businessman, I'm a business, comma, man. And I think Web3 enables people to stop being used as a tool from platforms to make money, and instead leverage platforms to make money for themselves. And that's why I'm excited about Web3. And that was a lot, so thank you for following along, and I hope that wasn't too much information in too short of a period of time. But if you have any questions, I would love to talk to you on the side afterwards, and I appreciate you checking out my talk.
Thanks, Nader. Okay, so just a couple things. If you're out there right now, and by the way, we have more than 500 people watching us virtually right now, so it's not just you here. I want to welcome everybody watching virtually from around the world. We have a lot of people joining us from other countries, not just the United States, so I do want to say welcome to you and thank you very much for being here. If you are not familiar with terms like decentralized apps or Ethereum or proof of stake versus proof of work, which is what I think what Nader was referring to, Ethereum moving to more of a proof of stake as opposed, if you're not familiar with those terms, if NFTs, if that's like, I don't even know what he's talking about, I would really encourage you to educate yourself up on that, because those are really going to become commonplace and far more common in the years moving forward. And I'll tell you this too, I don't know if you remember a talk by a guy named Andreas Antonopoulos in 2018 right here on this stage. He talked a lot about this, right? We've been on this topic for a while and talked about, money would become digital, and now we're talking crypto. And just in the 3 years since he gave that talk, we are light years ahead from where we were then. So in 3 years, so much has changed, and I think the acceleration of the change is only going to pick up. So with all that said, Nader, thank you very much. Next up is Adam. Adam, I know Chris Wright in his earlier keynote referenced the mission to Mars, Linux being in space, et cetera, et cetera. So Adam is the person actually responsible for making all of that happen. So really been looking forward to this talk. I want to bring Brad up with IBM. Brad, IBM is responsible for Adam being here today. He's going to do a very brief introduction, and then we're going to get right to Adam. So we're running a few minutes over, so I apologize for that, but thank you for your patience. We're going to go over by 5 or 10 minutes, then past what we were originally intended to. So if you just hang with us, we will get to the end of this segment soon. But again, this talk's going to be fantastic. Brad, with all that right there.
Hey everybody, I'm going to keep this brief because we're running behind a little bit, but I just want to say welcome to Raleigh. It's great to see all of you in person. I'm looking forward to talking open source with you in person, signing some free books later today. So it's great to be here at this premier conference. And let me just quickly say, IBM and NASA have a long, rich history of working together and in open source. And because of this, it is my great honor to introduce one of our guest speakers, who is the NASA chief engineer responsible for landing the Perseverance rover on the surface of Mars. So without any more wait, let me go ahead and introduce Adam Steltzner. And come on up, Adam.
Thanks. Good morning. Can you hear me well? Good. This will be a little different. I wish I could figure out how to get spacecraft into NFTs. It's been a rough kind of year or so for us, all of us here. You're sitting so spaced out, masked, socially distanced. It's been a rough time. And that rough time has had mostly downs, but there have been some ups in the last year and a half. And one of the great ups, at least for me, was this.
Propulsion, go. EDL safely, go. We have team Perseverance ready to execute entry, descent, landing on our own. Parachute has deployed, and we are seeing significant deceleration. The macro has separated. Sky maneuver has started. We're 20 meters off the surface. Tango Delta, Mission confirmed. Perseverance safely on the surface of Mars, ready and taking the landing pathway.
So, we landed a rover on the surface of Mars in the middle of a global pandemic. We launched her from Cape Kennedy at the height of the summer surge. That rover's name is Perseverance. Kind of a phenomenal name for the time that we are in. We named her before the pandemic hit. In fact, I was part of a group of people who looked at the names. It was a contest amongst school children around the world with essays and a name, and all those were sort of poured over, and eventually we came with this Perseverance. And I actually didn't like Perseverance as a name. I said to myself, this was in late February of 2020, I said, Perseverance requires us to be struggling against something. Doodle-a-doodle-a-dood. I want to talk a bit about Perseverance. I want to talk about getting onto the surface of Mars in the middle of a pandemic. I want to talk about her little friend that she took with her, the helicopter Ingenuity. And I want to offer some lessons that I think I learned from my team and the experience that we might all use as we look to go forward in our world, as we hopefully pivot out of this hard time and into sometimes better. But first, let's talk about Mars. For eons, Mars has captivated our attention. Before we could had aids to our vision, we looked up at the night sky and saw a light a little brighter, a little redder than the other lights in the celestial sphere. When we got early aids to our vision, although they were sort of crude, the first telescopes, we looked up and we saw life. We saw roadways and canals. We saw civilization. And then we realized that those are actually just natural features on the surface of Mars. But we never lost the idea that maybe Mars was alive. Because it's kind of a profound question, right? Are we alone in our universe? Are we alone in our solar system? Could one of our nearest neighbors harbor life? NASA has been trying to peel back the layers of the onion on that question for decades. And here is a family portrait of the rovers we put on the surface of Mars to try and understand the history and potential habitability of Mars. Starting in '97 with a tiny little Sojourner rover, size of a microwave oven. Important because we were able to put her on the surface of Mars for less than 1/10 of what we'd paid to make it to Mars successfully in the '70s with the Viking landers. Because of that, we said we're going to go back. We're going to go back to Mars again and again and again. In fact, the NASA administrator vowed, pounding the table, to return to Mars every opportunity we have. The way that the Earth and Mars go around the sun, you can only make it to Mars every 26 months. There's a little dip in the energy required when the planets are in the right spot. But we said every 26 months we're going to go to Mars. We're going to be on the surface of Mars every 26 months, but you can see there's more than 26 months between '97 and '04. And that's because we failed. We had some failures. We were playing a limbo game. How low can you go in terms of cost, in terms of number of people working on the missions? And it ends up being there's a certain ante of human brain calories you need to spend to be successful. If you don't, you can make a smoking hole on the surface of Mars, but you can't successfully make it to this surface. But we rallied, and in 2004, we put twin rovers, Spirit and Opportunity, on the surface of Mars. They were very important for these questions of life because they taught us that liquid water had been on the surface of Mars. And we know from here on Earth that where there's liquid water, there's life. But they couldn't tell us some important things about the water. Was it salty, sweet, acidic, basic? In short, was that early wet Mars habitable for life? Well, in come the nuclear-powered mega rovers. Curiosity in 2012. Chock full of all the science equipment necessary to answer this question about the early wet habitability of Mars. Could early wet Mars have been habitable for life? She gathered in situ data, sent it down to the Earth, and scientists here on Earth concluded the answer to the question she'd been sent to ask, and the answer is yes. Early wet Mars. 3 billion years ago, when life was just getting a start here on Earth, the conditions to support life were ripe on the planet Mars. Now, we don't know whether life started there, could have started there. It could have in terms of an environmental. Did it? We don't know. We actually know that the planets, both of them, were communicating with one another, a very low bandwidth protocol, but impacts in the orbital, early solar system orbital debris, late heavy bombardment, was sending material from Mars to Earth and from Earth to Mars. So life could have started on Earth and shot to Mars and flurried on Mars and still be there present. Or life could have started on Mars and come to Earth and we're actually all Martians. It's actually a thing. Could really be. So, that's pretty cool. Because it was so cool, we followed Curiosity on with her twin. A little tiny bit bigger, a little bit brawnier, Perseverance in 2021. She's got a sampling system. A system that can drill into the rocky material of Mars, take very special intact core samples of the Martian rocky surface, and seal them in hermetically sealed, agonizingly sterile vessels for return to Earth. But these mega rovers are really difficult to land, to get them safely onto the surface of Mars. In fact, we had to come up with an entire new way to land. First Curiosity and then Perseverance. This is a simulation of one of over millions of simulations that we would do before we'd ever push the launch button. Here we're landing the rovers on the surface of Mars, so slippery it can't rove, and yet we successfully land by lowering them below their jet backpack, the descent stage, the propulsion system, in a maneuver we called the sky crane maneuver. In 2012, I led the team that developed that technique, and in 2021, I led the entire rover for Perseverance to get her safely to the surface. I used to get so much criticism when we talk about the sky crane maneuver. I used to come up with this little pithy statement I would make before I would ever talk about the sky crane. It goes like this: great works and great folly may be indistinguishable at the outset. Now, I love that statement because it's simultaneously true and meaningless. Those are some of the funnest things to say, right? I mean, the truth of it is obvious. If something's very, very different, a good example is NFTs, non-fungible token, how does this really, right? When something's very, very, very different, you don't have a term of reference with which to understand it, and it appears crazy. It's just like a cognitive dissonance. Now, the truth of the meaninglessness of this statement is, of course, that crazy also looks crazy. So just because you say something that's outlandish doesn't mean, that you're not absolutely whack. But I promise you, if you ever say that phrase, great works and great folly, may be indeterminate at the outcome, people will then take whatever you say later like, whoa, that's intense. At any rate, we all had to come together and ask that question of ourselves on landing nights. First in 2012, it was a success. Second in 2021, on February 18th, it worked. Here is us wiggling Percy's toes. We landed the rover on our feet, on our wheels, 6 of them, and the first thing we did was start to move all the actuators, light up all the copper, make sure that we actually got the whole spacecraft intact to the surface of Mars. Then we took images of where we were. I love this one. This is one of the first images we took. You can see wheel tracks from us having spun in place, and then you can see that bright orange image up there is where our rocket plumes have scoured away dark overlying material and leaving the fresh iron oxide-rich dust that gives Mars its signature color. Then we trained our cameras on the reason for the season. We came to a place called the Jezero crater, pronounced correctly, Jezero crater. It's an old impact crater that was, when Mars was wet, a lake. And there was an inflow channel that left a big delta, a fan structure like we see New Orleans, Alexandria. That kind of deltaic deposits are great for preserving signs of ancient life here on Earth. And so we went to Yesero to look at that, which is one of the remnants of that deltaic fan deposit. There's others. That indistinguishable blob may have signs of ancient microbial life that started 3.5 billion years ago on Mars. Or maybe not. We don't know. But we came here to ask the question, to see what we could learn about the surface of Mars. And we brought a friend. It looks like a photograph, but it's actually a movie. This is Ingenuity spinning in place as she hovers on her second flight above the surface of Mars. She's now taken 13 and counting, and continues to amaze us as to her success. So here's that beautiful fan-like delta seen from orbit. This is a digital elevation map constructed by overflight data from XRISM and HiRISE, all on the Mars Reconnaissance Orbiter. It's been assembled to give you a height-accurate perspective as if you were flying about 30,000 feet in the air. And you can see a little star down here where I've placed the approximate location that Percy and Ingenuity are as they scurry about the surface, doing the scientist's bidding, asking the questions about what's going on with the history of Mars. I love them. Two great names, two great human attributes, perseverance, ingenuity. So I want to share some lessons that we learned as we got them to the surface of Mars in the middle of this yogurt that we've all been sitting in for the last 2 years almost. First, amazingly, we human beings are incredibly capable of adjusting to disruption. It was a fantastic gift, in some sense, for the tech industry, right? We all of a sudden went virtual. We never, ever, ever could have gone virtual. If you'd asked the staff at the Jet Propulsion Laboratory 2 years ago if you could operate a spacecraft from home, the answer would have been categorically not. In fact, a big, long list of ironclad reasons why it could never happen would have been given to you. But it just takes a bit of perseverance. Couldn't help mention it. But seriously, to stomach through the disappointment, to keep your eye on the focus, and, you know, I would normally be shoulder to shoulder. This is operations, physical operations, for a test that we really need to be physically present. There'll usually be 60 of us. There were 6 of us, masked, can barely hear each other because you're so spread out. This is early days. We were very, very worried. Nobody was vaccinated. Operating from home, impossible, except we did it. Changes to our personal lives, right? This is family, bi-weekly family trips to Dodger Stadium for family COVID tests. My son and my daughter both attended school in the living room, which is challenging for a 3rd grader. But these are things we all did and adapted to. To meet the challenge, some sectors, some certainly in tech, some businesses, some groups really actually bloomed during the pandemic because they were able to see the opportunities that the disruption created. They were able to see the new world that we were all in for what it really was and look for solutions, ingenious, creative solutions. That beautiful helicopter, Ingenuity, almost didn't make it to the surface of Mars. We needed to come up with an ingenious solution to close her design process. Independent team working fast to try and get her on board. This is a great image. This is made on Earth, by the way. She has a hazard detection camera that she shoots little black and white images looking for rocks where it's safe for her to land. She autonomously finds where she can land and lands. And then we took a set of those images that we downloaded here on Earth and stuck them together into this GIF. She almost didn't make it because our original plans were to strap her between the wheels on the side of the rover. So this is our rover as we're putting it together in SAF, the Spacecraft Assembly Facility at the Jet Propulsion Laboratory where I work. And we were planned to put Perseverance between the two wheels on the side of the rover. That was going to require her to fold her rotors in half and tighten the vehicle into a tiny little package. We'd have to deploy this thing like a lunchbox. It had to have batteries on it. We would drive away from it, and then battery powered, it would go through this unfurling effort. Now, the lean, mean team that was in the middle of developing the helicopter, using also some open source software, swore they could do it, but we were worried they might not be able to make it. So we made a late call to move her from the side of the vehicle on to the belly. That belly was going to be dangerous for her and dangerous for us. You might be able to see her there. Let me give you a better picture. I'm going to flip her over. Now you're looking at the belly of the vehicle, and now you can see Perseverance a little bit more clearly. The dual rotors, beautiful carbon fiber, super lightweight. We had to protect her against the landing event. The landing event, when you're landing with rockets anywhere, it's a very dusty, dirty affair. And so we had to protect her against debris on impact. We had to get rid of that debris shield, but we did. In fact, here's a great image we took just after dropping the debris shield on the surface of Mars prior to deploying Ingenuity from the bottom. And here is my favorite image thus far from the project is this one. The first ever image of a spacecraft on the surface of Mars from another spacecraft on the surface of Mars. This time flying, right? That's pretty cool. So, some notes on leadership or community, because these acts can be done by leaders of teams, but they can also be done by team members or any member of a community, right? It's really something that we can give to each other. First and foremost, the importance of sorting fact from opinion. That gets harder and harder the closer the facts get to the noise floor, right? When you're really trying to unpuzzle something that is statistically in the noise, it is a challenge. It can be important, as for instance our epidemiological public health issues have been over the last 2 years, but also very difficult. In my world, I've got different siloed individuals, people who look at a piece of the elephant, as it were. You know, I've got my mechanical subsystem, my telecommunication subsystem, my guidance subsystem, et cetera. And each of them see the challenge before us together as a team through different pieces of it. And it's my responsibility as a leader, and a responsibility that any member of the team can have to look outside your own stovepipe, look across at your other fellows' perspectives, to see compromise and to find a balanced perspective for which the team and the collaborative effort can move forward. Humans, us teams, we only succeed as teams. We're weird. As individuals, we might have a great idea, but if we really want to succeed, we band together in groups we call teams. And the success of the team is sort of the success of the product that the team is working on. They're directly proportional. You can't pull one from the other. You can't have a miserable, unhappy, non-collaborative team and get consistently great results. So how do you boost that collaboration? How do you have everybody comfortable to bring all of themselves into the work? Well, I use a technique based on selfishness, but it works. It is to find something to like, nay, love in everybody I work with. Now, I go to work when I'm going physically to work a lot. And virtually, I'm in contact with my team almost all the time. So I have a choice. I can look for something to be annoyed with my colleagues, and there's something always there. The way the guy puts his feet up on the table or smacks his gum, what the hell, right? Or I can look for something to love. something to connect with, something to appreciate. Well, I do the latter because I want to have a good time at work. And it works. I have a blast at work. But a weird side effect happens. They notice. They like it. They try it out on me. They try it out on each other, and pretty soon we're in a supercharged collaborative love fest. We're having a good time at work, and we're creating an environment where everybody feels comfortable to bring the most of themselves to the effort that we're working on. And then finally, something I've noticed from this virtual world that I've been in more than I ever was before. To really get the most out of a team, you've got to make space in the room, physical room or virtual room, for the team members to be able to bring their ideas out. And for me, especially in the virtual environment, I try and do that by talking less and listening more. I find that I learn a lot more by listening rather than by talking. So, what about the future? You know, we are going to come out of this. We are going to go make something new happen. What's it going to look like? I certainly prefer to think of the future as an opportunity for better success. I'm a positivist in that regard. And, you know, as long as we have the grit to deal with the disappointments, there will be. Spikes will happen. Changes in protocols will occur. Variants will spring up. But we'll find greater success. And one of the tools that we'll use to get there is our native human curiosity. Also the name of a nuclear-powered mega rover, right? We're on a streak. Perseverance, curiosity, ingenuity, these are, I mean, and this is not by design, I promise you, but it ends up being the kids of the world are good at grabbing essential human attributes that have meant our success as a species and given great names to spacecraft on Mars. Curiosity, I know a bit about curiosity, because curiosity changed my life. This image is taken from San Francisco, from the Marin headlands above the Golden Gate Bridge on the other side, the north side of San Francisco Bay. It's apropos because it's taken about a mile from the house I grew up in Sausalito. It's also apropos because of that star constellation sitting in the upper left of the image. You may not be able to recognize it. It's the constellation of Orion. I was a very poor student, terrible student, in fact, barely graduated high school. I graduated geometry class the second time I took it with a grade of an F+, because Mrs. Hunter really did not want to see me in the class a third time. So, after high school, I was playing rock and roll around the San Francisco Bay Area, not a particularly gifted musician, sort of hoping that lightning would strike and make me the next Elvis Costello, which would have been totally cool, but it wasn't going to happen. And one night, returning home from playing a show, I noticed that the stars were in a different place in the night sky than they had been when I went out to the show. I'd gone out and loaded in, they were over the east. I was coming home, they were over the west. And I was like, oh my God, the stars are moving. Clearly I'd missed that whole Earth spinning on its axis thing they teach you in school. My mind was blown, and I allowed myself to follow my curiosity about the apparent motion of the stars in the night sky down to local community college, technical college is sometimes called, 2-year institution, and take an astronomy course. It had a prerequisite of a physics course that I could take at the same time. But the title of the physics course said conceptual physics, physics without math. All right, I'll give it a try. Well, the guy who taught that course, a guy named Stephen Prada, took that spark of curiosity that I'd experienced about the apparent motion of the stars in the night sky and turned it into a fire of exploration that burned across my life and changed the course of my life and maybe even changed the way we land spacecraft on the surface of Mars. If Adam of yesteryear would have been told of what Adam of today's job is, his head would explode. But we never really know where our curiosity might be able to take us. It's a very powerful tool. When we explore, right, curiosity is the spark, exploration is the fire that burns from it. We're asking questions about ourselves as human beings. Who are we? How grand are we? We're looking for the edge of us. We're staring into the unknown of who we might be. I think Neil Armstrong appreciated that with the words he would choose to say when he'd first stepped foot on the moon. One small step for man, one giant leap for mankind. He was suggesting that he was carrying all of us with him, and that as he became more by the juxtaposition of that tiny footprint against the vast backdrop of space, we all became more. When we explore, we're asking questions of humanity. What are we capable of? Well, I've been thinking about this. Only since landing Curiosity. Before landing Curiosity, I was a dumb engineer, unbelievably lucky enough to be leading the most talented set of aerospace engineers to be assembled in the last 40 years. But after we landed and I watched people freak out, I started to wonder why we do this. And I've concluded that curiosity, it's in all of us. It's in our genes. That's kind of our bag, baby, right? We are born through hips too narrow to pass a fully human body, brain. We come here basically unprogrammed. We don't know to go south in the winter or look for worms under the shade of the alder tree, right? We come with very few lines of code. Perhaps one of the most critically human is be curious. And we all are. Before any of you could speak, you knew the difference between a solid and a liquid. You knew something about mass, distance, and time, all constructed in your wordless mind through exploration, driven by your native human curiosity. Whether you identify as being curious or not, you are. Now, a weird thing happens as we get older. The model we start to build at day one, at time t0 plus, it gets pretty good. I couple that to a little internet connectivity and a smartphone, and I start to believe that I know exactly the temperature it's going to be in Raleigh, North Carolina, tomorrow morning at 10 a.m., to within a degree Fahrenheit. I start to really anticipate that I know what the future is going to be. 2020 was a great wake-up call for me in that regard. Boy, I had plans. None of them happened. Now, if we keep our minds curious, a little bit like a child's, connected to our natural native human curiosity, they stay agile, much more innovative, and subsequently more competitive. And if we can take that attitude and put it with the perseverance we'll need to knock through these lumps and trickles that we'll get as the future goes on, these challenges that will be arise as we stare into an uncertain future, we have the opportunity to author a better future for ourselves. So what's next for NASA? Where will NASA's Curiosity next take it? Well, Perseverance is part of a big, huge, epic adventure called Mars Sample Return. It's the biggest thing that NASA's ever taken on. It's actually an international collaboration between ESA and NASA. It takes 3 individual missions to bring samples back from Mars. The first of those, Perseverance, she's on the surface of Mars. She's already taken a couple of rocky core samples and an atmosphere sample. But there's follow-on missions. Sample Retrieval Lander and an Earth Return Orbiter launched by the European Space Agency. Those are due to go up in 2028 and return samples in the early 2030s. And I'm currently the chief engineer of the whole kit and caboodle. But Mars is not the only place to explore. Europa, ice moon of Jupiter, a thin ice crust protecting a liquid water ocean more than twice the volume of all the seas on Earth. Now, I'm just an engineer, I'm not a biologist, but I drink beer with biologists. And they tell me the number one place for them to find life existing today, their number one bet, is in the waters of Europa. So I hope to help NASA put a lander on the surface of that ice and look for what evidence might have upwelled from underneath. So now I look at that beautiful fan-like structure. It used to scare the bejesus out of me that we could land on it successfully, or intentionally not land on the bits that we didn't want to land on. But now I look at it and it fills me with sort of anticipation. What awaits us in that delta? What does the future hold for all of us, really, on the back end of this pandemic? How can we take lessons that we've learned in working together virtually and physically, skills we've developed, the grit and determination, the perseverance to overcome the hard times? How can we take that and turn that into authoring, writing for ourselves a brighter future? Well, I wish us all luck, and I'm pretty positive about it. Thank you very much for your attention.
Thanks, Adam. Thanks, buddy. Awesome job. All right, Adam, thank you very much. Okay, so I want to thank all of our keynote speakers in this block. We're running just a little bit over. Sometimes happens, as you all know. Those of you that have been here before knows that maybe we're a little late at getting started, when we had a couple of technical issues, et cetera. So thank you for your patience. Let's see, Damon, can I bring up the image of the slide, please? Damon. Yeah, thanks. Yeah, sorry, I saw you, yeah. Anyway, that changed just a little bit. So I do want to encourage you to download the mobile app here on site, and that is how you can accumulate points if you want to play. Again, something fun we're doing this year. You can get points. By the way, the code, if you've already downloaded the app for this session, is just MARS1, M-A-R-S-1, MARS1. You can put it in the line associated with the morning keynotes, and then we'll do them. Each of our exhibitors out here have a code they can give you. And then I would encourage you as well to take a look at the prizes that we're giving away. They're super nice, ones that I would want to own, certainly. The next keynote block, the first breakout session block has actually already started, but our on-site speakers are going to wait for you to get there. They're actually delaying just a little bit, so the first block technically started at 10:45, but they're going to wait maybe 10 or 15 minutes on you, so around 11. Is when they're expecting you. So by all means, please go out, grab a drink, run to the restroom, whatever you have to do, and then make your way to the first block of breakout sessions. But thank you all very much. Yeah, I do. Yeah. Okay, hey guys, for everyone that's kind of stayed over, we're going to pull these air walls. That's actually what's going on right now, is the team at the convention center, they're going to pull the air walls. This area will become 3 separate breakout rooms. I should have said that during the keynote announcements. But ballroom A, B, and C. So our dev breakout rooms are going to be up here, and then DevOps is on the other side. So DevOps is in A, Dev1's right here, and Dev2's right there. So they're going to pull these air walls, and then we'll get our breakout sessions started immediately after the walls have been pulled. Thank you all.
And quick question, one more quick question. Okay. Everybody hear me all right? Beautiful. Oh, okay. Everybody still hear me all right? Great. So welcome to Why Testing is Hard, Estimating Impossible, and We All Feel Like Fraud Sometimes. We're starting the normal talks with something real light, just to get us warmed up. Sorry if this talk is a little bit heavy today, although it will not be heavy on the technical side, more on the emotional side. So first, who am I? I'm Fritz, formerly of the Vue.js core team. And before I got into tech, I actually didn't care too much about technology. I was mostly focused on education, psychology, linguistics. That was my training. That's what I did. And I got into tech because I wanted to build things to help me do those things better, to help me with my education mission. And I still, after I started earning most of my money from tech, I used it as a way to fund the projects that don't make a lot of money. I don't know if anyone knows this, but there's not a lot of money in education. So, and I still like to build tools to help myself and also help companies who are using those tools. This is me. I wasn't sure if I was going to have to wear a mask while I was up here. So I wanted you to be able to see my face. Fortunately, I can use my full emotional expressions. This is me in my pod. And we got through going outside a lot, you can see, playing a lot of puzzles. And like I said, like I warned, there's going to be some real talk today. We're going to talk about some things that are sometimes going to be a little bit comfortable, definitely very real, and I hope real in a way that you find helpful. I think it's only fair for me to be vulnerable first. I failed. I've worked for many years now as a consultant, international consultant, helping companies, often really big companies all around the world, with big problems, solve their technical problems on their teams. And I've also done a lot of workshops. With the consulting, I've been more successful, but in my workshops, to try to teach people how I do what I do when I'm consulting, because one of my values is to always make yourself redundant if you can. If I can make it so that people don't even have to hire me, then that's wonderful. I can work on more interesting problems. But most of the people who went to my workshops and learned about a lot of technical solutions that I offered for improving their estimates, for improving their processes, for improving their testing, when I followed up, some said, oh yeah, it's working great, we love it. We've never been happier. But most said, yeah, we didn't even really get to that point. We're still stuck. It didn't work. We never even tried the tool. We're still not sure what to focus on in testing. And that was hard. That was hard for me, figuring out what to do with that feedback. And when I looked into it, it turned out the reasons things were failing was not because the technical tips that I was sharing. And if you all came here for technical tips, I've got lots of talks online talking about technical tips for testing and things like that and estimating. So you can go see one of those. But in this one, I'm going to show you the stuff that I really wish that I had focused on first. before the technical stuff, which is the emotions. And before I go into that, I want to talk about what are the emotions that estimating brings up. And this is a question for you. So go ahead, raise your hands. If you are willing to be vulnerable enough, here with me and all of us, say, what are some of the emotions that come up around estimating? When someone asks you, how long is this going to take? Go ahead.
I'm totally not going to hold you to this.
Yeah.
Can you just dartboard it for me?
Dartboard it for you? Like someone asks you for, I'm not sure I understand the question. Like so you have a task, you're assigned a task, and someone asks you, how long do you think this will take? Is it going to be a day? Is it going to be a week? What are the emotions that come up for you? Yeah, go ahead.
Anxiety.
Anxiety? Anxiety too? Anxiety about what? What are you afraid of?
Wasting business resources and time.
Why do you care about wasting business resources? Because it makes what? It makes you look bad. And why do you care about looking bad? Because you might not get your contract renewed, so there's your physical safety might be threatened. Also, your relationships with your colleagues, with your boss, with a client. Yeah, go ahead. So you're afraid that you're going to give them a guess. And you're going to tell them, listen, I can't really give you a specific estimate. And then you're going to say, or they're going to say, well, just give us the number anyway. And I say, 2 weeks. It's but I really don't know. That could be way off. And then when it's still not done in 2 weeks, they say, why was your estimate so off? Yeah. And then you feel like you're being punished for giving them what you already told them you couldn't give them, for not giving them what you knew you couldn't give them and communicated that. And what about with testing? What kind of emotions come up with testing? Yeah, go ahead. Uncertainty? Yeah. Uncertainty and fear, maybe? Because testing is real hard.
And there's 1,000 things you can test, and especially when you're reporting to someone else, you don't know which ones they want you to test.
Yeah, where do we even start? You don't know what's going to break. Hopefully none of it. I mean, that's what you planned for. You didn't write code planning well, I think this will break later. I mean, maybe you think that, but you hope it's not true. And you try to code it so that it doesn't. So sometimes there are some pieces of code that you're worried about even looking at. You ever had the areas of your code where someone's saying, okay, so who wants to work on this services layer here? And everyone just kind of either looks down or looks at each other. And then someone finally says, I think Linda wrote that. Yeah, but Linda left. It's scary. And if you don't even understand it, and what it's supposed to do, because often that's not very well documented, how are you going to write tests for it? And you also might be fearing some, gosh, when I talk to some of my friends, they have some test frameworks that they're really excited about, and I want to be one of the cool people testing too. You also might just want to destroy the entire code base and quit your job. A lot of feelings come up, a lot of different, often conflicting feelings. You want to give, when giving estimates, for example, you want to give an estimate that's low enough that people think is oh, wow, that's great. That sounds wonderful. I mean, you want to please the people that you're working with. You don't want to say, oh yeah, I think that'll take 3 months, and they just look at you what are you, lazy or stupid? That would feel horrible. That would feel really horrible. So I think it's important to think of these problems first as emotional, then as technical. And I've resisted this so much, but I've learned it the hard way over and over and over again. Just like Steve Steltzner, NASA guy who was just here, he was saying you have to have teams that listen to each other. And part of that listening is listening for the feelings. Because we love and we want so badly to just have the right answer. But the truth is that all code is compromise. All code is compromise. Are you going to do 6 months of research to find the perfect library for this specific job? Or are you going to actually ship eventually? It's all compromise. You decide what you're going to focus on, how much you allow yourself, the different parts of you who want different things, to guide the direction to get you to where you want to be. And before we go any further, I think it's really important to define what are emotions. Like in cognitive science, when we talk about emotions, instead of using the word emotion, often the word dispositional representations are used. Because that's what emotions do. Emotions are some kind of representation that dispose you to particular kinds of action. So you come across this situation, some cues in your environment, in your body, and a little voice in your head says or just urges you with chemicals like, hey, let's go in this direction. Let's respond in this way. Let's just hide because we don't want anyone to assign tests to us. Let's fight because we're afraid that we're going to be in a situation where we're asked to test something and then we'll end up not being able to do it because it's scary. There's a lot of uncertainty. You don't know if you'll be able to do it. And it's really a separate skill set from normal development. And a lot of people outside of developers don't recognize that. Even a lot of developers don't acknowledge it. So it's important to note that every emotion evolved to direct you to action that either protects you from danger or guides you to opportunity. And which one do you think is more important? Which emotions do you think you tend to pay more attention to? The ones that protect you from danger or guide you to opportunity? And you can just shout out loud. Danger, yeah. Because if you dead, not a lot of opportunity. That's real important. You got to stay away from danger. And danger is not just survival. Danger is maintaining standing in your social groups. Danger is maintaining access to resources like money for your job so that you can have house and food and health care. So we like to think of ourselves as these, really stable, consistent individuals. But really, we're a bunch of dispossessional representations in a trench coat that are all arguing with each other, competing with each other, and being moderated by what are called critics in cognitive psychology, although I think that's kind of a weird name because it's not just critical voices, but deciding what to pay attention to. We really are a lot of different people, and you've probably had moments where you thought to yourself, wow, I wasn't even myself. You were yourself, just not that part of yourself that you're thinking of right now, that you're in at that moment. There are probably times when you've been mad in a meeting at a coworker with a partner, and you know you're wrong. There's a part of you that knows you're wrong at a certain point, but you keep on arguing, and there's another voice in your head saying, what are you doing? What are you doing? Just be quiet. Shut up. What are you? Oh my gosh, you're making it worse. What? Be quiet. I give up. Well, another part of you can't stop because they're scared. And they don't know how to meet that need except through this. And that voice, just telling them to stop, isn't offering them any other alternative to meet the needs that they're worried about, aren't even interested in the needs that that part is worried about. So typically, there are a lot of exceptions, but most people are not great at noticing conflicting emotions from different parts of ourselves, negotiating with those parts. Instead of just saying, shut up, what are you doing? Noticing it and saying, what's going on? What are you worried about? What's the fear? What's the concern here? What are you worried about happening? What do you want to happen? And having those parts negotiate with each other, which might sound a little bit strange, but it does work, and there's a lot of clinical work that shows very well that it works. And talking about emotions, there's a client, this is one of my favorite moments in I think my entire career, where I was doing some work to try to help him understand where, and to help myself understand where a lot of his fears were coming from, because there were some things I wasn't getting that were blocking us in the process. I wasn't understanding. There weren't any, as far as I could see, technical blockers, but there was something going on emotionally, like with him and with other members of the team, that I didn't get. And I recognized that as a danger sign. So I started asking him some questions about his feelings, using techniques that I'm going to show you later. And I've been doing that for a few weeks now, and we've been making a lot of progress. And apparently, he had been using the skills that I was modeling at home with his partner, because she came on the video call at one point and said, "Hi, I just want to know, who exactly are you, and how did you get my husband to start talking about his feelings?" Because this is a very logical guy. He's not the feely, touchy type. Now, why notice conflicting emotions? A lot of developers, I think, would like to think of themselves like this. I am incapable of any feeling. I just, stick to logic, and I think this is logically the best decision. And whenever anyone brings up emotion, they shut it down. They say, hey, let's just stick to the facts. Let's just stick to the facts. The emotions in the room are facts too. You can ignore those facts and not get very good results, or you can pay attention to all of the facts and get better results, because those emotions probably definitely are, telling you something important. They can tell you something important if you listen. And of course, if you do ignore emotions, what happens? Has anyone ever taken a beach ball, when they're out at the beach and they just push it way down underwater, and then you slip? What happens? Shoots right back up, hits you in the face. Emotions work the same way. If you try to push them down, they will shoot up and hit you in the face. I have a friend who, relatively recently actually, was just trying to work so hard, get all this stuff done, optimize all of his free time. whenever we would talk on a call or something, he'd say, "Yeah, I'm just trying to find, more ways to, is playing the ukulele really the best way to, get me recharged so that I can do more work?" And everything was in service of just doing more work, being able to do more, and he was treating himself basically like a machine. So he thought he was looking at his emotions, but not really acknowledging his humanity, that he needs more than just recharging so that he can get back to work. Sometimes you need to recharge just for yourself in 4 different parts, just to explore. And if you're paying attention to those parts, those feelings, you can tell when they're sated and you can tell when it's meeting their needs. But it's hard, that takes a lot of work. And then you end up feeling like this. That person ended up, I think at a critical moment in a sprint, just taking off sick for a week and playing video games. Because he was done. He'd hit his limits. He tried to optimize himself, treat himself like a machine, and then he broke down, like machines do. And started having a crisis thinking about, do I want to quit my job? Is my job the problem? I like the people I work with. I like the stuff I work on. Can I not just be happy doing anything? So how can you identify when you have conflicting emotions? This is pieced together from a bunch of different psychological models that don't compete and sometimes are reworded a little bit to fit together nicely. But I really like this chart. There are 3 kinds of major kinds of needs that we focus on. Autonomy versus connection. We want to be our own selves, but we also want to be close to others. We want to feel cared for. And we want to feel like we have others that we care for. We want to feel useful, valued. And there's power. We want to feel like, we're very competent. We can do a lot of things. And we also want to challenge ourselves. We want to go out and keep growing our skills. And again, for evolutionary reasons, this makes a lot of sense. You want safety, and you want novelty. You want to stick with the tech that you're used to, and you want to try out some new stuff. So why negotiate with parts? Has anyone woken up beginning of the day or maybe at the end of the day and just asked themselves in the mirror, why am I the way that I am? Why am I doing this? You don't have to answer. I know it's a very vulnerable question. I have. That's hard. That's the question you ask when you're not accepting parts of yourself. When there are needs that you have that you're not even allowing yourself to see because it feels dangerous to other parts to see that. And that is even adaptive. Probably in childhood or at other points in life. I'm not going to psychoanalyze everyone in this room. But, we learn these adaptations for a reason. We learn them from our environment. And they work, at least in some contexts. And then they can be used in maladaptive contexts because we don't have any better strategies. And then we end up empty. So to negotiate with those parts, my first tip is to give yourself time. Sometimes that's just time to breathe. I notice a lot of times when when someone says something that just like immediately activates me. Like there's some part, and it can take some time to develop that awareness of yourself. Meditation helps, going for walks helps develop that. When I feel activated, I try to automatically now, I've trained myself to just stop, like get a pretty neutral face, take a breath, gentle smile, and that gives me a little bit of time to think and observe what's going on without reacting. And of course, just giving yourself time during normal moments, like throughout your day, to just do nothing. If you're constantly receiving stimulation from Twitter and notifications, your brain isn't going to have a lot of space to observe because it'll be waiting for the next thing. I also often find it's helpful to name the parts and why they exist. A partner of mine used to name, this was more of a pattern than a part, when she'd suddenly start like yelling at herself and think like, oh gosh, I totally messed everything up. I made everything awkward. They should have never invited me to this meeting. Like I just totally derailed everything. I'm asking questions that aren't important, and everyone's looking at me like I'm just from Mars. And she has a little voice inside of her that sometimes tells her, you're a very small, bad idiot. And when you say it out loud, it sounds a little bit ridiculous. She got it actually from a review for an ice rink. Someone didn't like that ice rink and thought it was a very small, bad idiot. And just noticing that, like, made her laugh. And yeah, there's a part of me that's like really upset with me. What do they want? Like I think they don't want me to be embarrassed. They want me to like pay attention to the social cues of people around me, pay attention to their emotions and what they're needing. So yeah, let's do that. Let's do that. And you can re-regulate in a gentler way, noticing that. But still paying attention to the concern of that part. Any RuPaul's Drag Race fans here? A few? Okay, cool, yeah. I mean, it's great advice. You can't love yourself. If you can't love yourself, how in the hell are you going to love somebody else? You really have to pay attention to your own parts before you can even get to the communication part. Because if you don't have good relationships with your own parts, your own emotions, you're not going to be able to make space for someone else's emotions. What you reject in yourself, you will reject in other people. Now, why talk about emotions at all? What's wrong with avoiding conflict? If anyone's dating right now, like ghosting is really popular. That's the best way to manage conflict. Just never speak again without announcement. And we do something like that at work a lot too. How many times are there problems that just no one's talking about? With tests, usually people aren't having the conversation that like, yeah, we're all kind of scared that I'm not going to be able to write good tests. And then like we'll have wasted all that time. Or I'm scared that because the deadlines are really important in this company culture, that if I do tests, even if they said they wanted me to do tests, I'll get yelled at for it taking a long time. Whereas they might not even notice if the test isn't there. And if we don't talk about those things, we can't fix it. Again, a lot of people like to stick to the facts when talking about these technical problems. But these aren't technical problems, these are people problems. It's only a technical problem when people are not involved. So these are emotional problems first, and you have to pay attention to the emotions before you can even start talking about the logistics, the tech. A lot of people are scared, yeah, but if we're talking about feelings more, isn't it just going to be longer meetings? Like, Dave already goes on about his weekend for longer than I'd like personally, and no one stops him. It's like, well, if you were talking about your feelings, you could say, hey, Dave, you always have some really good stories about your weekend, but would you mind if we created a channel for weekend stories? Because sometimes I feel a little bit anxious that we'll get through the agenda, and I don't want to delay everybody in their day, and because I know they have other meetings and stuff like that. But I still want to make space for those stories. All those meetings are going to be a lot shorter from now on. And there'll be a space for Dave's weekend stories and anybody else's weekend stories, and they'll have places to talk about it and connect still. Once you start talking about feelings, you can get a lot more efficient. But how to talk about emotions safely? Because again, we're all afraid of it. That's why we avoid it. We avoid it and ghost people and just don't talk about problems. How many people have quit a job without fully communicating to their boss? Actually, I'm more curious about the opposite question. How many people who've quit their job, who when they quit their jobs, always fully communicate to their bosses about why they're quitting and all the problems they have with the company? Any hands? One. Most people don't, because they're afraid. They're afraid that it won't be received well, that it'll just burn bridges, that it won't make any difference anyway. So maybe if we had talked about our feelings, things could have been different. People often don't realize that. There's a dev I know who was really, really nervous about tests. He had never done any testing before, and he didn't want anyone to know that he hadn't done any testing because he thought it was just a normal thing that everyone should know how to do. I mean, he's a senior developer. He should know how to test. But he'd never done any tests before. Well, if you can't talk about it, you're just going to write really bad tests. I encouraged him to talk about it. He talked about it with his boss. And his boss bought him, gave him a stipend for whatever he wanted. I think it was up to $400 of course material and stuff like that and trainings. And then plus another conference that he paid for later to help him become more comfortable with testing and the specific testing tools that they were going to be using. It worked out, but he was afraid he was going to be fired. But it usually doesn't come to that. We're kind of trained that way. In school, you're given, when you do less than 100%, then you get a grade, and that grade haunts you forever, becomes part of your grade point average. Becomes a definition of who you are. In a job, it isn't really like that anymore, but usually our brains haven't really caught up. In most salary positions, they're not going to dock your pay. You might be fired, but usually only in extreme circumstances. Most companies have a lot of incentive to support their employees. So if you ask for taking half time off, additional resources, additional pairing, shorter meetings, and you do it in an emotionally intelligent way, you often get what you want. So my tip for this is Cravo. Cravo is not a robot designed for eating competitions. It's an acronym. And this is taken from a few different therapeutic models that have really high success rates, from everywhere between like couples therapy to organizational consulting. So first, clarify feelings with questions. Repeat the feelings to confirm. Acknowledge good intentions. Validate what you can. And own your feelings and role. And because we're starting a little bit late, I'm going to go through this a little bit more quickly than I otherwise would. But you can ask some questions, and I'll have my contact information at the end if you want to ask follow-up questions later. So for clarifying feelings with questions, it's amazing how often this step alone will solve a problem. I had one dev that was just really actively hostile to everyone in the team, including myself, but especially me. Really hostile to me. He didn't hire me, but I was hired to come in as a consultant the way he saw it because he wasn't doing his job. And he thought I was there to do what he couldn't. I was there because he was incompetent. That was his fear. I didn't know that. He wouldn't show up to meetings. He'd make excuses. He'd say he was too busy. Finally, I got him in a meeting, and he was ready for me to yell at him because he hadn't been operating. And I just said, "Is everything going okay?" And he just kind of broke. Because he's ready for a fight. He came there for a fight. When I showed genuine concern for his feelings, I asked, "Just everything going okay?" He said, No, I'm afraid they're going to fire me. And we got everything out in the open. And I told him, "Listen, my job is to make you look good. That's how I see it. My job is to make the developers I work with look good and feel good about their work. So how can I do that?" And we never had another problem again. He was great. He was so helpful. And he had so much valuable knowledge, we couldn't have done it without him. And he was ready to quit because he was afraid of being fired. Repeat feelings to confirm. It's important that we understand what the other person is saying. You can even repeat the same words back to them, but just making them feel heard relieves so much anxiety. You can see people's shoulders suddenly slump in relief when they tell you their feelings. They're not used to having their feelings heard, and you just say, "This is what you're feeling." Nothing else, no judgment, no additional commentary. And they just say, "Yeah, that's what I'm feeling." That's a tip that saved marriages. Acknowledge good intentions. Even when you disagree with someone, there was a case where someone thought that we should be 100% testing everything, when, we just realistically didn't have the time or the resources for that. But he kept fighting for it, and he was adamant. And I was in a position where I could have just overridden him and said no. But instead I said, "Listen, I know you want what's best for the team. When we have something that isn't tested, that means it might break. And we might not even know it's broken. And that's scary, right? So what are the parts of the app where that's scariest? Where can we start? Where can we alleviate the most fear? And what we did, as I've doing a lot of apps, is test the things where without that you don't have a business. Can users log in? can they give us money? Just testing those two things will save you so much peace of mind, give you so much peace of mind. Like, can they log in? Can they give us money? It's okay if they can't log out. I mean, that's a minor problem. You can work on that, but you still have a business at least if they can log in and get money. And validate what you can. Validate is very different from verify. You don't have to tell people they're right. If they say, can you believe Michelle is making us work like on this Friday, even though she said she was going to give us this Friday off? You could say like, yeah, you're right, Michelle's a jerk. You can verify their view of reality in that moment. It's probably not going to be helpful. It's just going to heighten their emotions. It's not going to resolve anything. But validating that it makes sense that they feel that way, it's like, yeah, I mean, you probably had plans for Friday. Like, you were looking forward to having that day off, and you've been working hard, to make sure you could get everything done before Friday. And now suddenly things have changed. Yeah, that is a problem. I think it'd be good to talk to Michelle about that, about how you feel, and figure out like how we can avoid this happening again in the future. Because, I mean, it sounds like it's worse than not having that day off in the first place, like not even being offered. And own your feelings and your part. A lot of people, especially developers, in conversations, they get very good at a lot of these skills, but they're say like, oh no, I don't have any particular feelings or emotions about this. I'm just pretty neutral and logical. And there's nothing more frustrating than someone not owning the feelings that they have and then acting passive-aggressively. Like, that'll bubble up, it'll beach ball into passive-aggressive behavior, which is especially dangerous if you're in a position of power over anyone. So own your feelings and your role. If they're mad at you, like let's say you're Michelle. Like, they start talking to you, don't try to defend yourself before. You can explain yourself, but don't try to defend yourself. And only explain yourself after owning your part. It's like, yeah, I wish that I had planned better and not offered that day off and then took it back. I don't want to do that again. Like, I don't want to play with your emotions like this and your schedules. Like, your schedules are important to me, and I just messed them up. And that's it. I hope I had some case studies that I was going to go into. I hope that can be enough. I don't think we have very much time for questions. But you can see these slides at slides.com/emotions. And if you have any questions, if you want to follow up with me, I'm happy to send you some resources. Like, I've tried to keep the sort of psychobabble low in this talk. But if you want some additional resources, like with specific research, like, this stuff is really kind of the tip of the iceberg. It was really hard to decide what to keep in this talk and what to keep out, because this is so deep. And just Cravo alone, you could practice that for the rest of your life. I think I will, and still learn new aspects of it and get better at it. And make sure the subject line is emotions if you email me, or else it will probably just get lost. And that's it. Thank you very much for your time.
Okay, cool. Hello, everybody. Can you all hear me okay? Sweet. Slides up. Does anybody deadlift here? Or do any kind of lifting? Okay, never mind. I deadlifted this morning and I hurt my back, so if you see me walking crooked, give me an ibuprofen. All right, so thank you so much for coming to my talk, everybody. I am going to be talking about getting started with GraphQL, specifically in an enterprise. In this talk, we're going to be talking about why GraphQL. I will be talking about our story of adoption of GraphQL from a PayPal's lens. I work at PayPal, and we adopted GraphQL there. So I'm going to be talking about why we decided to use GraphQL, what were the challenges we were trying to solve, our story of adopting GraphQL in the enterprise, and what were some mistakes we did, how you can learn from it, and if you are interested in getting started with GraphQL, how you can get started. Before that, I want to introduce myself. My name is Shruti Kapoor. I am a senior software engineer at PayPal. You can find me on Twitter at ShrutiKapoor08 or live streaming on Twitch at twitch.tv Shruti Kapoor. And if you're looking for somebody to work on your side project with you, you can come to the co-working sessions on Twitch. If you've been following me on Twitter, you know that I love dev jokes. So I'm going to ask you a question, 3 questions, and basically you can yell the answer out. So the first question is, why did the computer keep sneezing? It got a bug. Somebody else said something. I said virus. You're right. It had a virus. Okay, next question. What did the proud React parent say to its kid? Props. I've got to give you props. Okay, why do Node.js developers wear helmets? To secure headers. Okay, if you want to know more dev jokes, you can go to the GitHub repo. But let's get started with the GraphQL talk. I know I'm standing between you and your food, so I'm going to try to make this short. How many of you have worked with GraphQL? Okay, and how many of you have never worked with GraphQL, never used GraphQL? Cool, awesome. There will be something for everybody in this talk then. So when I started using GraphQL at PayPal, I actually had never used GraphQL before. I thought it was kind of like this API thing, but it used to work with Gatsby, so I thought it was like something to do with Gatsby. I know Facebook made it, so I thought maybe it has something to do with like data type graph. My role in PayPal was, when I started, was to work on an application, and the application was supposed to consume an API, which was a new API that we were building. The application was consuming some REST API, downstream REST APIs that already exist in the enterprise, and the application I was building was a Node.js app. In 2018, when I started working at PayPal, one of the main apps that was using GraphQL was Checkout app. Has anybody used PayPal Checkout? Awesome. So the app that powers PayPal Checkout is built with GraphQL API. In 2018, the support of GraphQL at PayPal was very limited. We did not have any internal tools, any central support. Every team was kind of building GraphQL on their own, so we're kind of venturing in the wild. In the community itself, GraphQL was slowly picking up. There was very little community adoption, but since then, a lot has changed. And if you look at the number of companies that have adopted GraphQL today and are using it in production, it's crazy. You can see all of the big companies are using GraphQL now. GraphQL landscape looks a lot different. We have GraphQL Foundation, which actually helps in maintaining GraphQL. GraphQL is an open source repo. And it is powered by different languages. So GraphQL is actually a specification, and you can implement GraphQL in any language you wish. GraphQL.js is an open source repo, which you can find here. But as you can see, there's a lot of people who are using it in production. And in 2020 survey, it was found that GraphQL is the technology that a lot of people are interested in. So if you want to learn GraphQL, this is actually a really great time to learn GraphQL. In the company itself, at PayPal, we are using GraphQL heavily. We have almost 50 apps that are using GraphQL in production. We also have a public API that is built by Braintree, one of our subsidiaries, that is also in GraphQL. And in our internal Slack community, we have over 500 members. Since 2018, we also built a lot of internal tools to help adoption of GraphQL in the company itself. We provided infra support to set up your GraphQL apps. We provided training materials. Now it's basically the default pattern for building any new Node.js app. And we are using it all across the board in all of our subsidiaries. But if you're sitting in the crowd thinking, what the heck is this GraphQL? Don't worry. Here's a GraphQL 101. So what does GraphQL mean? GraphQL, if you break down the name, it actually, graph means the graph type data structure. And QL means anything to fetch the API. So it's a query language for fetching the APIs. So by graph, you can think of your data's connection with different types of fields. So let's say you're building a library app. You have books, you have authors, you have titles. Title could be a string. So graph would represent how does a book connect with authors, titles, string, so on. So you're thinking of like the representation of data as a graph. So basically, GraphQL is a query language for APIs. And in fact, the definition of GraphQL is also that it's a query language for APIs and provides a runtime for fulfilling those queries. GraphQL is a specification. GraphQL provides a complete and understandable description of the data in your API and gives clients the power to ask for exactly what they need and nothing more. And I think that is actually a really powerful statement, that GraphQL gives clients the power to ask for exactly what they need and nothing more. I think that's also one of the biggest selling point of GraphQL, because it allows a UI or an application to ask for exactly the data they want, and they will not get any extraneous data. So if you think about how GraphQL works in comparison with REST, here's an example. Let's say that I'm building a homepage for PayPal.com. What I want to display is maybe the username, maybe their payment details, maybe how much money they have in their account, and maybe I want to show some notifications. So with REST, what I would have to do is, let's say that customer's account is the API I need to fetch for their maybe like payment details. There's a bunch of things that this account API would probably ask for, right? It could be the authorization, it could be the user ID, it may even internally call account details. And so what happens is, when you resolve one, maybe let's say auth came back and that gave you the ID. So you pass it down to other APIs. When they resolve, you get the whole object back, and that's when your entire endpoint resolves as well. And that's when you get the whole structure of the data that you needed. So there may be some fields like ID and token that the API requires, but you have no idea where to get it. So you have to go and explore the rest of the documentation, find which endpoints to call. Now with GraphQL, what happens is, let's say that with GraphQL, you only have one endpoint, the /GraphQL endpoint. All of the documentation would be here. Any of the IDs that you need would be here. So with PayPal.com/GraphQL, you'll send your request. And once it comes back, that's it. There's only one request that comes back. So the data is resolved right away. There's a few terminologies in GraphQL, so I'll talk about those. Four main things that we'll talk about today is schema, queries, mutations, and resolvers. What is schema? Schema is actually a full description of everything that your API allows you. So it describes completely the set of possible data type you can pass to the query, you can pass to the service. So let's say that I have a character type. It could have a name, it could have an episode. So this is how I'm defining my schema. So I'm saying I have a type character, and I may have a type starship. And then when I want to fetch something from the API, it's called a query. So I'm querying the API. The query kind of looks like this. So you'll have a query keyword at the top. And then here in the next lines, you're defining which field you want. So you're saying that I want hero, but out of that, I only want the name. And then I want the droid, And then let's say, this is Star Wars thing, so let's say that the droid's ID is 2000, a specific droid is what I want, and for that, I just want the name. So when you send this request to your service, you get exactly the data you asked for. So you get the name, and then you get the ID you get the specific name of that specific ID. So query, if you think about in terms of REST, it means it is kind of similar to get in REST. And the next thing is mutation, which is kind of similar to post and delete. So with the help of query, you saw we could fetch fields. With the help of mutation, you can also post or delete data from the API. Every field comes with a resolver. You can define a function that helps to resolve that data or helps to send back exactly what you ask for or do other sorts of operations or call downstream APIs. All of that logic sits in a resolver. Every field is given a resolver, so if you do not define a resolver, it's given to you automatically out of the box. So let's take a look here. Let's say that this is the query I have. This is the schema I have. So I've got a user, I've got given name, family name, and addresses. I can define the resolvers like this. So this is basically just JavaScript functions. I'll define everything for the user, the given name, family name, and I can do any sorts of filters that I want. So here, if you see given name and family name, this would be automatically given to you by GraphQL.js. So basically, in a nutshell, GraphQL is an open source specification. The main selling point is that it lets you ask for exactly the data that you want and gives you exactly the same data. And you can define the shape and the structure of the data that you want. And so that helps in actually reducing the amount of parsing you have to do on your UI. Another really cool thing about GraphQL is that because there is just one endpoint /GraphQL, there is no versioning. And if you need to add anything to the API, you can actually just add it to your schema. So like here on the left side, you'll see if you wanted to remove something, we'll add maybe like a directive next to it called deprecated. If you want to add a field, we can just simply add it to our schema. So there is no versioning. Now, schema is actually one of the main important things of GraphQL because it's kind of a contract between client and server. This is everything that a client can ask for from the server, so that's why schemas need to be established in the first, as a first thought. Well, one of the really cool things of GraphQL is actually the developer tooling that comes around with it. So at PayPal, why did we choose GraphQL? Well, we were having a few challenges at the time when we decided to move to GraphQL. Before diving into GraphQL, we thought of the architectural challenges we were having, and these are some of those challenges. So we had a lot of REST APIs and a lot of downstream APIs in our application, and what we noticed was that we may call an API, like account details, but let's say we only needed the name. But the API would send us back like 20 other fields, which would have to then throw away. So we had all this like waste data that we were getting from the client. We didn't have a way to like reduce the amount of data we could get. Another problem that we had, like I showed in the REST example, was we were doing multiple round trips. So maybe we needed an ID, maybe we needed a token. So we had to find like which API I need to call and then make a call to that and then come back and call my other API. So this makes it very slow to develop an application, but also just calling those APIs. Another problem was because we had so many different versions out in the wild, it was hard for us to know if clients were using the most updated version or if we could deprecate a field and nobody would get impacted. Sometimes some clients would be locked down to a single version, so they wouldn't get the updates because they wouldn't want to integrate again. Another problem internally as well was our APIs look kind of different from one subsidiary to another subsidiary. Also within the same company itself, within PayPal itself, we had so many different names. Something would be called like a username somewhere, something would be called like a user, something would be called an ID, something would be called token. So it was kind of very difficult to understand like which field goes where. The developer experience itself and the integration itself was very inconsistent. So when we were looking for a right candidate, some of the things that we wanted the candidate to provide us was, number one, uniform experience. We wanted that every client who was integrating with this API should see the same documentation, should have the same ID, the same names of each fields. Another thing was because we were developing these APIs for multiple subsidiaries like Braintree and Honey, we also wanted to make sure that It was easy for anybody who wanted to adopt this API to get started immediately. They shouldn't have to know anything in the background. They shouldn't have to know any of the enterprise knowledge. They shouldn't have to know about which API to call before this API. We wanted this to be like the source of truth. So it was very important for us that this API made it easy for clients to integrate with this API across the board. Another very important thing for us was because we didn't know which client with REST, we didn't know which client was using which field, or if we could deprecate it, or if we need to add anything. We wanted to make sure that this new API would have detailed analytics over exactly which field is being used, what kind of data people are asking for. And that's why I think GraphQL is really cool, because if you remember, we saw resolver. So every field comes with a single resolver. So we can know how many times a field has been called. And if a field has not been called, we can add deprecated to it and let our clients know that this would be going away. So we can intelligently deprecate and add fields. So when we were developing application, one of the common conversations we had around with our backend and front-end engineers was, let's say that we had a new request come in or a new user story come in, and we had to add maybe a new data to our API endpoint. Because we had versioned APIs, we were thinking like, how can I make it work with a versioned API? Should I add a V2 to this API? But the problem with adding that is it could be a breaking change. So if a client who's integrated with V1 now moved to V2, how would that impact them? We didn't know which field they're using, so we didn't know if it could impact them or not. Another thing was, if we do add V2, what happens to the clients who are integrated with V1? They don't get the new updates, so they're going to miss out on the new features. And we can't force clients to update their APIs. We can't force them to reintegrate with PayPal. Another thing we thought was, well, what if I can add query params to the same endpoint? Let's say I need to ask for more data. I could add new query params. That works when you have one or two query params you need to add. But what if you have to add like multiple parameters? Then you're basically polluting your query parameters. What if you add it to existing endpoint? Now you're impacting all of the clients that are integrated with it. So that's where GraphQL kind of comes in, and that's how it helped us. So the biggest points that it helped us with was there's one endpoint. So if you're integrated with GraphQL, even if you don't want the newest update, you can still be on the current version and you can still get whatever you need. But if you want the updates, it's out there. You just need to fetch it. You just need to query it. Just need to do a mutation. Because we don't have any more version APIs, we don't need to worry about whether our clients are outdated. They can get the new data if they want, whenever they want it. It was also really easy for us to intelligently add new fields or deprecate fields that were no longer being used. And as a client, as a front-end developer, one of the cool things that I really enjoyed was I didn't have to throw away any of the data I was getting back from the API anymore, because the API was giving me exactly the fields that I asked for. And so I didn't have to do any sort of parsing on my application. And that really helped us in one of our applications, because we didn't have to do any sort of like parsing or restructuring of the data, we were able to get rid of Redux even. As a developer, GraphQL was really cool. Anytime we showed graphical to folks, which is actually an exploration tool of GraphQL, people were like, oh my God, this is so cool. Because with that tool, you can see the documentation, and you can see exactly what the documentation, exactly what the query is, exactly what the mutation is, all of the fields that API is asking for, and you can also fire requests right away. So it's kind of like inbuilt playground with GraphQL, which was really cool. People really loved that. And it's also really awesome because if I do need to fire a different mutation, the documentation is right there. I don't need to look up any other application. So it's wherever, it's kind of like having Postman built in. It was also really cool because we have to think about schema up front when we build our application. So that basically meant that our front-end developers and back-end developers now started collaborating with each other in the beginning of the project itself. No longer were we building our APIs in isolation. No longer were back-end developers sitting on their own side and just working on their application, on their Java application, on the REST APIs, and then sending it out to the front-end. And then we wouldn't have to work with mock data anymore. So what was really cool was that front-end developers and back-end developers sat down together, established a contract was schema, And then we kind of went separately and independently worked on it. So it increased the collaboration we had in our teams. And so when we showed it to our developers, they were really, really excited about it because now we had one endpoint. We can push out our updates as soon as we want. We have field level instrumentation. We can deprecate and add fields intelligently. And we've got an established schema that brought our teams together. Now, there's a few different approaches of adopting GraphQL, especially in an enterprise that already has existing downstream REST services. I'm going to talk about 3 approaches here. So the first approach is to have a GraphQL wrapper over REST APIs. It kind of looks like this. So let's say that this is your client app, and it currently calls 3 different REST APIs. Let's say we're building PayPal.com homepage. So what you can do is you can have a GraphQL wrapper in between your client app and your REST app. So GraphQL is the one that is going to resolve all of the fields, all of the queries and mutations. And then GraphQL can do the job of figuring out which API to call. So basically, you can convert everything to GraphQL. Another approach is that you can have a REST wrapper over a GraphQL API. And this is specifically useful for clients that are tied to REST APIs that do not want to change their integration. So this way, what you can do is you can still have a GraphQL API internally, but you're surfacing a REST API on top of it. And GitHub does this as well. So you have a REST API that's surfaced to your client. Client doesn't see GraphQL API. They don't have to reintegrate. But internally, you can develop your GraphQL API. And another approach is that you kind of have to do duplication of work in this. It's not an ideal approach. So but what you can do is you can have your GraphQL API and your REST API coexist. And this works really good for systems that are kind of on a legacy system for one application, so maybe the REST API side, and then everything new is built on GraphQL API. So now let's start talking about how we started fitting GraphQL in our application in PayPal. We had a few different options of adding GraphQL in our applications. We did have new APIs that we were building. So we thought like there could be 2 approaches. One is we could orchestrate our existing APIs, convert them into GraphQL APIs, and let our clients talk to GraphQL. Another approach was that we could build anything that's new in GraphQL, and so build standalone APIs in GraphQL. Before we figured out and before we started plugging in GraphQL, there's a few things we wanted to know just to make sure. So one of the biggest things was how many clients are using the API. If we do orchestrate an API, it was really important that the impact was low, so we wanted to make sure that we are not using a high traffic API. Another thing was how many downstream APIs are we calling? And this was really important, especially if you wanted to orchestrate, because if your application is only calling one REST API, then you're not really using GraphQL's advantages. Then there's no advantage of converting your REST API to GraphQL API, because you're going to basically do a one-to-one mapping. Another thing was, what is the business impact? Can we reduce the amount of payload that we are sending? If we do convert this GraphQL API into a REST API, what application does it impact? If it's an internal application, it's a lot easier to convert or to take that time to do this migration from REST to GraphQL, because there's a lot of onboarding and learning involved for the team as well. And who are the stakeholders? Are the stakeholders people who use REST, so GraphQL would not work with them, or are the stakeholders internal developers and they are eager to learn GraphQL? And what is the time frame? So the app that we ended up choosing, the one app that I worked on was actually an internal tool. And one of the main goals we had for this app was to make it fast. And that's why GraphQL was really cool here, because we weren't sending a lot of data. We were only sending the data that the GraphQL client was asking for, and we had less code. So like I said, because we were not parsing data on our client side, we were able to get rid of some of the third-party libraries that were doing some parsing for us or state management for us. So because we were sending less data, there was less data to manage, and there was less code on the client. So what we did with this first app is we owned the backend REST API. So the REST API was also being built in parallel. It was a brand new API. So our GraphQL API was a completely plain orchestration layer. It did not have any backend, it did not have any business logic in it. All of the business logic lived in our REST API. We do have existing authentication APIs in PayPal, so we were able to use the existing REST APIs for that. And so what we did was our GraphQL layer was basically just like a thin layer, kind of like a proxy to call the rest of the downstream service. And the major one we were using was a REST API. So we found that GraphQL shines as an orchestration layer. If your REST API is sending too much data, if you can put a GraphQL layer in front of it, you're able to reduce that payload a lot. And so that's what we ended up doing. So the architecture kind of looked like this. So this is a client app which talked to the GraphQL API, which was purely an orchestration layer. It called the authentication and then called the REST API for business logic. So all of our business logic lived in the REST API, which then in turn called a bunch of other APIs. This REST API was brand new, was being built at the same time as the GraphQL API. This brought our teams together because we both talked about what API, what the schema would look like, what the UI would drive. And actually the GraphQL contract, the schema was derived by the UI's needs. So it was really cool because our UI was powering what fields the GraphQL should have. So it was a UI first approach. So what we ended up doing was we wrapped our REST API with the GraphQL API. The client sees and reaps the benefit of GraphQL. What was really important to that team was also that they did not want to implement a GraphQL API. They weren't completely sold on GraphQL. So this way, by having that REST API layer, they didn't have, the backend developers didn't have to change the way they were working. So everybody was happy. So basically, to summarize, this app, we created a GraphQL interface to orchestrate that brand new REST API. We delivered the data that our client asked for. The client drove what goes in the schema. It made it easier to evolve the API over time because our REST API was the one that held our business logic. Another very common approach that we have in the company is that any new logic lives in GraphQL API. And our checkout API, our checkout app is kind of like this. So the GraphQL API is the mastermind here and does the job of calling any downstream API it needs to do. One of the cool things about this is that if your REST API is sending a lot of data, this is where GraphQL can really shine because now you don't need to send, you don't have like that one-to-one mapping of REST API with GraphQL API, so you only send the data that your client is asking for. Currently, a lot of our applications are now defaulting to GraphQL, especially if they are powered by UI. Our mid-tier applications, which are the applications that sit between the client and the client's layer and the backend layer, they are starting to move to GraphQL as well. We are trying to move to GraphQL for our subsidiaries as well so that we can have this one layer, one GraphQL layer that all of our teams can integrate with. When we started moving, two biggest challenges that we had when we started adopting GraphQL was performance. And so GraphQL helped us with performance because our clients now determine what data they want, and we were able to deliver that data. But also they can also determine what shape of data they want, and that helps in reducing the size of the client-side app itself. Another big problem that we had was the dev productivity. It was really hard to find any API or the resource or documentation of our API, figure out which API to call next and where those parameters go. So with the help of GraphQL and the tools that it provides, it was really cool because now we could see and fire requests right away. And the explorability of docs was really cool because we had our documentation and kind of like our postman at the same place. So it was really cool to like fire requests, see documentation, fire our next mutation, and so on. And because we had really powerful instrumentation, really powerful field level instrumentation, it made it really easy for us to evolve our APIs over time. So what we did was we established a schema contract, our UI drove the schema, and we started building our GraphQL APIs at the same time as our REST APIs. So there were a few mistakes that we did, but a few lessons that we learned as well, which helped us a lot in this GraphQL adoption. One of the first lessons that I can give away is to pick your first app and to ask yourself some of those questions that we did, which is, what is the business impact? Who are your clients? Who are the stakeholders? How long how much time do you have to build this application? And because GraphQL shines as an orchestration layer, even if you're not able to get the entire company on board, that's still okay because you can orchestrate one API at a time. So if your team really wants to adopt GraphQL, but the entire company is not sold, that's okay because you can slowly orchestrate your APIs. Another mistake that we made, which is a good lesson that we learned, is not to do a one-to-one mapping of REST and GraphQL. So by this, what I mean is, let's say that you have your REST API and your client needs to consume exactly every single field from that REST API. So basically, everything that's in the REST API will be in the schema and the client will be asking for it. At that point, GraphQL is not a really good technology. It's not a really good use of GraphQL. You're going to have to basically duplicate your work. So don't use GraphQL for a one-to-one mapping if you have a REST API that needs to be consumed completely. And another cool thing is to build schema together. Because the UI can now drive the schema, it helped us a lot in bringing our teams closer, helped increase the developer productivity and collaboration between teams. And one cool thing, if you're not using TypeScript, is that GraphQL gives you type safety out of the box. So for us, it was really cool because we can now define in the query, in the contract, you have to define if a field is a string, is an integer, and so you get schema, you get type safety out of the box. But there's word of advice. GraphQL is not a magic thing. It won't solve all of your problems. Your API, GraphQL API, will be only as fast as your slowest endpoint. So if there is an API that takes too long, that's probably what you should address first instead of converting it to a GraphQL API. Another thing is that a lot of people don't realize that you'll have to think about the schema in advance. So if you are working on an application where you may not know upfront what kind of data the client may be asking for, GraphQL may not be the right fit because you have to develop that contract the first thing. There are still some challenges of GraphQL that the community is still working on. So if you have an application that deals heavily with caching or handling errors or parsing that error object to show a specific type of error, GraphQL may not be the right candidate for you because those things are still being developed. And like I said, you need to know the schema upfront. So maybe if you have something like a public API, where you don't know what kind of query, what kind of mutation the client could ask for, it will be very hard to build a GraphQL contract and a GraphQL schema that way. Another problem that we are specifically facing in our teams is that we have multiple teams that now have their own GraphQL endpoint. We're trying to move to a one graph approach, but that has been a challenge still, and we're still working on it. So working on a federated graph in an enterprise that big and getting everybody on board still is a challenge. So if you are interested in GraphQL, here are some next steps for you if you want to adopt it in your enterprise. First thing I would say is assess if GraphQL is the right fit for your architecture. So some of the questions you can ask yourself is, what are the challenges you have right now? Who are your consumers? What kind of data they use? How much data do they use? What kind of language they use? Are they tied to a REST API? Are you building a public API? Where are you going to put business logic? What about your authentications? Another thing is if you want to adopt it in your company, think about your company-specific things. So where are you going to put your analytics? What kind of analytics you have? Can you have field-level instrumentation? What about your monitoring? What about your authorization? Where are you going to put that? Do you need your schema or your queries to be tied down to a specific user or a specific permission? How are you going to implement that? So those things could be really helpful in understanding if GraphQL is the right fit for you. Another thing, like I was saying, is are you going to save any data by converting to GraphQL? So if your client is going to need to ask exactly the same fields that your REST APIs or your downstream APIs are doing, then you're basically not using GraphQL for its advantages. GraphQL doesn't really have a role to play there. Another thing I would say when you want to onboard your company and when you want to increase the scale at your company is how are you going to onboard new teams? How are you going to impart knowledge from one team to another, share that knowledge? How are you going to enforce standards? So type safety, schema definition, how are you going to merge multiple schemas together? So to get ready, for your enterprise, I would say start with maybe a dog food exercise. Maybe think of one small app that could be useful as an orchestration layer that could be used to convert to GraphQL. Maybe work with your clients, maybe work with your front-end teams and the back-end teams, get them together in a room, see if GraphQL really fits well for you. And then once you want to start scaling it up, once you have kind of gotten that yes from your team, so set a standards team, and this team will help enable different APIs and different type safety for your GraphQL layers. One of the things you'll have to start thinking about is schema stitching, which is when two teams have their own schema and they want to use, like, let's say common fields, let's say like username. How are you going to have those two graphs merge together? So you'll have to think about those. So set a standards team that can help you kind of onboard this and make it easier for other teams to also adopt GraphQL within your company. Also, one of the biggest things about GraphQL is because it's open source, there's tons of open source libraries and tooling available. So maybe do a little bit of research of what existing tools can you use. So now, if you want to sell it to your team, here are some things that we focused on that kind of helped sell the story. We focused on dev productivity. That was one of the challenges we had. If we can get our developers on board and if we can solve their problems, it's a lot easier to convince leadership. So once we showed them the graphical tools, the playground tools, how easy it was to explore APIs and call APIs and add new fields, it made it a lot easier for people to be convinced about GraphQL. And focus on incremental adoption. Oftentimes we think that the entire company has to move to GraphQL, but that's not the case. You can move to GraphQL one team at a time. So you can incrementally adopt your apps as GraphQL apps. Focus on the collaboration between teams. For us, this was a really big thing because our front-end developers and back-end developers, they were kind of working in isolation before, in silos before, and with the help of GraphQL, because we had to establish schema in the first place, it kind of forced everybody to be working together. Focus on the tooling that's out there. There's tons of open source libraries that help in the adoption of GraphQL. And one of the things that helped us was focusing on that there are no versions, so everybody is updated whenever they want to. And another cool thing is that because the data kind of looks similar to JSON, it's easy for new engineers and new developers to onboard onto GraphQL as well because it feels familiar. And one final thing I would say is that get your architects and your domain experts on board so that they can kind of help you find out, solve the problems of authorizations, of analytics, of monitoring. So get your engineers, get your architects on board as well so they can help you solve the business logic perspective of GraphQL. So there were a few questions that a lot of people had in mind when we were introducing GraphQL, and I think this may help you as well. Some common myths that are associated with GraphQL is that you need a graph type database, but you actually don't need a graph type database. Whatever you have right now would work. People think GraphQL is kind of similar to SQL, but it's actually a query language for your API, not your database. A big misconception is that it's only for front-end applications, it's only for JavaScript developers, but it's not. There's GraphQL in Java, Kotlin, Go. It's a specification, so you can build it in any language you want. A lot of people think that all of my services are in REST and nobody would want to move to GraphQL, which is okay. You can move to GraphQL one API at a time. You can start orchestrating. A lot of people think I have sensitive data, so it would be exposed to the entire public. But however you expose your data right now, that would still work with GraphQL. You just have to think about where it's going to fit in. But however you expose your data right now, that will still work. And another question people have is, can I limit what APIs are exposed? And you can totally limit what APIs are exposed. A lot of people think that GraphQL doesn't support auth, but you can fit in your authorization however you're doing right now. And a lot of people think that I don't want to expose my entire database, which same thing, you can limit whatever you want to do. It doesn't expose your database, it's just an API for calling the data. Okay, to wrap up, no technology is perfect. GraphQL is not perfect. It's not a magic wand that will solve all of your problems. But for the problems that we were having at PayPal, it was able to solve a lot of those problems. And so I would suggest when you want to adopt GraphQL, think about the challenges that you have and if GraphQL is the right fit for you. But I would also say that GraphQL is actually here to stay, and a lot of companies are starting to move to GraphQL. There's a lot more jobs in the community on GraphQL. So if you are interested in GraphQL, I would definitely give it a shot. And I would say get involved in the community. The power of GraphQL is the community that comes with it. And there's a lot of tooling in GraphQL that can help increase your productivity. We wrote another blog post on our PayPal Medium tech, on our PayPal Medium blog, which is a success story of PayPal checkout application that you all may have seen. You may find that useful if you want to adopt GraphQL in your company. And I'll leave the slide up for just 1 second, which is some success stories of other companies that have adopted GraphQL. And I would highly recommend, if you want to adopt GraphQL in your enterprise, Marc Andre's book, Production Ready GraphQL. It helps a lot. Finally, thank you so much. If you have any questions, please feel free to grab me around. I'll be here. Or you can send me a DM on Twitter. All of the slides will be available here. I will send a snapshot of today's talk in my newsletter as well, bit.ly/Shruti newsletter. Before I go, I want to leave one final dive joke. Thank you so much, everybody. You've been great.
Yeah, please. Yeah, I think so. All right. I think we're going to go ahead and get started. So I am back. If you were here earlier, you may have seen my earlier talk. And this is kind of an extension of that talk, going past like the ideas and philosophy and all the different ways that people are building apps and actually showing how to actually build one of these decentralized apps, and maybe going a little bit deeper into some of the web infrastructure stuff that I touched on earlier. And really the main thing we're going to cover today is kind of what are all the different pieces that are out there and how do you actually get started. And I'm going to live code from scratch a full stack app using a stack of technologies that I'm going to cover in this talk. So to introduce myself again, my name is Nader Dabit, and I'm here to talk about how to build a dApp. And we're going to be, again, covering a few of the things that I covered earlier, but maybe a little bit more in depth on the actual coding part. And I'm going to touch on some of that stuff for the first 5 minutes, and then we're going to be getting into probably a lot more new stuff. So when the title of the talk is how to build a dApp. Well, dApp is just short for decentralized app, and it's just an acronym that you'll hear a lot. And it's essentially kind of building an application and using decentralized technologies to do so. Now, I've been a developer for like 9.5 or 10 years, and coming into this space from AWS, I typically was thinking of what are all the pieces that I need to build an app. And at AWS, that was going to be something like I need Cognito for identity, I need DynamoDB for my database, I might use Lambda for my compute. And that's kind of mentally the way I thought about building an application. You have all these building blocks, you put them together, and you're able to achieve the functionality that you want. Now, with decentralized applications, it's kind of the same thing, but the pieces of infrastructure are much different. And there's also a spectrum of decentralization. So you don't have to kind of build an application that is fully decentralized, or think of it like, when you're building these types of applications, like everything needs to fall into this category. I think what you're seeing is people kind of taking bits and pieces and mixing them together, and they're coming up with interesting new ways to build applications. A lot of people kind of look at this space and they are like, oh, these things don't make a lot of sense for all of the use cases, and they're absolutely right. In fact, most of the applications that we think of today probably would not implement these technologies. Instead, people are coming up with new, interesting types of applications that we've not really seen before. And that's really the things that kind of excite me the most and really what kind of keep me going, I would say, day to day in this new space. So the way I defined Web3 before is a stack of protocols that enable fully decentralized applications. And that's what we're going to be diving into a little bit more today. What are these different protocols and how do they work? And then I also kind of defined Web3 as this combination of all of the different stack that we had in the past. And then we're also adding in smart contracts, which enable these native payments in native state. And what we're going to build out is a really basic application that implements some of this technology. I kind of covered some of this earlier as well, but so the characteristics around a Web3 application have a lot to do really with this set of characteristics: decentralization, self-sovereign identity, native payments. Really, a lot of the stuff that I'm most interested in have to do with this idea of being able to take existing backends and let developers build out different experiences on the front end. So we really kind of go from having these proprietary backends that only certain people can interact with and build upon to really kind of having this idea of an open source backend that anyone can build an application on. So we're going to dive a little bit more into the web infrastructure pieces because I kind of went over these very, very briefly earlier. We're going to go over them a little bit more in depth here. So in a typical database like DynamoDB or a NoSQL or a MySQL database, these databases are optimized for two main types of operations, reading and writing. You can kind of look at different metrics around how many operations per second, how much latency a read takes. When you're doing relational data with MySQL or NoSQL, you kind of have all these benchmarks, and therefore you're going to kind of move and grab the type of database that you would like to use to build the type of application that you would like to be building. And there are different people that really like the NoSQL way of doing things. A lot of people like SQL, relational data, and things like that. But in the blockchain world, it's a lot different because databases are not optimized for reads. They're only optimized for writes. So when you hear about different protocols, they're typically focusing on how many transactions per second can a protocol handle. So when you think of something like Solana, for example, it's been really popular because it can handle 500,000 or so transactions per second, and therefore it is very scalable compared to other databases that are blockchain databases. But maybe not compared to something like DynamoDB, which is a lot more scalable than that. But all of the conversations really have to do around how many operations per second can we write and how efficient those operations are. But one of the things that aren't really covered out of the main implementation of a blockchain is how do you read this data? Because this data isn't, again, queryable. It's written over time in the course of days, weeks, months, or years in these blocks. So if you want to get a really, really simple query, you want to read a piece of data at a certain point of time, it's really easy. But if you want to do anything like relational data, or you want to do some type of computed data, you want to do some query, getting a relationship between friends and friends' friends or something like that, it's just not possible. So what people have done in the past is they build out their own indexing servers, which go and get that data, store it in the database, and they build their own API layer on top of it. But this kind of breaks the security mechanisms around decentralization in the first place, and you kind of go from wanting to build a decentralized application to now centralizing your data, and also you're having a single point of failure, which is kind of defeats the whole purpose. So one of the protocols that is out there, and the one that I work with, is called the Graph Protocol. And the Graph Protocol is a protocol that allows developers to participate in a decentralized network in a few different ways. You can be a node operator and index data and serve it up via an API endpoint. You can be a developer that creates these APIs called subgraphs and deploys them to the network and allows other people to use them and consume them. And the network was built not only by the core team, but it was built by people all around the world. So during the development of this protocol, people from South America, from Asia, the United States, all over the world helped build this. And when the protocol finally launched, they shared the ownership of the protocol by distributing tokens, and a lot of people were able to essentially kind of help build this and help own it together and make a living off of it, which to me is pretty interesting. But yeah, this is kind of like one of the pieces. If you want to do now querying for some type of blockchain data, you might use something like the graph. Another piece of the infrastructure is when you're dealing with data that is not on-chain. So only certain types of operations are typically going to be written to a blockchain, because when you have a transaction, you typically have to pay some transaction costs. That's why you see most blockchain applications right now being some type of financial applications, whether it be artwork or whether it be some type of decentralized finance or something like that. But if you do need off-chain data, you can still build in this way. And there are a couple of different options. One of them is a ceramic network. And this is a really interesting way to deal with off-chain data, but also they have a protocol that allows you to deal with self-sovereign identity called IDX that kind of work together, that I'll cover in just a moment. Live streaming. So LivePeer is a live streaming network that allows you as a developer to build live streaming services like Twitch-like experiences. And it is very inexpensive. And it also runs on a decentralized network of nodes. And you can basically spin up your own live streaming platform using LivePeer. IPFS and Arweave are ways to deal with file storage. So in the traditional web space, you might use something like S3, or you might use any version of something like S3, I guess you could say. S3 is definitely one of the main ones people use. But let's say you want to store an image or a video or something like that. IPFS and Arweave are kind of the two main ways you might do that in Web3. IPFS is free, and it typically is not guaranteed to stay there, though. Which is interesting, right? Because if you want to upload something, you want it to be there for a certain amount of time. Now, you can use something like an IPFS pinning service, which guarantees that it stays there for a longer time, but it doesn't guarantee that your file will be there forever. Arweave is interesting because it guarantees pinning forever, and it's not really called pinning, it's just lifelong file storage. So if you want to store a blog post and you want it to be there forever, you can use Arweave. You pay that transaction cost for 1 megabyte of text, it's around 3 or 4 cents, and then it's there forever. So instead of having to pay like a monthly or a yearly hosting fee, you can have an API that stays there essentially forever. And what a lot of people do is they kind of combine these things. So you might use something like a blockchain to anchor an ID for a blog post, and then that ID would be fetched from something like Arweave, and that way you're kind of only storing the least amount of data possible, and you're storing it kind of in the right ways. We're used to the implementations of Git being centralized, even though Git itself is decentralized, but most of the time we're using something like GitHub. Well, Radical is interesting because it is a decentralized Git provider, and you can use it just like you use your own Git that workflow that you've probably used forever in your own day-to-day experience. And then the one thing we're going to be looking into and implementing today as well is sign in with Ethereum or sign in with some type of Ethereum wallet. There's a handful of different wallets that are out there. Solana has a really nice one called Phantom. With Ethereum and similar EVM networks, you can use MetaMask and Rainbow. And these wallets allow you to just be able to sign in without handing over any of your personal information using public key cryptography. So when you create a new wallet, you're given a seed phrase. Using that seed phrase, you're able to derive mathematically a private key, and then using that private key, you're able to derive a public key, and then that public key derives your address. And using all these things together, you can actually have portable identity wherever you go. So let's say you want to have this same identity on your phone or on a new computer. All you need is that seed phrase to re-enable that identity, and from there you're able to interact with all the applications that you're probably used to interacting with just maybe a single click. And we're going to be implementing this in just a moment. And then for identity, if you want to kind of go past really basic authentication, and you do want to implement something like we're used to where we keep like a user profile, you might want to keep your username or even a profile picture, you can use something like IDX. The main difference is IDX only allows you as the user to update the metadata, and you only can update the metadata that you would like to share. So if you don't want to share your phone number, your address, your email address, you don't have to put any of that stuff and store it. You can just store the information that you want made available. So most of the times you would use something like IDX for an e-commerce application where you want to point to a profile that does have some of your personal information, like your shipping address or something like that. So the implementations of Web3 applications are kind of listed here. The ones that interest me the most are definitely the decentralized web infrastructure protocols and the DAOs, I would say. I work at a company that supports a lot of this stuff here, but the main thing we really work on is decentralized web infrastructure protocols. So you could think of the Web3 stack as kind of the old school web stack where we have compute, identity, data, storage, et cetera. And we're now just using these services, but making sure that we try to find decentralized versions of them. And we now have this added smart contract layer, which is something we did not have before. So how do you actually build one of these applications? And this is what we're going to do here now. Well, to get started, the bare minimum, you typically would need something like a front-end framework. You want to choose what type of blockchain you want to build on. Anything that supports a smart contract is something that would kind of fit into this category. You want to choose your client library. So in the front-end world, we might use the combination of something like GraphQL with Apollo, or we might use something like Fetch with some HTTP endpoint. In the Web3 space, we have similar client libraries. Instead of interacting with an HTTP endpoint or a GraphQL endpoint, you're interacting with an RPC endpoint. And you have different options. And we're going to kind of look at the ones that I like the best. And then you have the blockchain itself. So coming from the React and JavaScript world, one of the things that I found really powerful is this idea of learn once and write anywhere. So with React, you learn JavaScript, you learn React, and you can build mobile apps, web apps, desktop apps, watch apps, all kinds of stuff. Well, there is a similar idea in the blockchain world, and it's probably the easiest way to get up and running, and they're hiring these Solidity and EVM developers like hotcakes right now, because if you learn EVM, which is the Ethereum virtual machine, you can write applications for Ethereum and all of the Ethereum layer 2s, and you can write for Avalanche and Celo and all these other blockchains that are kind of like gaining momentum. So you can kind of think of it as the network effect that we've seen with JavaScript kind of happening in the decentralized world, where you can learn this one suite of tools and technologies, and you can build across many different areas. And that's what we're going to be focusing on today, EVM and Ethereum. So again, EVM stands for Ethereum Virtual Machine. A lot of people have taken this Ethereum Virtual Machine and applied it in their own protocols, giving developers the exact same API that they can use. And for the development environment, we might have used something like Next.js as a great abstraction on top of JavaScript and React to give us more things that we can kind of get going with without having to build all this stuff from scratch. Hardhat is really great because it kind of does this for the blockchain world. You start off with a front-end application and you initialize a Hardhat app, and you're given a smart contract, you're given a local Ethereum node, you're given all this stuff that you can start writing code for and kind of get up and running in just really a couple of minutes. So we're kind of starting off with this really basic stack. Our client framework is going to be React or Next.js. Our Ethereum development environment is going to be Hardhat. Our client framework is going to be Ethers.js. The two main client frameworks for interacting with Ethereum and Ethereum virtual machines are Ethers and Web3.js. So either one of those seems to be pretty popular right now. And then for the wallet, we're going to be using MetaMask. So let's go ahead and start off with a live demo. So what I would like to do here is I'm here in a React application. And I'm going to go ahead and open this app in my text editor. And the only thing I've done so far is installed a couple of dependencies. So we have a basic React application, and I installed the dependencies necessary for Hardhat. I haven't initialized a Hardhat environment yet. I just have installed Hardhat and the corresponding dependencies that you can find on their website. So what I'd like to do now is just go ahead and initializing my development environment. So to do that, you can just run npx Hardhat. You don't have to install anything. You can just use npx, and it will go ahead and fetch all of that stuff for you. And it'll walk you through whatever you need to kind of get your project set up. So here I can say create a basic sample project. I can choose the default as the project root. And then I can, of course, just choose yes to git ignore. And then now we've created our development environment. So if I go back to my code base, I can see now I have this contracts folder. The contracts folder holds a smart contract. We have a scripts folder, which holds a script to deploy the contract to the network. And we have a test, which is just a basic test for us to test our code before running the actual code itself. And then we have our Hardhat configuration. And I'm going to delete almost all this code because we don't need any of it. This module.exports really just defines your development environment. So anything that you need set up here, you can kind of put it here. So we're going to start here. And the thing I want to go ahead and set up is our artifacts directory. Now, when we're working with something like GraphQL, we use GraphQL queries, which are query definitions that are typically written, in plain text or something like that and stored somewhere within our project. If we're using a REST API, we can just hit a REST endpoint. But with GraphQL, you need some type of query to kind of define the post that's going across the network. There's something similar with Ethereum and most blockchains. When you're interacting with the network, you typically have something called an ABI, or an application binary interface. And you can actually extract an ABI directly from the contract once you compile that contract. The great thing about Hardhat is that all you need to do is just define the artifacts directory. You can run a single command. It will go ahead and compile all that code for you. And then the other thing that we're setting is the chain ID. Because we're working on localhost, we're not going to be deploying to a live Ethereum network. We want to tell the network which chain ID our MetaMask wallet is using. And by default, the localhost is set to 1337. So this is more like a local configuration that we typically just have. So we've set our configuration. We're now ready to look at our smart contract. So here we have really the hello world of Solidity. And I'll walk through some of this. The main code right here is kind of in the contract greeter. This is very similar to something like TypeScript, though. If you've ever read TypeScript, this should look very familiar. We have two main functions that are happening, and then we have a constructor. In the constructor, we're taking in an argument where we're setting an initial state. The state is greeting, and whatever we pass into that constructor is what gets set as that initial value of greeting, and this value gets set when we deploy the contract. We then have a function to return that greeting. So we just call this function, it returns that value. And then we have a function for updating that greeting. So when we call setGreeting, we pass in an argument. That argument changes the state. This is a transaction on chain, meaning we have to actually pay for this transaction using gas in some way. So here we have a really basic hello world, but I think it's a really great getting started point, and we're going to build a front end on top of this. So now that we've checked out our contract, we can now compile our contract if we'd like. So to do that, you can just go to your projects, and I'm going to split my windows up a little bit. I'm going to be here in the top left corner, and I'm going to run npx hardhat compile. And this is going to look in our contracts directory, and it's going to compile our ABIs that we can now use in our front end. So if I go back to my project, and I look in the SRC directory, I see I now have this artifacts directory. And here I have everything I need to not only deploy the contract, but also to interact with it. All right, so we've created our contract, we've compiled it. Now we want to deploy it. So how do we actually deploy an application? Well, a long time ago, we'd upload it to FTP, right? Throw it in a folder, and then it starts working. And then now we're we're much more advanced than that, of course. We might use some of the nice tooling that we have these days, like Amplify or like Vercel or something. But in the Ethereum blockchain world, you're actually writing a transaction to a network whenever you deploy an app. So you're kind of like taking your code and you're writing it to that network, and it's now on chain. So to test that out, we can just run a local network, and it's pretty easy to do that using hardhat. We can actually just run npx hardhat node, and this will create a local Ethereum node, and it will give us 20 different addresses that we can use locally with 10,000 Ethereum each. So we're pretty rich at this point. So here we go with this account number 0. It gives us 2 values. It gives us the account address and the account private key. So using this private key, we can actually import this account into a wallet and start testing it out in our browser. So let's go ahead and do that. So I'm going to go ahead and open Google Chrome. And I'm going to go right here. And I'm going to go to my MetaMask. So this is kind of like the wallet. This is one of my wallets. I also have Phantom. This is for Solana, just to kind of give you an idea what this stuff looks like. And what I want to do is I want to import one of these accounts. So to do that, I can go to Import Account. I can paste in the private key. And here you see that we now have 9,999.9994 ETH. And I believe this is actually, yeah, this is right, because, let's see here. I'm wondering why this isn't actually 10,000 ETH, because we haven't done anything. So let me try to remove this and then add it back. Either way, we're going to keep going. So let me go ahead and import this again. Yeah, so for some reason we have 9,999. I'm going to figure out why that's not 10,000 in just a moment. But anyway, so we're able to like import these accounts. So if I wanted to import another one, I could do that as well. Let's see what's in that one. Oh, okay, I think I know the problem, yeah. Let me switch these networks. There we go. Okay. Now we have 10,000 ETH, which is right. Okay. So now that we have our local node running, we can actually deploy our application to that node. So let's do that. And to do that, we can run a deployment script, which is also written in JavaScript, which is nice because I'm a JavaScript developer. And we're given a sample script by the hard hat development environment already. And I'm going to delete almost all this code. And we're just going to go, or I would say comments. We're just going to go to these 4 lines of code here. Now, the first line of code is going to go ahead and fetch the location of the ABI. We know where that ABI is because we defined that configuration in our hard hat config. So since it knows to look in the src directory, it can just look for the ABI named greeter. And now it has a reference to that ABI and that contract, actually, both things. And then we're going to go ahead and deploy that by saying, once we have a reference, we're going to call the deploy function on that. We wait for that deployment to complete, and then we log out the address because we're going to need that address. Because just like in an HTTP endpoint, we need the HTTP URL. In an Ethereum project, you'll need the RPC endpoint along with the address of the contract that you want to interact with. And we're also passing in an argument to deploy, and this is going to be that constructor. So whatever was set in that constructor, we can pass in as an argument here. And this will go ahead and update that local state in our contract. So to deploy this, we can go again back to our terminal, and we can run npx hardhat. And I want to rename this script to something a little bit better than sample script, so let's just call this deploy. And I can say run scripts/deploy, and then I can just set the network to localhost. And what we should see happen is greeter deployed to, and then given our address. And then down here, we should see that we have some stuff that's been logged out. So that means we have created our contract, we've started our local node, we've deployed to that node, and we now want to interact with that contract from our application. So to do that, I will go ahead and run npm start. And we're going to start off with the really, really basic app with not a lot going on. So you might have seen this before if you're a React developer. You just have your hello world. So the first thing we might want to do is how do we get access to this user? Because authentication is hard, right? We have to kind of let the user sign up. We have to create the service for all that stuff. Well, it's actually pretty easy in Ethereum. All we need to do is get access to this account that is in their wallet. And now our Ethereum has gone down because we paid for that transaction. So we have 0.00004 less than we had before. So to do that, I'm going to go ahead and open src/app.js. And we're going to create a function that allows us to access that user. So I'm going to go ahead and create a function that calls window.ethereum.request. When someone has a wallet installed as an extension in their browser, the browser automatically injects a window.x context. In our case, it'll be window.ethereum. If you're using that Phantom wallet for Solana, it'll be window.solana. And once we can check to see if that window.ethereum is there, we can then request that user to go ahead and give us their address. You can also do null checks here, so you might want to say if window.ethereum, whatever. But since we know that the wallet is there, we can just call await window.ethereum.request, ask for their accounts, and then we'll log out the accounts. This will be an array because you can give access to more than one account, and then we'll just log that out. And then we will create a basic button. And this button will just call that function. So this is a really, really simple authentication flow to get us started. So if I go back, we see that we have this connect wallet button. And I'm going to go ahead and open my terminal as well. And here we should be able to see the user. So if I click connect wallet, we see that this pops up. We're able to choose the address that we'd like to authenticate with. We click connect, and then now we log out the accounts array right here. So we've gotten access to that user. What we now want to do is get access to that user's wallet and send a transaction and interact with our application. So the next thing we might do is we want to allow the user to type and save a message and update that greeter message that we kind of set when we ran the deployment script. So I want to go ahead and import some stuff. We're going to import use state from React, which allows us to deal with local state. We're going to import the Ethers library from Ethers, which allows us to interact with the Ethereum network. We're going to import the ABI that was compiled in the artifacts directory, which is, again, something we're going to need to interact with the network. And then we're going to define the greeter address. And this should be the deployment address of the contract that we deployed a second ago. So if I go here and copy that, I should be able to just use it like this. And you can dynamically do this, of course, if you just use file service or something like that. So we have all this set up. What we want to do next is set some initial state. Let's see here. The state that we're going to be working with is a variable called greeting and a function called setGreetingValue. Maybe we'll set that value to an empty string. And this will allow the user to use a form to kind of update whatever that greeting is going to be. We want to have a function for fetching the greeting. And this is where we are going to interact with the network for the first time. And all of that really is happening in these lines of code here. So the first thing that we're going to do is we're going to get access to that window.ethereum context, and we're going to create what's known as a provider. And the provider allows us to set a variable that we're calling contract that allows us to speak to that contract that's been deployed on the network. And the three arguments that we need are, what is the address for this deployment? What is the provider? And what is the ABI? So we pass all of those three arguments here, and we can now call all of those functions within our contract directly from this variable. So any read operation we can pretty much do right here. So what we're doing here is we're going to go ahead and just request what the greet value is right now and then log it out here. So this is how we read data. How do we write data? What we're going to do next is create that write transaction. And this is going to be in this setGreeting function. We do everything maybe in these lines of code here. The first thing we do is we go ahead and create a provider like we did earlier, but instead of passing in the provider to the contract, we're now creating a variable called signer, because when you need to send a transaction across the network, the user has to authorize that transaction, and they need to sign that from their wallet, and it will cost them some amount of money to do this transaction. So we get a signer, and instead of passing in the provider to the contract, we pass in the signer. And then we wait for this transaction to be approved. So we're going to call setGreeting, and the user then gets prompted in their wallet to approve that transaction. Once that is approved, this continues to run. And from there, we just call fetchGreeting again to kind of get that updated greeting. So now that all of that is done, we can update our user interface to have a couple of buttons, one for fetching the greeting, one for setting the greeting, and one for allowing the user to type in the updated greeting. So what I should be able to do is save this and go back to my code. And if I click fetch greeting, we see that hello hard hat is there because that's what we passed in when we deployed our contract. So I should now be able to go ahead and set this value here. And now we're prompted to confirm the transaction. And now our data is coming back, hello, all things open. And if I refresh and click fetch greeting, we see that hello, all things open is there. So everything is working as we expected. So with that being said, that's kind of like the most basic full stack hello world you'll see. But I think it is a great getting started point. In fact, a lot of people have kind of taken this demo tutorial just to kind of get their feet wet, and they realize whether or not they even think this is something they're interested in working on. So it's a great getting started point to kind of not spend a ton of time, but still fundamentally understand what this stack feels like and what it looks like. If you want to go a little bit further than this, there's a really great project called Scaffold ETH by Austin Griffith. There are over 200 different repos within this repo. I would say branches within this repo, I guess. And each branch is a separate type of implementation of a Web3 app. So you have everything from finance to gaming to DAOs and really, really cool stuff. And it's all full stack. So you get the front end and the back end and the smart contracts. And it's really just a wealth of information, and it's really interesting just to go through and look at all the stuff that's there. And it's not just built by him, it's built by a lot of people in the community. There's also Anchor. So if you're interested in not looking at Ethereum development, but you want to look at Solana development, which is starting to become a lot more popular because of a bunch of reasons, mainly because it's already running on an environmentally friendly consensus mechanism, and it's not waiting for a merge. But also, the transactions are faster and cheaper on Solana than they are Ethereum. Anchor is a really great version of what Hard Hat kind of is for Solana. My guide, the complete guide to full stack Ethereum development, is something I wrote that's been read a little over 250,000 times now between my blog post and my video. A lot of people seem to like this. It's a little more extensive than what we did in this getting started talk, but the very initial principles are actually done there, like that greeting contract, but then we go a little bit further into how you send monetary transactions within the smart contract, sending money between parties and stuff. So yeah, that's it. I hope you learned something and enjoyed that. I finished a little early, so if you have any questions, I would love to answer your questions, so feel free to come find me anywhere in the conference. Yeah, maybe I can answer some here. Sure? Oh no, they're all free. Yeah. Any other questions? All right, cool. Thank you so much.
Good to go? Okay. Thank you, everybody, for being here. Glad to see some, finally getting some in-person conferences. I've definitely missed that. My name is Moshe Zadka. My website is cobordism.com, where you can find every way of contacting me known to humankind. And today I want to talk to you about building containers for Python applications. Actually building good containers for Python application, because bad containers are pretty easy to build, but that's not very interesting. And I want to start with acknowledgement of country. I live in Belmont, which is in the San Francisco Bay Area Peninsula, the ancestral homeland of the Ramaytush Oholoni people. So, before we talk about how to build good containers, we need to talk about what is good. And I'm sure we all know what is good, to crush your enemies, to see them driven before you. I'm sorry, that's like the other talk I'm needing. Okay, cool. So back to this side. Okay, so what is a good container, right? We want it to be fast, right? Faster is, in general, all other things being the same, better. We want it to be small, right? Regardless of how you're going to store your container images, right? So there's like a lot of ways. Eventually, you have to pay for the storage. Doesn't matter how many layers of abstraction. Eventually, you're paying for the storage one way or another. Less paying is good. You want it to be secure, right? Like nothing more embarrassing than someone using the fact that you had like a old security hole lying around in your container to get into your environment. Definitely not a conversation you want to have. And you want it to be usable, right? Like people need to be able to kind of, get that image, do whatever they need from that and deploy it, right? So that's, like basically our basic metrics. So, but those were like super high level. So what do we really want, right? Like, so all of these things, right, are supposed to accomplish the high-level goals, right? So first of all, we want to make it easy to keep up to date, right? That's the most operationalized way to say secure, right? You can't build something that doesn't have security issues because there's going to be. What you can do is make sure that at least any security issue that has been fixed is fixed in your container. You want to make sure that you build reproducible builds, right? If you have a small bug fix, you'd want to make sure that, you don't change other unrelated things because that's going to be fun to test and deploy, and that's going to be slower to deploy, especially with a hotfix or a security issue. This looks super specific, right? No comparison prod. Unfortunately, if you follow tons of the instructions that you find on random websites, how to build containers for Python, you'll end up with comparison prod. Sometimes because sometimes because the instructions are bad, sometimes because the instructions are not specific enough, and a little bit of misinterpretation, and awesome. So, and again, you want to keep size reasonably small. I say reasonably because it's really easy to go down the rabbit hole of trying to slim down here and slim down there, and at some point it's going to not be useful, and we'll talk, kind of in more details about that. But these are kind of the operational requirements. We got the high level, what are our metrics? This is how we're going to achieve those metrics, right? So that's good. So for me, the most important thing in up-to-date is install security updates, right? Because we're all going to build containers from something that has stuff. That stuff will have security issues because that's the world we live in. Hopefully you get it from someone who's responsible enough to give you security updates. You need to make sure that you consume them. But the question is when, right? And this is not an easy question to answer, and you probably are going to have complicated answers to that. If it's a critical hole, you need to have 5 days of SLA, except if there's already a problem in the wild where you have a 0-day policy. You're going to have a complicated set of requirements that in most realistic scenarios, you're not going to be in charge of, right? That might be part of your security team SLA or some contract that you signed with some critical customers. Once you have that constraints on when, your job is to operationalize it. And so the exact answer depends, but what you want to make sure is that you control the when. If you control it, you'll be able to respond to the requirements. If you consume it randomly every time you rebuild, or you consume it never and you have to do something very complicated to rebuild, you're not in control anymore. Now when someone tells you, this is how you do, well, now you have to build that policy. So build those abilities before you start so you can adapt, because those policies will change as your company matures, as new customers are brought in or whatever, right? You suddenly have to work with the government and everything changes. The next thing you want is reproducible builds. The abstract definition of a reproducible build is that if you start from the same code, you get the same results. But there's a lot of ways to kind of interpret what same results means. If you interpret it in the strictest way possible, meaning if I get literally bit for bit equal code, I get bit for bit compatible output, you can achieve that. But it is really, really, really hard to achieve that. And it's not obviously worth it. So like in a lot of things, the best way to solve this problem is to redefine it. And kind of like reducing the requirements to like, it's more or less compatible, means that like, you don't have to care about, abstracting the build from the time, because then the timestamp in some file will be different. Sure, it might be that there's like a process in your thing that checks the timestamp of random files, but like just don't do that, and then you won't have to care about it, and that will be much, much easier. So that kind of reduction in like your goal, right? Like what is a reproducible build, will give you 95% of the value of a reproducible build. The problem with compilers in prod, the way I think of that, it's obviously you don't want it. Like nobody like start out with the requirement, I'm going to have GCC in my runtime container that like every user accesses. Nobody has that. The problem is that it takes active work to avoid that. And if you don't put that active work in like several different steps, you're going to end up with a compiler in prod, and that's going to have a lot of regrettable consequences. It's surprisingly easy, right? Because what most Linux systems like doing is support your dependencies, right? You install something, it recursively closes, right? You pip install something that needs a C stuff, right? Like it will kind of try to figure out how to grab the compiler, right? There's like so many ways of things kind of silently and without your knowledge, grabbing something that grabs something that depends on something that, oh, okay, now you have a compiler, okay, great. With size, the problem is that you get into diminishing returns, right? Like going down from like, say, depending on specific distribution, specific choices you're making, going from 1 gigabyte to 300 megabytes, easy. Going from 300 megabytes to like 200-ish, not that hard. Scraping that down to 150, sure, you can spend 2 hours and kind of scrape down those 50 megabytes. Going down from this on that, you spend another like, kind of 2 days kind of figuring out, and you lose another 5 megabytes. You decide when to stop, right? How much value your time has versus how much time every byte costs in the output versus how many versions you build. But usually around the 200, 300 megabytes mark is when typically if you get paid halfway reasonable engineering salaries is when it's like, that's good enough. You do want to be aware of like somewhat like how much cost saving are you making, right? Are you actually paying for like bytes, or do you have like, kind of 10x the capacity right now that you anyway kind of like is going unused, and if you use it, that's fine, like don't bother. So it's a very local decision how much effort is worth putting into that, but usually most realistic scenarios, around the 200, 300 megabytes mark, you're gonna be like, okay, that's done. Another parameter that's really important, it's gonna be really important for how fast the builds work, is that you support binary wheels. Binary wheels, supporting them well will give you two things. First of all, when you install and build them, it's going to make a lot of like how you build the container, especially if you're doing multi-stage, and we'll talk about that later, a lot easier to operationalize. And it's going to be a lot faster if you manage to find binary wheels that have already been built, either by the open source community, or if you have all kinds of requirements, or those binary wheels have not been built by the open source community, you can build them yourself, shove them into a local package index, and again, increase the speed of your build. So you want really good support for binary wheels, and we'll get to like why that matters in a while. If you have really amazing support for binary wheels, you get to simplify your image and simplify your build process a lot. This is a general thing. It doesn't have anything to do with Python, but this is super important. You don't want the user that the container runs, like the main process that is starting up, being root. There are exceptions. Assume you're not one of them. You do not want that to be root. Any general hygiene, right? Like, less boot stuff is like, good. But specifically in containers, this is super important. This is super important because if you root inside a container, and you have managed to get access to the container, it's going to be much easier for you to perform a container escape, meaning get out of the container and start attacking the rest of the environment. If you're not root, usually most container escape attacks involve getting root. You're making the attacker work a lot harder, potentially getting frustrated, worst case, at least doing a lot more, which means that you have a few more chances for your auditing layer to detect that something bad is going on and start mitigating. So you basically want to make sure that you don't use this root. This is kind of a prerequisite, like assuming you don't want a root because you already figured out that that's a bad idea, you also want the user that you do run as to have minimal privileges. And the most important privileges to take away from that user that they don't need, shouldn't have, and it's really great if you don't give them, is permissions to pip install. Wherever your Python environment is, should be read-only to the user. That means, again, if an attacker gets in, they can just pip install stuff. Losing that ability, again, makes a lot of potential attacks much harder, means they have to work much harder, again, either frustrating them or at least pinging your auditing environment a little bit more, giving your security team a chance to catch them in the act. Fast rebuilds are really important. You notice I don't say fast builds, because fast builds are not important. Usually, where speed comes in is when someone is trying to do the edit debug loop. That's what you want to optimize for. Optimizing the first build, not so important. Optimizing rebuilds is really important because that measures how well your build process is responsive. The faster you do that, the less people will try to work around it. Now, you're not going to get perfect. It's still going to be not super fast. But the faster it is, the faster people need to run things locally or start editing files directly on a container, do all kinds of stuff that sometimes it's essential to increase your edit debug loop, but the less people do that, the less then they have, but that only works in my local environment for that reason. Now I have to try it in the container, and now I have to rebuild. So the less times people have to kind of drop out of the main loop to improvise an ad hoc edit debug loop to kind of improve responsiveness, the more people will be happy. So again, not being perfect, you have to kind of take it as a granted, but this is kind of a linear, right? The faster you build it, the better off people are. Now, the first thing you need to consider when you're building a container is the first line in the container, which, with some minor exceptions like comments and the like, is from. And after you type the letters F-R-O-M space, you need to put something after that, right? And that's your first decision. What do you do? And basically, what you're going to do is put in the name of the distribution. So you're going to have to choose a distribution. Now, I've been around for a while. I've been around in the 90s. I remember somewhat fondly and somewhat not fondly the distro wars, where people would go on /dot. It's a thing we old people used to have, and would yell a lot at other people for whatever distribution they have. When I said fondly, I mostly meant not so fondly, and I don't want to get into that. But I do want to give you some guidelines about how to choose about the distribution and how to think about that. So let's start with the base, the size. And the easy thing to say about the size, not an issue. Most distribution, if you use every distribution calls it something differently, server size or minimal, or each distribution has a different name, but they usually have a version whose proper name should be the container version, right? Because that's a version that's right for containers. It doesn't include extra stuff, because if you need extra stuff, you can, DNF or apt-get or whatever, install it later. But it does include, the basic stuff that we need, and you want it to be minimal. Now, most distributions have it. Like I said, it's kind of annoying to go through the documentation and figure that out, how they call it. Some call it server, which is why I like to call it server. But if you're making a choice and you don't have any other constraints, I found that Dabit is easiest to go smallest out of the valid options. We'll talk about why some options that you might be all thinking about are not great. Because like I said, this is not to say that they're not great for other reasons. We are specifically talking about containers for Python, right? Maybe they're great for other stuff, not for our use case. The next thing you want is to figure out your kind of long-term support version, right? And the reason is because you have some process right inside to figure out when you jump from one version to the other. You need to figure out when to do that. That jump usually includes upgrading a lot of stuff that might potentially break a lot of stuff. That's fine. That's part of life. That's why we have a job. But that, like we also have other stuff to do at our jobs. And maybe now is not the right time. Maybe it's a crunch time. Maybe like, you promised like a version and it's on your OKR and you need to finish things by the end of the quarter. It gets dragged up to the next quarter. So 2 quarters, you really don't want to think about upgrading your best OS because you have to deliver a feature and nobody will even talk to you about that. You want to make sure that when that time comes, you're not like, but we are going to lose security support in 2 months. We have to do it now, right? That's not a good place to be in. So usually most things have 5 years, and like they have kind of 2 years release practice, which means you have 3 years. Now, if you're slumped for 3 years, I don't know what to tell you. Like figure it out. You have 3 years to figure it out. But it's perfectly okay to be slumped for like 6 months, 5 months, like even a year, right? That happens. Like business is business. But 3 years, I feel like it's usually enough time that you can find some slot in those 3 years to do kind of the effort. So you want to look for something that has 5 years. Again, most distributions that you'll get usually give you at least 5 years. Some will give you more. That's okay. But that gives you the time to upgrade. The other thing you want to care about the volatility, right? So the reason you call it LTS or supported is because at the very least you'll get bug fix, you'll get security fixes, right? When you do like whatever is your distro's version to like get upgrade, DNF upgrade, whatever it is, then it will grab stuff. Now, you want the security updates, ideally backported security updates so you don't upgrade any major versions because, again, that's not what you want. But what else does it give you? And this is a trade-off. Maybe you want some bug fixes, but you definitely don't want a lot of changes. If you want a lot of changes, you would just jump to the next version. So you want to understand the policy that whatever distribution you're using has. You want to make sure you understand it, and then you want to make sure that it's compatible with your desires, right? Like, I can tell you what you want, but I can tell you that it's really worthwhile to like look into that and think about it before you get the fix that you did not plan to fix, that upgrade something that you do not want to upgrade, that broke all your stuff. Much better to think about it in advance. So I'll give a couple of examples, right? Debian gives you a long-term support version of 5 years if you take like all the different steps that like takes like a few kind of hours to kind of figure out the details on the Debian, but that's like the bottom line. You get LTS, at least security support level for 5 years. Debian tends to be extremely conservative in what it allows. Critical fixes, security fixes, everything backported, no major version update, that's it, nothing else. Again, if that's what you want, that's good because you get that. Another example that a lot of people use, so I want to cover that. Ubuntu also gives you an LTS of 5 years. Except it's weird, and you have to understand what packages you get from the universe and the multiverse, and like I don't want to summarize that stuff, but like I said, you need to read and make sure that you understand what you're getting and why you want it. It's fairly conservative, not quite as conservative as Debian, but so it will include some more bug fixes than Debian does, but it'll still not like do most of the stuff will be backported. Alpine is a bad choice. Not in general, like there's a good reason for Alpine. Alpine solves the problems it's set out to solve really well. But Alpine uses muscle, not libc. Usually it doesn't matter too much, right? Like, that's also a fine C library. Very few people use like the 3 features in GNU libc that only GNU libc has and not other libc because it would be weird and why would you do that? But the other kind of hidden feature in GNU libc, which is like not really easily spelled out, is GNU libc hasn't upgraded a major version since the last century. And it has perfect backwards compatibility instead of minor versions, which means if you built something on some version of glibc, like glibc 2 point something, it will run perfectly on any glibc that's 2 point a higher number. That feature of GNU libc is used in like what Python binary wheels call many Linux, which basically will build a version like a wheel on a really, really old version of something, usually some variant on Debian or CentOS, something that gets supported for a long time. And then you can use that wheel no matter which version you're running because you're probably running a newer version. This is really nice because you can take that wheel, put it in, again, if it's from the open source community, it's like built by the originators. That's already in PyPI. Even if not, you can build it locally. Push it into your local packaging index, which you probably have, and if you don't set up dev PI, it takes about 5 minutes. And you get basically to not have to build it every container build because it's the same version and like people do the right thing. All that stuff straight out the window if you use Alpine. Nothing of that pipeline supports muscle, which means if you use Alpine, you're going to have slow, annoying builds. Not because Alpine is bad, because it's different than what Python binary will support. You probably don't want a distribution that has probably rolling releases, because you'll get new stuff when you're trying to just get security updates. If you have an SLA for security updates, now the SLA is compounded by, but we also have to test it, like, these are the 3 things the upgrade doesn't break us. That's a lot less fun. You don't want it in your, again, if you have a desktop with Linux, I have a desktop with Linux, rolling releases are great, not for that use case. Because the updates can change major versions are not backwards compatible, that's almost the definition of a major version. CentOS, since version 8, is a rolling release. So everything I said, it's not completely rolling release, but close enough to a rolling release in that if you're starting to use 8, you'll get major updates, and everything I said applies. So just a reminder, kind of, if you think about which distribution is right. So your next line, after you choose a form, right, and kind of everything I covered so far is your first line of your Docker container. So I better move fast because you have a lot more lines in your Docker container. How much time would I have? OK, I'm good. So is how to get the Python, right? Fine, you have a distribution. You chose a minimal version, which means you don't have Python on it. So you're going to have Python on it. OK, well, you have a lot of options. But let's first talk about the one option you shouldn't use, which is apt-get DNF or whatever it is you use, install Python, not good. Distros use Python, the distro Python, for the distro packages. Unless you're building distro packages for your Python application, you do not want to use that Python. That Python is not designed for you. It looks tempting. If you use it, you're going to have a bad time. It's not designed for your user program. So, sometimes it doesn't even include pip or venv. Sometimes, they don't upgrade the patch version because they only patch security or critical updates. But if you have an application using Python that runs into a problem that Python fixed in the patch version, you probably do want that fix because your application is based on Python, right? So, and you're writing custom applications, right? So, System Python is going to have a bad time. You can choose a repo that's designed as a repo for Python versions for your OS build mechanisms. The most famous example is DeadSnakes for Ubuntu. So you add the DeadSnakes PPAs, like something package, something, I don't remember what it stands for, but the idea is that you can add it as an extra source to your Ubuntu. Those Python, the ones in DeadSnakes, are designed for user programs. They do include stuff like pip and venv that you probably want. Another option is to get pyenv on your thing. Pyenv knows how to build and install Python. It knows how to manage Python versions. It does a reasonable job. However, it does leave behind what pyenv calls the shims, which is this weird layer of indirection for your Python versions. Not necessarily bad, but if you don't want it, you can use Python build. Python build is what pyenv uses under the cover. So it's perfectly fine. It's equally usable as pyenv. You do have to kind of, tell it a bit more about to do exactly where to install it, but that's sometimes actually what you want. It builds and installs Python. But at the end of the day, it doesn't do a lot more than just, that, right? So, again, there are good reasons to get a Python build. It will abstract you how to get the sources, how to validate them against the checksum, but, there's not a problem with doing it yourself, or you can grab the tarball and put it in the repository. There's a bunch of options here. And then one configure, make install. That works equally well. I didn't specify the options for configure because you will have to think for more than 10 seconds about the options, but you'll figure out the options and you run it and you'll have a working version of Python. If you do that and you chose Debian in the earlier kind of choice options, then I have a cheat code for you. This. So Python : images on Docker Hub are basically, they start with Debian and and then they install Python more or less like that. I kind of simplified a bit, but that's basically what they do. No, if you were going to do that anyway, you can outsource that part of your job. You want to use a slim version, but we'll talk about it later. But you want to be very, very careful about what you're doing. But basically, you can get that for free. And again, that's a valid option if you already I think the right way to model it is like first make your choices. If those ended up being your choices, use a cheat code. Don't start by using the cheat code. Start by like thinking what you need. If you have decided this is okay for you, you can basically take the shortcut. Every single one of those options has like a three-way trade-off. How much control you have about how you build your Python, your build options, like, you know, your optimizations options, CPU, stuff like that. How much work does it take? You know, all our time is, you know, valuable. You probably can be doing something else. And how many problems you can run into. It's a kind of three-level trade-off. You're going to choose one point on it, and like, we'll have to live with the consequences. There's no way to avoid it. Like, whatever you do, you're going to have to live with the trade-off. At least, like, now you know what you have to do. Assuming you're building it as a base for other things, you want to support multiple versions so people can have an upgrade path, right? Like, again, usually in modern environments, there's like microservices. You don't want to have to force all the microservices to move at once, so you want to build a new version, allow microservices to move one by one. Even if there's one service, you probably want them to move on a PR to that branch, be able to test as much as they did. So you want to support multiple Python versions. Now, as you can know from like, you know, basic math and the word multiple, 2 is the minimal, 1 is not multiple. More interesting is that the higher level, you usually don't need more than 3. 3 is reasonable because Python now releases like a minor version every year. So if you only support 2, that might be a bit of a tight timeline again for teams that are stuck in like, you know, really bad circumstances, right? Again, like 6 months of crunch time when like, you know, two engineers left the team and also they have like a super critical feature that's strategic or whatever. So giving like a little bit of breathing space of 3 sometimes is reasonable. But maybe you're not in that position, maybe that's not likely to happen. 2 is also a good number. Almost no other numbers make sense. Like I said, I already explained why 1 doesn't make sense. 4, they don't need that, right? Like, you know, probably like if they can't figure out in the span of 2 years how to upgrade the version, the problem is not the crunch time that the 2 engineers leaving, the problem is that they can't allocate work appropriately. Now, I'm going to talk a lot about how to use multistage to make things better. Multistage is, I guess, a new enough feature that I do want to give a quick recap of that. So when you have a Docker multistage, remember that only one stage will actually be part of the resulting output. Well, so why do we have the other stages, right? Are they just there for fun? Well, no, they're not just there for fun. The other stages will help producing the final output stage. And there's 2 ways to use previous stages in like the stage that actually does the output. One is from. A stage can start with a previous stage. That's really helpful when you want to use like when you want to use stages as modules, because you can have like shared code in some base module and the other stages move from that. But honestly, if that was the only feature you got, some creative text munging on Dockerfile would have given you the same ability. Not a great option, but that's not the main benefit of multi-stage. Just like once you have staging, you might as well do that. The real advantage is copy minus from. So a stage can copy minus from a previous stage, which means one stage can prep files. It can install whatever it wants because it's not going to be in the output, and then you copy things from the previous stage to this stage. That is a really useful feature, and we'll talk about how you can use that when you're building Python applications. So this is not necessarily like I wouldn't recommend using that as a good template, but this explains how you use stages as a module. So like here is how I build both 3.8 and 3.9. Again, I really want to be clear that this is not how to build good containers. This just shows in a thing that fits on one slide how to use stages as a module. So usually the first stage will be slightly more complicated, and the other stages will be more complicated. But this fits on one slide. But the main benefit is you can separate the build and the runtime. Now, especially if you're building stuff from source. Doesn't matter if it's Python or if you're building some native extensions from source. You're building stuff from source, and the common thing that you need to build when you're building native extensions or Python is compilers. Just like Chekhov's gun, we talked earlier about how compilers in prod are kind of like, the weird monster that lies in the shadows ready to pounce. This is usually how it pounces. You try building from source, you install the compiler, and that's it, right? Like the whole movie ends. So then this is usually, so this is how to avoid the monster, right? again, you know, I simplified a bit to make it fit onto a slide, but you basically start with the builder version. You need to install build dependencies. I don't want to get into these details because there's like a whole discussion I could do about that unfortunately I don't have time for that, but you can always catch up with me later if you want to talk about it. And then you build Python, say, /opt/myorg/python. And then in the next stage, you do from Ubuntu as runtime, and then you copy the Python from the builder. That will give you what you want, right? Now you have something that has Python, does not have all the build dependencies that you installed in the first 2 stages, right? And that's basically the template for all variants, right? Regardless if it's Python you're building or like the extensions you're building, that's kind of gonna be the basic structure, the basic skeleton that you're gonna fit your stuff into. And you'll also notice that I kind of try to optimize the layers, especially in the runtime. Again, we want Docker kind of startup time to be fast. The reason you want that is because that basically measures your elasticity. If you add another thing in your node, whatever kind of orchestration mechanism you use, Kubernetes, Swarm, manual, whatever you do, the first step is downloading the layers and extracting them. Less layers means that it's less complicated and faster to start up, and that measures your elasticity, which means how fast you respond to sudden increases in pressures, or how much extra capacity you need to build so that when you respond to extra capacities in pressure, you have time to respond. So either way, this will make things better for everybody. And basically the way to kind of do that is to make sure that you put everything under one big directory, which is opt.myorg, and then copy one layer. So basically you have the base layer, you have the, and you have kind of the layer that has everything that's special for you. When you build Python, and this is why it's important to do it in multi-stage, you couldn't do it without multi-stage, but you are going to be torturing yourself, at least since I think 2 or 3 months ago. Now Docker files can have here documents, so you don't need to put backslashes. That is a very, very small comfort to okay, that stage takes 2 screenfuls. So that stage means those 2 screenfuls are not cached, right? You can't cache in the middle of that. So that kind of sucks because if anything changes, the rebuild is no longer fast. And plus it's less readable, less understandable and things like that. Much better to do it in multi-stages. Who cares if you have a few extra layers on the build stuff? That's not going to be your bottleneck usually, even with most realistic CI environments. So after you build Python, now that you are kind of doing it in the build stage rather than the runtime stage, you have kind of a nice place in your Docker file to kind of remove the tests, remove the obviously don't have the build dependencies in runtime, and there's other stuff that you probably want to remove. I don't want to get into these details. You can see a bunch of kind of skeletons. You can, for example, look at the Docker file of the official Python image to get a good sense. But tests and the static library are usually the 2 things that are the most space consuming and the least useful in your runtime images. Okay, so you've done that. Next step is to install your Python level dependencies, right? Until now, all we have installed is operating system dependencies and Python itself. Great, that's awesome. But probably at least 30 to 90% of the reason you use Python is because of how awesome PyPI is. Great, which means you need to install dependencies. And probably at some level of the recursive dependencies, even if you think, I only have 5 dependencies, how bad can it be? Well, when you recursively close it, pretty bad, right? Not bad in bad, right? It's not going to be worse for you, but it's going to be pretty long. And it's almost certain, right, by kind of basic probability, at some point, some recursive level dependencies will need native code, because that's kind of part of what makes Python awesome, right? It's really easy to write native extensions, which are the interface with the Postgres client and the MySQL client and optimized Fortran stuff and all kind of stuff. So so you want to build the binary wheels within the builder image if they don't already exist in your PyPI or in the open source PyPI. And then the next step, you can basically, you kind of have another choice. You can copy the wheels, the binary wheels themselves to runtime and install them in a virtual environment. Or what I like to do is you build them with a builder, you install them in a virtual environment in the builder, and you copy over the virtual environment. Again, less useless stuff hanging around the runtime image, although you can kind of work around that. But it's kind of really nice because you can test it in the build time image, which is like the main benefit of that. If you're building a good builder image, you want to get patch shelf. The reason you want to get patch shelf is patch shelf will be what allows your binary wheels to be portable binary wheels, which means you can upload them to your local pipe, packaging index, which means you can make your builds a lot faster. So patch shelf is super cool. However, almost all distributions have a slightly older version of patch shelf. That version of patch shelf has some critical bugs that will produce broken wheels. Do you not use that version of patch shelf? If you are going to use patch shelf, sorry about that. You're going to have to grab it and install it from source. Now, that's not a big deal because, again, only in the build stage. If you have some stuff flying around the builder image, it's not going to harm anything. So, yeah, it's OK. But patch shelf is what you need to install, not what you need to use. That's a big distinction because you're not going to use patch shelf directly. You're going to use patch shelf with a Python abstraction for patch shelf, and you're not even going to use that. You're going to use audit wheel, which uses a Python abstraction for patch shelf to use patch shelf. So from your perspective, as a builder, after you make sure that patch shelf is the right version, what you need to do is install audit wheel. But that's easy, right? So that's why I didn't cover that because hopefully pip installing is something that you're doing all the time. So you pip install audit wheel into some random virtual environment, or hell, you can even put it directly in the main environment of the builder because it's a builder. If the main environment has a few extra stuff, who cares? But then you can easily build self-contained binary wheels. So this will not build a portable binary wheel. If you do that, then you get a wheel that you need to install in the same Docker build, but it is self-contained, which means, for example, if you're building a MySQL client, you don't have to install the runtime version of the MySQL client library in the runtime image. Whatever parts in the runtime library will already be shoved into the wheel. This is amazing because it will make your runtime image so much simpler. And figuring out what is the right version of MySQL runtime for the MySQL dev is annoying. And MySQL is that's not a problem with MySQL, that's just a general problem. It's worse with other stuff. So this will already give you a lot of value. But if you want even better, you can have portable binary wheels. Portable binaries are one you can upload. So that tag, is specifically marked as a tag that no packaging index will accept, right? It will get rejected in the upload phase. This is a feature, not a bug, because that tag is not safe to use in arbitrary images. If you want to build portable binary wheels, the first thing you kind of need to accept, right, is that you can't. But that's okay. Because you don't get to have to be perfectly portable. What you need to decide on is the portability level. What is the oldest thing I need to support? That's your portability line, right? So everything below that you don't care, everything above that you do care. So after you've accepted that you can't do perfect, this is what you can do, and that's great. So figure out what is the oldest supported. And again, I can't tell you that because we already talked about how you need to choose a distribution and how you need to understand the LTS and how fast people upgrade to that. So I know what you chose, but you know what you chose, hopefully, and you know what people are using. Hopefully you can at least check or, talk to them, worst case. And so you figure out which version they need support for, and that's the version you're going to build the portable binary wheel for. Once you've figured out all this stuff, which is not a technical issue, that's a social issue. You need to at some point actually talk to some human being. This is a good example of a many links tag. 227, I believe, corresponds to basically Debian versions after the thing that's before Buster. But I'm not going to trust my memory. It's a fairly new thing, but it's not super new. So probably that's a good approximation if you're building it right now. If you're watching this talk on a video, in the future, I hope this is a great future, and you probably want a different time. So how to generate binary wheels? I also can't tell you. That's because every single to misquote Anna Karenina, every Python, pure Python wheel is the same. Every binary wheel you have to build in its own way, right? There's usually documentation. Some documentation is good. Some documentation is so-so. Some documentation is an insult to humankind. That's the world we live in. I'm not going to sugarcoat it for you. Sometimes it does take a while to read the documentation, to understand what they're trying to do. But you try and try and try. Eventually, hopefully you succeed. Ideally, like they have some unit tests that you can run to make sure that their build is correct. The nice thing is that after you have suffered, and like I'm not using this word lightly, sometimes it will be suffering, but after you have suffered, you can make sure that no one else suffers by encoding these build instructions in a Docker file, right? You build the dependencies, you build the PyPI, you upload it to like your native Python images, and that's done, right? They have a new version. First, depending on your religion, pray to whatever things you believe in. They've not changed how they build stuff. After you're done with prayer, you try building the new version. If you prayed well enough, you get to upload. If you not, enjoy reading the new version. Again, not the perfect world, but it's much, much better than 5 other teams trying to go through the same process, right? So it's actually like, it's better than the alternative, which is, it's not you. It's like 5 other teams who have gotten it wrong, and they come to you after it's broken in like subtle ways in production. So as horrible as this is, imagine the alternative. When you're trying to optimize layers, like I said, like you want to reduce the amount of copy minus form you want to do. Again, faster, usually smaller. That means you want to prep, right? You don't want to copy and then kind of move things around. You want to move things around and then copy. You also want to optimize the caching, right? Like Docker kind of build cache, or I really should say build kit cache, because that's actually how you build, right? Docker build is just like a very thin layer of UI, and barely even that on top of build kit. The build kit cache is amazing. But it's not going to be very amazing if you don't, give it the right stuff to work with. If you copy stuff that you need in the wheel that like is your specific application too early, then, and they say installing dependencies, build kit will be, oh, so that depends on the source files. I should probably do that again. That's going to be sad, because that is probably the slowest part of your build. Again, most people who use Python use it because they don't want to write C code. If you already wanted to write C code, you could have done it at the beginning. So probably your application does not have directly C code. So installing that is pretty fast. What you want to make sure is that the installing dependencies is cached, so you don't have to do it again, because that's hitting the web and then also like potentially compiling and doing a lot of stuff, not fun. So you need to know what invalidates caching. And basically like copy new files. So one trick I like is like, first you copy over the requirements files, then you install them, then like a pip install -r, and then only then you copy the sources. Your requirements files probably are not going to change. Your source files probably change, because that is what the application engineers are actually debugging. Sure, occasionally you upgrade a version, but that doesn't happen again. And again, rebuild speed, right? This is what we're trying to optimize, rebuild speed, right? So you copy the requirements, you install the requirements, then you copy over the source files, then you build the wheel, then you install the files. It's going to get you a much, much better cached build. So you kind of communicate with build kit in a much better way. So I want to leave you with these thoughts. I don't think I like this phrasing anymore. Like it is kind of true, but I think instead of the word wrong, what I want to say is kind of okay or serviceable, right? It's really easy to, like pump out a Docker file that will kind of work, right? I've seen it happen a lot of times. It's much, much easier than to, kind of follow instructions I have laid over like almost 40 minutes now, right? It's much, much easier, right? Like I've told you what kind of thing you need to think about. All that thought takes time, right? All this, like, kind of documenting all that research into what other teams need and who we have and who's going to use it. That takes time. That takes a lot of work. But when you do all of the things I suggested, you get a much, much better thing. You get something that you can easily redeploy. You can easily intake hot fixes, right? When people are asking, like, how long does it take to deploy a security fix? When people are asking, how long does it take to debug? When people are asking, like, how long does it take to be more elastic? You have much better answers for them, right? You're in a much better place. You can get to amazing, right? So kind of don't give up on, like, don't give up and do the obvious thing, right? Go the extra mile, spend some time. Think before you Docker, right? Before you start, VI Docker file, before you, put the first byte, spend the, kind of day, 2, 3 days, you probably they're gonna be paid off think about it, right? Like write the list of all the decisions you need to make, write the list of trade-offs you're gonna need to make. Do research, ask people, write some prototypes. That's gonna be work, but if you put in your work, you're gonna get something pretty great. I think that's close to my time, and also pretty close to the end. So once again, thank you all for being here and listening me chat about one of my favorite obsessions. Once again, thank you all, and thank you all for coming. I hope you enjoyed that. I don't think we really have time for questions, but I'm like around-ish, so you can catch me, or corbadism.com, reach out. I'm happy to answer any questions. Bye, everybody. Thank you.
Audio working? All right, thanks for coming. This is finite state machines, but like for web applications. A little bit about me. My name is Zachary Berry. Hello. I'm really thankful to be here and be able to present. I love JavaScript in the browser. I am a front-end developer at Crosscom. And just the 10-second plug, we are hiring especially a back-end developer. So just see our booth. We are right back out there, or go to crosscom.com/careers if you're playing the home game. Okay, so let's say that you are building a shopping site. So let's say this is your site. So you've built it in React. And disclaimer, some of the stuff I'll talk about in this talk mentions React, but the core code we get to later is React agnostic. But there are plugins for React. So anyway, you have this website, shop123. I'll go ahead and log in. And then we have products here. So we have the life-changing pineapple cup, the above average bowl, and the third thing. So let's go ahead and buy one of these things. We'll buy the pineapple cup. And as you can see, it's loading as it's sending a request off to the server. Eventually that comes back, and now we have one item here in our cart. So go ahead and check out here. And we have our checkout page. It's all pretty standard. Insert a few details here and click buy. We wait for that to go through. And then finally, we get this receipt page. And then we're able to then go ahead and buy more things, which takes us back to the shopping page. So a pretty straightforward example. Let's see how we might build this out in React. So on the right here, we have our state, one possible state for this application. So you can see like we have a flag if they're logged in or not, what page we're on. We have what's in the cart, and some flags about kind of our network state. So like, are we currently adding something or buying, or is there a glitch? Is there an error? So as I go through here again, I'll do this again. You'll see the state update. So now we see that is logged in is set to true, and page is set to products, and then this is the rendered result of that. So I'll buy our pineapple cup again. We see something's been added to the cart now, and is adding product as a flag we've set to true to indicate that we're waiting for the server to respond. It finally does. So the change here is adding product as false, but we do have something in the cart, so we see the indicator by the checkout button. So now we're on the cart page. We're going to click buy, and is buying is now set to true. And that goes through, so is buying is set to false. We're on the receipt page, and our cart is now emptied out. If we buy more things, we will go back to the products page. So that works, but there are some issues with that. Do you know where a user is? So for example, when is the user shopping for products? That happens when these properties are set to these values. They're logged in, they're on the products page, and they currently aren't adding products and waiting for the result. Similarly, what happens when they're submitting an order? We have these properties here. And this application, this example is pretty small, and so this isn't too hard to wrap your head around. But as you can imagine, as your application grows, and I'm sure some of you worked on complicated web apps before, this can kind of get exponentially harder to wrap your head around. And so not only do we have an issue with looking at the state of the application to determine where the user is, but we also need to parse the source code to examine where the user is as well. And so in a complicated enough application, it could be difficult to be confident what your user is seeing, especially if there's weird edge cases. There are also many unknown and undefined states, and by states here I mean kind of like what the user is currently doing. So for example, what happens if is adding product is set to true, but they're on the receipt page for whatever reason? Or what happens if they're on the product page, but is error is true? I didn't really demo that in the example, but is error was kind of for if there was a error when buying something. And so these are undefined states. They shouldn't happen, but it's possible. And I'd be curious if you've ever heard or said these out loud before. I've never seen that happen. That shouldn't be possible, and nobody's going to run into that. But in my experience developing stuff, it does happen, it is possible, and people will run into it. The other issue is there might be other states you hadn't thought of. So, you know, maybe it's not clear without like some user tests that maybe it makes sense for there to be another page. Maybe it makes sense for there to be other network states that you haven't modeled. And usually what happens is when that happens, you have to kind of shove that into your state, and over time, your really clean and nice state becomes this really disgusting mess. And you don't have time to refactor it. So, is there a better way? Well, you obviously know the title of the talk. So yes, change careers and become avocado farmers. It's like, it actually is finite state machines. Maybe, and I'll get into the maybe a little bit later in the talk. But you might be asking, if you're not familiar with it, what is a finite state machine? So, part 2, what is a finite state machine? Okay, so it sounds complicated. If you haven't been exposed to this in like the computer science field, it sounds scarier than it is. Kind of sounds like it might be a death metal band or an industrial band or something. But it really is kind of a type of flow chart if you really think about it. The machine part might throw you off, but it's not a kind of physical thing, and it's just an abstract kind of diagram. So in a finite state machine, we have some state. Here we have state 1. And then there's one or more transitions, and when we can transition from one state to the other. And in this specific example, all we can do is toggle between state 1 and state 2. So to turn that abstract example into something that might kind of resonate, let's say that you are sleeping, then you might have a wake-up transition, in which case, hopefully all of you are currently in the awake state. Then when you go to bed, hopefully, eventually, you'll become into the sleeping state. So this part of the talk is just kind of a couple examples to reiterate kind of what finite state machines are. So everyone's familiar with the traffic light. You can model that like this. So we just have a 3-light system that changes states. The transitions here are based on time, or potentially if there's a sensor in the asphalt, maybe that's communicating with it. Here we have a soda machine. This is a soda machine simulation. Sodas are $2. So I will insert a dollar, insert another dollar, and then I will have to make a selection. I couldn't resist the tabs versus spaces thing, I'm sorry, but here we go. We have a delicious tab soda and an okay spaces soda. So I will order tabs, but unfortunately, looks like it's sold out. So we'll go with spaces, and ta-da, we have our soda. So what might that look like as a finite state machine? So initially, we're in this take money state, and so we're going to kind of repeat this take money state until a condition is met, and we have our $2. So you can see here, these diagrams can have loopbacks, if you will. So I will insert a dollar, we'll loop back, and we're still in the take money state because we haven't reached our total of $2. Insert again, and we reach our $2, and now we're in a choose state, and the LED or LCD is changed into a make selection message. If I try to buy tabs, it's sold out. If I try to buy spaces, it's in stock, and it will dispense my soda again. Get out of here. All right. Forget if this is the last or second to last example, but so we have regex, if you're familiar, or just string parsing, really. We have this contrived sentence that helps my example, Dave's dozy dog. Let's say that we are searching for the string dog in this string. So we could model this with a state diagram. So we start off with state as 0, and that's basically we have nothing. And we have two options. We can find a D, which is good, or we can find a not D. And if you have not seen it before, This weird kind of angular symbol is just another way to say not. And so if we are to get to the D state, we then look for an O. And if we find that, that's great. If we find another D, we can kind of just hang out here and keep waiting for a second D or a third D. If we don't find an O, though, we have to start back to the beginning. Lastly, if we're on the O, all we need is that G, and if we don't get it, we have to start over. So I think you guys know where this is going, but we will go through the simulation anyway. So as it reads these, it's looking for a D. It found it at first, but then it had to give up. Finally, we find a D, and we find an O. But unfortunately, we don't seal the deal. We're back at Z, and then we're back at state S0. But if you can imagine it, we will reach our dog. And I like this effect, so I'll do it one more time. So, and then we have kind of a practical example that might make sense in our world. Here's a network kind of simulation. So we start at this idle state, and we load some sort of request. Excuse me. And so then we reach into this loading state. We have kind of two options. The network could fail or send us some sort of error, and we're in a failure state. Perhaps we've built our application to have a retry functionality, and we can resend our request, in which case we're back in the loading state. And when we get a response, a successful response, we migrate to the success state. Okay, so that covers some examples. Hopefully that sort of makes some sense if you haven't been exposed to these. How do we apply that? So we have our shopping site yet again. This time, let's think about how we can model this in a state machine. So initially, we are in this logged out state. And we only have one option, is we can log in. And when we log in, we move to shopping. While we're shopping, if we add stuff to the cart, we go up to this adding state. Excuse me. And then on the adding state, when that succeeds, we kind of come back to the shopping state. So these don't necessarily represent individual pages of the application, but more of states. So on the shopping state and adding state, we're both looking at the products page, but on the adding state, we have that modal dialog on top that's saying we're working on it, waiting for a response from the server. Then when we're checking out, we can cancel and go back to continue shopping or buy. When we buy, it can either fail or succeed, and then we get to our receipt page, and we can continue shopping. So I think hopefully that's kind of obvious, but I will just go through it real quick. So I will submit, and we're in our shopping state. This time, let's add the bowl. Actually, I didn't make it work with the bowl. We'll keep buying the pineapple cup. And then it's loading. It's finished adding, and now it's successful. We're back at shopping, but this time we have this checkout button. Checking out, we will buy our cup yet again. We really like pineapple cups. It's buying, and then it succeeds. We're back at the receipt. And if we click buy more things, we're back at the shopping state. Okay, so why is this good? There's no mystery states here. They're all enumerated and visible. So you saw in this diagram, the end result was that we saw every possible nook and cranny of this application. So it makes it easy to see what's missing. If once you map out this flow, you might see like, oh, I might need a page between these two nodes. Or in the example, I didn't actually model out what would happen if adding a product to the cart failed. So we might want to add that. And then also great is that the transitions are defined. It's obvious what states a user can and can't go to from any given state. So abstractly, that means, like, for example, on S0, I can only go to S1 and S3. That's defined. I know there's no way for me to jump to S2. And if I'm on S1, there's no way for me to kind of magically teleport to S3. And so what could happen in a traditional application is that these state properties change to things you don't expect because of a bug in the code, and all of a sudden your user's teleported to somewhere you didn't expect, or they're on some sort of page that isn't planned for, and that's when things go wrong and weird. So, JavaScript, which is where this gets useful. So we're sort of starting to leave the theoretical world now of finite state machines and entering the practical real world where this kind of can come in handy. So This is a good resource. I have two good resources on building your own finite state machine in an application. If you like tinkering with this stuff, I'd recommend that you read this article and the next one and kind of play around with it. It's surprisingly simple at its core, and you could build one of these in an hour or two or a day or something like that and get it working. So actually, let me stay on that slide in case anyone wants to grab that and hasn't had a chance to, the URL. But these are, if you search the finite state machines, JavaScript, Google, these are kind of like they come up pretty quickly on the first page, I think. And then this one is from John Bella, which is similar but slightly different on the previous one. And now this is where the code comes in, but I try to keep it pretty light on code. But this is using a library, XState, and I'll talk about Lucene a little bit later. So XState is a pretty mature library. I had built out a finite state machine using some of those earlier examples I just showed you. And that was working really well, but I started to come across some edge cases that I needed to then build into my finite state machine. It's been a little while, so I forget exactly what those were. But then I had to make a decision. Like, I could keep kind of tinkering with my own little finite state machine, but I knew that this existed. And so I made the decision that I would just try this. It felt like overkill at the time, but they have kind of worked through every little edge case and kind of need that you'll probably run into. And so I was like, okay, I'll use XState. And again, this is agnostic to your framework. So it has bindings for React and Vue, but you don't need any of those to use it, which is great. It's pretty well documented. It also mentions state charts here. If you're familiar with that term, I didn't want to get into it in this talk, but it's similar to the idea of a finite state machine, just more has been added. So if you see that term, it's really interesting to look into, but that's kind of the relation between that and finite state machines. So we're taking a slice of our example from earlier, and we're going to put it into XState code. So we don't have the login state. I'm just sort of looking here at when we're shopping, adding stuff to cart, and then going to the checkout process. So this is what it looks like defining something in XState. We have a machine here. We need to give our machine an ID. And then we can define an initial state. That's where we start. So as you can imagine, we start at this not logged in state. And then we have this object here, which is context. In the real world, when you're using these in your applications, you'll find that you actually, you still need data. So for example, like the shopping cart. And so XState realizes this, and they give you this object called context. You can think about that in React terms as state. It's just confusing to have state in a state machine because you say state too many times. So they call it context, but that is basically a bucket of data which your states can use. Then we go on to defining the states themselves. Here we have the shopping state, and you can see over here that is represented here. And in XState, the transitions are defined through actions, and that's what on is here. So on is where we define our actions. Here I've added an add action, and we tell it to then go to the adding to cart stage, state. And so here's the add action, and then over here is that adding to cart state. If I scroll down, it gets a little more complicated. I have our adding to cart state, again, that's up here. And we have this new property called invoke. Invoke is what XState refers to as sort of an on-enter event. So as soon as we jump to this adding to cart state, we'll run the invoke code. And the reason they went with invoke, I believe, is because this library intends to be backwards compatible with a standard called I think it's SC-XML or state chart XML, and also to be standard with the state chart definitions, which is great, but I think it's a little bit of a learning curve. I find it a little bit weird, but once you start to use it, then it becomes second nature. So anyway, when we invoke, we run the source function, and so this is where we might talk to an API, for example. So here I have some sort of add API, and I'm sending in context.cart, which again is kind of our state machine state or data, and that cart would be the contents of our shopping cart. And then with invoke, you get a couple of things. You get on done and on error. So if our source function returns or is a promise and resolved successfully, then it's going to automatically call on done, and we'll go to wherever we define. So here on done, we'll go to shopping. And on error, so that means I think it's undefined is returned, or if it's a promise, it rejects. We'll go to some other state. Now here I don't have it, I didn't model this, but you can imagine there might be some sort of add to cart, and we might have a fail state here. And then, and I hope you can imagine kind of so forth and so on. The other states would be kind of iterations of the same kind of idea. So I didn't fill them out here. So what's great is I've showed you some visualizations, but XState has that built in. It's on the website. So I can define, here's like maybe a fleshed out XState code of our machine. So if I run that and update, then we have this visualization. Now it's not quite as pretty because they just algorithmically build it, but we have our not logged in state. If I hit login, so that's a login action, we then transition to shopping state, and we can add to the cart that calls on done when that invoke function completes. And then we're back at shopping, we can check out. Checking out, we can buy our product. When that invoke function completes, we call done, and we are in our receipt state, and we can continue shopping and return back to the shopping state. So what's great about this is as you're playing with it, this is super helpful to visualize if you have any bugs. Obviously, if you have like some source code issues, it's not going to compile. And all that's really helpful as you're building some of this stuff out. So, oops, I didn't mean to click that. 1 second. Here we go. So I have a real-world example. I used to work on an open source project called Obojobo. This was a learning module platform. It's still out there. It's still open source. But this talk isn't really about kind of plugging that. It's more about a real-world example of how this helped an application I was working on. So I have this GIF here just to kind of show you what it looks like so you're not curious. But the piece that I'll be talking about is this assessment piece. So students would come to the assessment of these modules, and then they would see a pretest page. They would then, which would give them instructions about what to expect on this assessment test. Then they would take the assessment test, which would be a couple of questions, and then finally they would submit that. That would then process and then show this results screen that you're seeing, that you just saw there for a second. So here are the pages that I talked about. There was a couple of dialogues, so if they lost network connection and came back, we would resume their attempt. If there was an error, obviously we would show them an error. Then we have that results dialogue. And then we have a bunch of data to determine what to render. So some of our state values we cared about, and this is not exhaustive, but like how many attempts have they completed? Is there any incomplete attempts? How many attempts do they have remaining? Is there any sort of error? Did we get successful responses? So then as time went on, we added a bunch of features and things exploded. So now we have new dialogues. We need to let them import a previous attempt. We need to, because of changes we made to the application, there were new question types, and it resulted in us needing to kind of save the responses and then send them all at once. So we now needed to let them know if it was taking a while that we are currently sending their responses up. Did that fail or did that succeed? We also wanted them to confirm to submit their attempt in case they accidentally hit the button and they weren't finished, or if they hit the button and they had some answers that they didn't fill out yet. And then the data also increased, so does this module include importing? What's the response of when we're sending all the responses? Is this the last attempt? Because now we had that special dialogue. We had a special dialogue that let them know, hey, this is your final attempt. Are you totally sure? It's going to be set in stone at this point. So I spent some time putting XState in the application. Now I didn't refactor the whole thing, although I wanted to after using it. But this was just the assessment, and I came up with these states. It seems like a lot, but going over it several times, it kind of ended up making sense to me that this really was the number of kind of things that a user could do in this assessment. I'm not saying that this is the only way you can do it. What's really cool about XState is you can actually nest state machines. And so it may have made sense to kind of have a nested model too. I think both are valid. But it was simpler for me doing it for the first time to kind of forego that and just stick with one state machine that had everything sort of flat and visible. So a little bit more code. This is kind of a simplified example of what the code was before putting in XState. This is an older application, an older React application. It used a Flux store. So there's things we could do realistically to make this better, is maybe incorporating Redux. Unfortunately, didn't have the time to do that to the project. But regardless, we have things like we end the attempt with this API response, and then imperatively we kind of next show a dialog saying, here's your results. Or we do a check. If this is an incomplete attempt, we need to show them a dialog like, okay, we're resuming your attempt. And then finally, we can do things like, we'll resume the attempt, and then if it doesn't work, we need to show them, oops, something went wrong. And then call on the store to resume the attempt. Once the state machine was in the application, and this, I don't think I mentioned this, but this is specifically looking at the code that just handles mostly dialogues for the application. You saw one of them in the GIF earlier. But regardless, it made this way easier to reason about. So now I just had this big switch statement, and I had all the states that were important to showing a dialogue. So when the end attempt successful state was happening, I could then be like, oh, okay, I'll show them the results of that attempt. Or if we're asking them to resume, we'll show that dialogue. If that didn't work, we'll show them another dialogue. And so once that was in place, it was amazing, because before this was kind of in some pieces, and again, could have been improved with things like Redux, but this really helped out to understand and work on the application going forward. So, preparing for this talk, about a week ago, a friend of mine pointed out this thing which I had not heard of, that he heard on, I think, the Chris Coyier podcast, called Lucy. And this is sort of a DSL, its own little language that then transpiles into XState code. So here's what that looks like. Again, this is our fleshed out example of our shop123 site. On the left here, we have our XState code. You've seen this a couple times now. On the right, and forgive the syntax highlighting is a bit weird because there is no Lucy syntax highlighter, but this is what it would look like in Lucy land. So over here, we have a bunch of actions. You can define these inline, but I do kind of like that they have them all put up here at the top. And then we define an initial state. And otherwise, other than this initial word, all these states are kind of in the same definition. We just say state, the state that we want to call it, and then we add our actions over here, and those actions then transition to other states. And we covered the invoke, so that just looks like this. We call invoke in our source function, in this case, our onEnter, so to speak, is this update cart method, and this update cart method is maybe some API request again. That would come externally and sort of be slotted in here that's not necessarily defined in Lucy. Lucy is really just more interested in building out your state machine. And I thought this was pretty cool. It has connections with like Snowpack and Rollup, but you could even forego all of that and then just build this on your own in a command line, and then run the command line script to then convert it into XState, copy that, and put it in your project if you didn't want to get it, spend the work to get it integrated. And that works fine. So there are a few things to consider, a couple of cons to go with these pros. XState is a learning curve. I think the terminology is a bit hard. There's a lot of options, and so there's a bit of trying to decide, well, what's the best way to do this? Something I didn't cover is that in XState you can define guards. So what that means is you can say this transition will only happen on this condition. So for example, in our soda example from earlier, we'd have a guard on the transition from taking money to making a selection to make sure that the amount was at least $2. But that's an example of just one feature in XState. I'm sure there's other ways to do the same thing too, and other ways you can model the finite state machine that would also be totally valid. So plan to spend some time pouring over the documentation if you do pick this up. It's not a magic bullet. If you have complicated logic, maybe complicated business logic in your application, doesn't mean that your application is going to, that part's not going to go away. You're just going to maybe move that somewhere else. There's analysis paralysis. Like I said earlier, I made one large state machine. Should I have made nested or parallel state machines? Maybe. Should I have done a whole ground up rewrite? I wanted to, but probably didn't make sense as a business case to spend the time doing that. And of course, as always, this is a tool. It can be used for good or evil, and maybe it doesn't work for you, and that's totally fine. Also, the last half of this talk is really talking up XState, but I'm not necessarily tied to XState. It's just something I used and worked well for me. There are other libraries out there that do similar things, and I'd encourage you, if you're interested, to go look and research those on your own. But XState ended up being kind of an easy decision for me in the end. And so based on this state machine, we have reached the question portions of this talk. So does anyone have any questions? Yes. I think, so the question was, how difficult is it to communicate the state machine across components? So for the Oboe example, that wasn't too bad. Using some older kind of React standards, I sort of put that into this assessment store piece. But XState does have hooks for React, so there's like a use machine hook. I haven't toyed with that, but I did glance at it at this talk, and it seems pretty straightforward to kind of be able to define a machine and then kind of use it in different components without having to like kind of pass it around. Any other questions? Yes?
Can you actually put your state in Redux?
I'm sorry?
Can you actually put the state information in Redux so that it's available to all components?
Yeah, so he said you do put the state information in Redux, so it is available to all components. So yeah, that is definitely an option. Yeah, good point. Any other questions? Yes, back there. Question was, how do you handle side effects? I missed the last part though. Like error logging? Trying to remember. It's been a little while since I incorporated it. I think a lot of that is handled through, so you saw that invoke method, and then there was that onDone handler. That's kind of where side effects happen. So in the state machine I incorporated, on those onDone methods, that's when On the source methods, when the invoke was called, that's when I talked to my API. On the on-done, that's when I updated the context of the state machine, which is like its data or state again. And there's a method in xstate called assign, which does that. And what I kind of ended up sort of liking to do is sort of take that code and kind of abstract it to its own little, I don't want to say class, but its own like little class, so that I could kind of separate the pure moving around states code from the actual code that did the talking and the updating of the state. Any other questions? All right. Thank you. So if you're interested, my site is zachberry.com, and that's where I have all my social links and everything. But yeah, that's it. Thank you for coming.
Meeting new challenges by having greater ability to manage the data underlying our business. At Panera Bread, our focus is on giving our customers good, real food that they love with a friendly touch that we call Panera Warmth. But whether you're in the business of food and beverage, retail, hospitality, or any other, the ability to adapt and manage constant change is crucial for success, whether those changes are customer tastes, market demands, or real-world events. In case you haven't heard of us, Panera Bread is a fast casual bakery cafe chain of more than 2,000 locations across North America. We focus on natural, real foods with
All right, come on in. It's good to see everybody. We still have people coming in. And if you have friends or colleagues here and they're not in, message them to come on in. They don't have to. I think, do we have any more, do you all know, are there any more sessions going on right now? So all the sessions have wrapped up today. Okay, I thought that was the case. So thank you all for staying around. Thanks for being here. And thanks for staying, again, all throughout the day. So this was, day 1 was yesterday. This is day 2. And we still have day 3 tomorrow. So by all means, please come back tomorrow. We'd love to have you back. We're going to start an hour later tomorrow morning. So we're going to start at 9:45 instead of 8:45. And we do that for a variety of reasons. But primary among them is, you know, people are a little tired after the first day and don't feel like getting on it quite as early or as early on day 2 or day 3 in this case as they were and they did on day 2. So we try to give you a break and start an hour later. But the programming tomorrow is going to be amazing. World-class speakers again. And it's really going to be a great day. So as more people are coming in, I want to remind you of the RIoT event downstairs. You know, historically, if you've been to how many people have been to ATO before? Most of you. How many people are here for the first time? Whoa, a lot of you. So, wow, that's really great. If you've been with us before, you know our Monday night social, we typically do 2 things. One is the RIoT event. They have always hosted their demo night here. But the second thing, the other thing that we do, the ATO social, is at Jimmy V's, and we're out on the patio, and we actually buy the restaurant out. We didn't do that this year. Obviously, we're in the age of COVID, so we didn't feel comfortable putting people inside Jimmy V's elbow to elbow. We just didn't think it was the right thing to do. So we have partnered with RIoT, and we are just going to walk downstairs. If you've seen the second floor, it's huge, and we've distanced everything, and we are going to be serving food and drinks down there. Well distanced. We've done our best to distance you as much as we possibly can. So right after we wrap up here, and I'm only going to be 5 minutes, I promise, we will go right downstairs, and then that's where we'll do the social. So if any of you are playing the game, and if any of you have downloaded the app, and if you've gone around today and you've wanted points, this is the wrap-up keynote or the wrap-up session, and the code for this session is Neptune 5. Neptune 5, Neptune 5, Neptune 5. So I hope you all played. I know a good number of you are because I've seen the leaderboard, and some of you are taking this pretty serious, which I don't blame you because if you've seen the prizes, they're pretty cool. They're stuff I would want to win, frankly. So again, which as I said this morning, is always our barometer. We always want to give things away if we're going to go through the trouble of making it something that we would be excited about, and if we won, we would actually use. So the items that we're giving away are quite nice. Now I will tell you that the final event tonight that is worth points is the RIoT event. So go down there, there's another code, and I think it's worth 250 points if I'm not mistaken. But again, it's something new we're doing this year. Hopefully you've had fun with it. Hopefully you've engaged with people that you might not otherwise have engaged with, because you know, you're here not only for the educational component, that's number one. I think that's why most people attend events. But the second is the networking too. We want you to meet people. This year's a little bit different. You can't get quite as close to people, et cetera. We know that's a little bit different, but you still want to meet people while you're here. And if we can facilitate that in some way, we certainly want to do that, because we want you to come out of here with relationships and contacts that you didn't have coming in with, and ones that can help you long after you leave. So years after, we want you to think back of All Things Open 2021 and say things like, gosh, you know, I'm still in contact with this person, or I got a job because of this person that I met at ATO 2021. And we have a lot of people that come back and tell us that. So we want to encourage that and facilitate that all that we can. Tom, I mean, we're getting ready to head downstairs, right? Any preview or anything? I don't mean to put you on the spot. I'm sure you're like, Todd, why do you do this to me? Don't do this to me, man. Yeah, come on up. Yeah, because I definitely want people to stay around because this event is very, very good.
And I'm going to add a small clarification. Thank you. So, yeah, I'm Tom Snyder. We love working with Todd and his team. As far as I'm concerned, they're the absolute best in the business. We work with a lot of conference operators around the United States, and thank you again to you and to the entire team and everybody that puts on this amazing show. It took a lot of courage to do it this year, to be quite honest, and it's been a fantastic first day. Actually, second day, I guess. There was a lot of programming yesterday as well. And I encourage everybody to come back tomorrow. Our organization, we're a nonprofit. We focus on economic development in the tech space. So in the industries that all of you work in, as new technologies come about, we've heard a lot about kind of future-looking stuff, right? This morning at the keynotes, we talked about, technology on Mars, and we talked about Web 3 and this transition from Web 2 to 3. And, as new technologies emerge, that's where the best new jobs happen. And so our organization helps to educate, to promote those that are developing new technology. We have over 90 corporate partners that support kind of some of our work. But at the end of the day, some of our core missions are at the individual level, helping people start new companies through startup accelerators that we run, to learn new skills that help them to get hired through educational programs we run, and you'll learn more about that if you come to the event this evening. In terms of the mechanics, we've got on the mezzanine floor, second level, street level on this side of the building, my left, your right, we'll have over 50 demonstrations, technology demonstrations, IoT demonstrations, robotic medical devices, all different kinds of things. It's a cool event. We do have a short talk about supply chain this evening. That'll be in this room at 5:30. And at that talk is where we will announce the code for those of you that are working on working towards these great prizes that.
Well, thank you for the clarification, because I obviously got that way wrong.
Yeah, so no, that's great. The exhibiting and everything opens at 5. You can go down. If you want to come up and listen to the talk, everybody has heard about the challenges in the supply chain so far, and we have a pretty interesting story about how a small software team helped Panera Bread Company to avoid all of the perishable food in their supply chain from spoiling when all of a sudden all the restaurants had to shut down. It's a pretty cool story, had a great impact. We'll give that short talk, we'll give out the prize code, a little bit of information. That's only gonna last for about 15 minutes or so, and then you can go right back down, keep networking, and as was mentioned before, we got food, we've got drinks, a bunch of great sponsors that have helped to set that up. We'll promote them, and we look forward to seeing you this evening.
So I'll say this, we're gonna try to give away prizes tonight. So after we announce that code, we're going to go ahead and take a look at the leaderboard, and we'll see if we can announce some winners, because that's fun. Because if you've been here, learning who's going to win while you're on site, that's kind of cool, as opposed to having to wait 3 or 4 days and the excitement kind of fades, and then you go on about your business, and everybody's like, so what? I'm on to something else. Who cares? So anyway, but we'd like to do that if we can on site. So Tom, thanks for the clarification.
Yeah, thanks
for whatever reason, I don't even know why I was thinking what I'm thinking, but at this point, frankly, I'm fortunate to be standing here upright and somewhat cogent and clear thinking.
No worries. Yeah, thanks again. And there's plenty of time, by the way, to do that and still get over to the sponsor dinner for folks that are involved in that activity.
Yeah. We always do a speaker sponsor dinner on Monday night too. So if you're a speaker or a sponsor, we always do a special dinner as our way of saying thanks, because speakers and sponsors really make, they really help to make this possible. So it's our small way of saying thank you. So anyway, okay. So with all that said, we're going to go downstairs if you want, and then come back for the talk at 5:30. By the way, the talk topic is extremely timely. Is there anyone in the know in the country that's not talking about supply chains right now? Because shelves are empty, and my God, some of the stories I'm hearing is amazing. And it makes me wonder why we haven't maybe prepared, or maybe it's beyond our ability to prepare for. Anyway, even in our own household, we've talked extensively about supply chains and how and why we are running out of some of the things that we're running out of. So the topic seems to be very timely. So with all that said, thank you all very much for attending again. So we will, I've got about, I guess, maybe 5 o'clock or so. It should be about 5. I promised to finish up by 5. I have 5:02. So let's go ahead and wrap up. Again, I do want to thank you. I want to encourage you to come back tomorrow. And we're just very thankful and grateful that you're here. What a different year. We knew 2020 was wild, man. What a wild year. And our mantra internally, this event was all virtual last year. It was, hey, look, let's just hang on. Let's get through this. Let's survive. Let's live to tell another tale on the other side of this. If we could just get through to 2021, boy, Lord. Little did we know, it was like, no. You got some more surprises. So we thought we were home free when the vaccine first came out. We were all excited. We were fist bumping and high-fiving, and so many people were contacting us like, we are back, baby. And little did we know Delta had something else in mind. So we just didn't know. So our fingers are crossed for 2022. I want to thank our AV team. I want to thank Brandon and his team. AV team's done an amazing job today. Thank you all. Thank you, thank you. And I'll say this, right? I don't want to end on a negative note, and I don't mean this negative in any way. But those of you that are here for the first time, and this is your first ATO, keep in mind, this is a very different year, okay? This is not normal. And all the people that have been here, and in this room, there's a really good mix. About equal number of hands went up for have been here, and I've been here multiple years, versus this is my first time. If you're here for a first time, talk to people that have been here for multiple years. This is not representative of what ATO is normally like. So, and I don't know how else to say that. And I don't mean that negative. You're here, so it's a great day. I can see half your face. That's wonderful. I'll take that. You're gorgeous people, beautiful people, and I'm genuinely thankful. But do just keep in mind, right, we're coming out of a pandemic. You know, not normally what you'd expect at ATO or any events. So, and I've talked to a number of people that have traveled the country and attended events in this cycle, September, October. Everybody's coming out of it. We're all seeing exactly the same thing. Some people are just slower coming out. This is going to take some time. So please keep that in mind as you plan for 2022. Our dates for 2022, I think October the 22nd or 23rd through the 25th. I think we're about a week later next year, but it's our 10-year anniversary. So please put us on your calendar for our 10-year anniversary. We want to do something really special. So we're already working on that event, assuming that we're going to be in much better shape from a COVID standpoint. And we are going to do some really special things next year, because next year does mark 10 years. And anytime I think anybody can stick around 10 years, that's something to be commemorated and something to be proud of. So we sure are. But ultimately, we're thankful to you because you have made this possible. And so we want to reward you next year and just I don't know, we're going to do more giveaways than we've ever done. We're going to give away nicer things than we've ever given away as a very small way of saying thank you, because you all have helped us get to this point. So, okay, with that said, I'll go ahead and wrap up. Let's close out day one. For those of you that have never heard, the reason we bring it back in here is because we start the day together, but we also wrap the day together up. Something that we've, together, something that we've always done with ATO. We created All Things Open because we wanted to focus on people and human beings. I had attended many other tech conferences, and there's nothing wrong with them. It's hard to do one of these events, and if you're an organizer, you know where I'm coming from. If you do a small event with 2 speakers, it's hard because you've got so many variables and they're all moving because we're dealing with human beings. So it's forever changing. So to do an event with 2 people is a hard thing to pull off. So I have a great amount of respect for that. But anyway, anyway, we are grateful and truly appreciative. Where was I going with that? What was I going somewhere with that? My God, I even forgot where I was. Oh, focus on people, of course. You can tell I've gone a long time without sleep. This is what no sleep looks like. It's not pretty, folks. It's not pretty. I also have young kids. And boy, that's just icing on the cake. I'm thankful, but man, is that ever icing on the cake. But other events put the tech first. Led with tech. We've always led with people, because at the end of the day, it's human beings that implement technology and create new technology and innovate. So we've always tried to be real with human beings, our fellow humans, and treat them with respect. And that's why we've always focused on inclusion and diversity from the very beginning, because that stuff's really important, because at the end of the day, we're all just trying to make it. We all are trying to get along. And to us, the humanity, the human element of this outweighs and supersedes, frankly, the technology. We love the tech and the education, but at the end of the day, this is about human beings. And that's what we've always started with, and then the tech will follow that. And we're big believers that if you start with the human element, the rest will fall into place. And for us to be around 10 years, kind of a miracle, right? Most events don't last 10 years, or most companies don't last 10 years. But we believe that that's a big reason for it. And so if you're here for the first time, hopefully you've noticed that. Hopefully you've noticed that we genuinely care about you. We genuinely care about the community. We think community is super important. And we just really are very, very grateful that you're a member of our community. So I'll thank you 400 more times. And if you see me, I'll say, hey, thank you. I'll lead with thank you, because we're genuinely grateful, okay? So with that, I promise to shut it down now. Now we're for reals done, and now we're going to head downstairs, but come back at 5:30 for supply chain. Thank you all.
All right. Good evening, everybody. We're going to start in about 2 more minutes, so please just hang tight. We got a few people trickling from downstairs, and then we'll get started. All right, let me unmask here and get ready for prime time. How's everybody doing? It's been a long day, right? Well, thank you so much for being here. My name is Tom Snyder. I lead RIoT. We're a local nonprofit organization, and today we're going to dig in a little bit to supply chain. How many folks have started to see recent stories about, like, should I start doing my Christmas shopping now? Like, what's happening? There have been, semiconductor shortages. There have been all kinds of supply chain challenges. Not only, that ship getting stuck in the Suez Canal 6 or 9 months ago, but kind of broader impacts of the fact that our world has been really trying to drive lean processes across all industries and everything being just in time. And when you have a speed bump as big as a pandemic, it can create some challenges. And so we're going to talk a little bit about that. We call it the world's largest chain as we think about the supply chain, the interconnectedness of everything. But before we dive into that, just real briefly, our organization, RIoT, we're headquartered here in Raleigh, North Carolina. We're proud that this is our home, but we operate across the United States. We have team in about 6 different states. We run programs that really support entrepreneurship and job creation in the areas of emerging technology. Everyone that's here today in some way is probably connected to the tech sector. That's great. We're excited to have you here. But for many folks, they discover, through their life that they, some folks have a great run in a company for their entire career. Some folks jump company to company, but many people at some level have that entrepreneurial itch. You have that idea that you either want to take forward independently through a new startup company, or that maybe you want to champion from within your organization to create change in your organization. And oftentimes those ideas are rooted on the fact that as technologies evolve, we can solve customer problems in new ways. Our nonprofit is focused on helping to create jobs in kind of emerging technology areas. We started back in 2014 around Internet of Things. In fact, we started as a meetup group. The Raleigh Internet of Things meetup was what RIoT was. We grew and became the regional Internet of Things, and now we're operating at a national level, so we're RIoT. You can find us at riot.org, but we operate chapters in multiple states. We run equity-free startup accelerator programs, helping entrepreneurs to grow, helping corporate innovation teams to drive new lines of revenue. We actually have a government innovation team that's participating in our program right now, developing out new services for their communities, for the people that live in their communities, as they look at, how can we innovate? So whatever kind of organization you're in, we'd encourage you to, to reach out, to connect, to either volunteer, to, if you have deep business or technology domain expertise, you'd like to maybe be a volunteer mentor to a young founder that's starting a new company, we would love to hear from you. If you are a corporation that's interested in maybe participating, we have over 90 sponsors that help us to keep all of our programs 100% free for participants. So if you're an entrepreneur, if you're working on some new business, or if you're
a mid-career professional that just wants to come out to one of our classes or one of our workshops. We want everything to be completely free and for that to remain so always. And that happens because of folks like the logos that you see on this screen. Tonight specifically, we have a few sponsors I'd like to call out. Styra does amazing work. If you don't know about some of their programs, please reach out. Are you in the room right now? Some of the Styra folks, they may be downstairs already at their booths, but they are one of the major sponsors of All Things Open, and they're enabling tonight's event to happen and also to be free, including food and beverage. We also have Napino, one of large manufacturing institutions that helps people in particular that have hardware products through their R&D, their distribution, their connected components, and then eventually building out products. DNA Group, right here locally, is oftentimes the crowd favorite sponsor. They're often our beer sponsor. They're also another manufacturing organization in the area that helps with folks that they're building hardware products. I know that we're at a software conference, or at least it's thought of that way. Todd, if you heard his closing remarks this evening, said really we're a people conference and we're also a people organization. The future economy is being driven by data. It's being driven by, thank you, Todd, by real-time use of data. So anything that is happening in the AI, the machine learning space, anything that's involved in blockchain and public ledgers, all these are data technologies, and they're software-driven. But data is generated by hardware, by sensors, by devices, and as we're now learning, we're seeing this transition from cloud computing out to the edge because of the latency advantages and things that you heard from Red Hat CTO this morning. We're seeing more and more real-time information, collect data, immediately do something with it, automate solutions. Sometimes we ourselves are the data creators, right, when we're inputting things into our phones or into our computers and other things. But we see the future as a much more close merging of both hardware and software. And so we try and bring all those communities together. And as soon as we're done with a short talk here, I encourage you to go downstairs, see technology demos, learn about this kind of fusion of both hardware and software and IoT and data. It's a whole lot of fun. At 6 o'clock, we're going to roll out the food and the beer that these sponsors are bringing forward. But back to our topic for the evening, supply chain. Everything we can look at in this room came from somewhere, right? The tables, the chairs, the AV equipment, all the food that's up on this slide. This is a Panera slide. You're going to hear a Panera story in a moment. It all comes from somewhere and it has to get from A to B. And we don't always think about the complex networks of aircraft and shipping and rail and trucking and all these different interconnected things that physically get our stuff from place to place. And the fact that all of this is really driven by software. So this is another, hardware and software fusion coming together to create an interconnected system that ideally gets things from place to place, as Amazon would try, within 2-hour delivery, right? How do you develop out these optimizations and efficiencies that whatever you might want at whatever time you think you might want it, it can get there? Well, what happens when all of a sudden you have something like a pandemic that completely disrupts where things are going and why? I'm really excited to hear the story of one of our software partners, Tibco, and how they helped one of their customers to maintain and completely re-engineer through software innovation a supply chain in the midst of the pandemic. And so with that, Jesus Centeno, I'll ask you to come up to the stage and tell your story.
Thank you, Tom. Thank you. Can you guys hear me okay? Yep, sounds is good, yeah, okay. That's a really big picture, so let's move on to the next slide. So, hello everyone, my name is Jesus Centeno, and today I'm joined virtually by Noel Nitichek, who is Director of Enterprise Services at Panera Bread. Unfortunately, he didn't get clearance to travel and be here with us today, but we'll be hearing the story directly from him on how they basically leverage technology to re-innovate and reinvent their supply chain, basically, right? So as Tom mentioned, I work for a company called TIBCO Software. For those of you that are not familiar with the company, we've been in the industry for over 2 decades. We do a lot of like data related things, right? Like it was interesting to hear Tom saying how everything comes from the data itself, right? So think of TIBCO as a way to not just connect to the data, but integrate it, move it, virtualize it, analyze it. So things like analytics, machine learning, MDM, right? Like those are embedded in our DNA for sure. You know, these next couple of slides are interesting, right? Because oftentimes when you hear the word supply chain, people will think of different things, right? And sometimes it really depends on what world they're coming from, right? Like, is it more like the technical side? Is it more like the business side? Usually it tends to be one or the other one, right? So this first picture is more like what I would think, like someone from the business side would think when they hear supply chain, right? It's the perfect picture where everything works well, everything connects, all the devices talk to each other seamlessly, automagically, right? Like you can configure it, you can customize it, you can fix it remotely with the tap of a finger from a iPad or a remote device, whatever you are in the world, right? Now, we know that like that's hardly ever the case, right? Supply chain, it is messy, right? It's very complex. And it gets difficult very quickly as well, right? So when I hear supply chain, this is what comes to my mind, right? A lot of stuff moving all over the place with needs to track it, to optimize it, to revolutionize it in any way possible, right? Now, why would we care about supply chain anyways, right? Like, I mean, Tom made an awesome case for supply chain, and actually, I'm very excited. I live in Austin, so in theory, tomorrow night when I fly back, Home Depot will finally have the door for my home office. So I recently moved houses and I built a home office. I've been waiting for the door for 6 months, kid you not, right? So to the point that like, yeah, I mean, why we care about supply chain? Because once upon a time, there was a year called 2020. And we all know what happened with that, right? So, I think it was the perfect case for us to realize how big is our dependency on the supply chain, right? Actually, I don't think I ever got to the bottom of this, right? Like, what happened with the toilet paper? Like, where did it go? Like, anyways, it's an interesting story. But, it's clear that, like, we depend largely on the supply chain to get a lot of, like, the products and items and services that we consume on daily basis, right? That they have become part of most of our own existence, right? So that's why we care, right? And we all of us in the technology field, right, we have the responsibility to leverage the best in breed technologies out there, powerful technologies that we have nowadays to make the supply chain the best that it can be, as efficient and as productive and as cost efficient, right, as possible, right? So let's talk about like some of the different technologies that can shape the supply chain, right? So number one, blockchain, and social sustainability, right, is top of the mind of a lot of like the consumers out there, right? Like this notion of I just don't want to buy. I want to know what I'm buying, and I know who I'm buying it from, and where that product has been, and how it was manufacturing, and what were the standards and the policies, and et cetera, that were followed to produce and manufacture that item that I'm thinking of buying, right? And I want to make sure that they stick to my view of the world, right? And so this requirement, right, to understand the lineage, the track and tracing capabilities is becoming more and more common, right? So blockchain is a technology that can definitely be leveraged for those type of scenarios. Now, digital twins as well. Digital twins is a very powerful concept, right, that can be leveraged to bring together the physical and the digital worlds into just an abstraction layer, right, of an entity, right? That entity could end up being pretty much anything, right? Like a person, a process, an institution, data itself, right? Or a supply chain, right? Like that would be the ultimate digital twin, right? And it really allows us to then run experiments, right? And different scenarios, hypothesize different scenarios on how the different subcomponents of that entity, they correlate and they influence each other, right? So in the case of supply chain, for example, trying to figure out how changes in transportation system are going to affect positively or negatively the overall supply chain, right? So very, very powerful concept. There's also, the idea of contactless payments, right? Like, so with the rise of e-commerce, with the pandemic and other things that are happening in the world, contactless payments are becoming more and more common, right? So blockchain is very well suited to support this type of initiatives. Now, second force, AI and ML, right? So think predictive analytics. How powerful it is, right? Like the ability to predict what's going to happen, identifying patterns, identifying risks or potential fluctuations in the market, right? And be better prepared to address those fluctuations. Have a way to run your operations as efficient as possible, meet the demand with the exact supply, consistently, on a consistent basis, right? That's a very powerful concept that definitely can be leveraged. Now, so think of reverse logistics, for example, right? So reverse logistics as, the addition of all the services, right, that especially now with e-commerce, that retailers have to provide to support, the demands of customers, right? So think of returns, refills, reselling, recycling, right? All these value-added activities that happen after, post-sale, basically, points, right? And how technology can support, those type of requirements. Drones, another great example, right? How much ML capabilities drones need really to be functional. Right? I know that there's a big legislation aspect into drones, but from a technical point of view, right, like drones are getting almost ready, right, to become, at pair with other type of transportations in supply chain, right? Especially, when you attach cameras, they can address very, very powerful use cases, right? So from delivery of vaccines in remote locations to track and trace to surveillance, auditing, et cetera, right? You name it, right? So, ML definitely is a major engine that is driving a lot of, innovation in supply chain. All right, the third force, robotics, right? So let's think of, for example, autonomous vehicles, right? So if we think that most of those, items and products that we've been talking about, right, they are delivered by trucks in the end, right, in the supply chain. So think of the impact of now having self-driving trucks, right? So obviously we're not there yet, right? Companies like Tesla and Mercedes, they keep making a lot of progress. We're not level 5. But I think we all agree that it's not a question of if anymore, it's more like a question of when, right? This is going to happen, right? So imagine the impact that self-driving trucks will have in supply chain, right? In terms of efficiency and cost savings, right? This is a huge aspect of the conversation now. Now, in terms of also robotics in the context of warehouse automation, right? With the increased level of capabilities of things like IoT sensors and mobile scanners and wireless telemetry, right? And basically increased capabilities, right? In terms of understanding what's happening in the warehouse, right? Like warehouse management systems, for example, right? All these capabilities are helping warehouse automation, right? To bring the digital and the physical aspects of process automation closer and closer together, right? To have an easier and faster and cheaper way to bring warehouse automation to the next level, right? A good example of that is autonomous robots or AMRs, mobile robots, right? So, leveraging these robots to take care of all the heavy lifting, right? All the hard tasks, so to speak, right? In warehouse management, and then focus humans, right? On more like the decision making process, right? Strategic decisions, right? In terms of the operational side of supply chain. Now, force number 4, environmental factors, right? Big aspect here, right? So think of lean logistics, for example, right? And, lean logistics has been one of the main or most active conversations, right? In terms of how you can reduce waste, how can you boost efficiency in the supply chain, how you empower your employees with technology and knowledge, how you have more open feedback, how to improve the processes, right? So these are big questions, right? Then how you leverage technology to do that, right? I think we all realize, right, that in order to have a greener supply chain, this is not an easy task at all. You're looking at leveraging a lot of different technologies from materializing efficiencies, but also training employees to perform their jobs the best they can, in the most cost-efficient way possible, right? Risk management is also a big part in terms of environmental factors, right? So when it comes down to whether it's logistic risks or operational risks, right? You're looking at technologies such as process mining, right? To understand, for example, where are these risks coming from and what's the best way to address them? What are the factors that are driving those risks in my process, in my business process, and what's the best way to address them proactively, not reactively, right? So that's another big aspect. Now, last but not least, IoT, right? Like core topic for this conference that we're all in. So IoT being defined oftentimes as the eyes and ears of supply chain, so very well positioned to make a huge impact, right? As we've seen it. So things like computer vision and inventory tracking capabilities. I think of computer vision as not just computer vision on its own, but this capability of taking computer vision feeds in combination with traditional IoT feeds, right? Like this sensor fusion concept that we see more and more often, right? For example, loss prevention in retail. It's a huge topic, right? And when you think of what needs to happen at a point of sale in, let's say, a Target or a Walmart, you have the kiosk, you have a camera, you have a scanner, you have an RFID mat, you have a scale, and all these readings, they have to be understood real time together in a split of a second to determine if there's an anomaly or not, right? Very, very powerful concepts, right, to identify anomalies and have a way to react in real time to those events. So with that, I wanna now present Panera's story. So Noel will be describing how they leverage in different technologies such as MDM to understand cross-domain relationships in their data, and basically how they leverage that understanding to find efficiencies in their supply chain, and also how they basically understood supply chain as part of their strategic roadmap. So with that, let's hear it directly from Noel. And yep. Oops. No.
Thanks, Jesus. I'm happy to be able to speak with you today about how we've been able to transform the TIPCO, meeting new challenges by having greater ability to manage the data underlying our business. At Panera Bread, our focus is on giving our customers good, real food that they love with a friendly touch that we call Panera Warmth. Whether you're in the business of food and beverage, retail, hospitality, or any other, the ability to adapt and manage constant change is crucial for success, whether those changes are customer tastes, market demands, or real-world events. In case you haven't heard of us, Panera Bread is a fast casual bakery cafe chain of more than 2,000 locations across North America. We focus on natural, real foods without artificial additives or preservatives, sandwiches, soups, salads, and we've even launched a line of flatbread pizzas that are delicious. Panera has experienced rapid growth over time, and it's because we led the industry in technical innovation with things such as mobile ordering, fast lane kiosks, and rapid pickup stations. The expansive My Panera loyalty program has tens of millions of customers, and we've also partnered with third-party delivery services nationwide. That rapid growth came with a lot of data challenges for our company. For a lot of our teams, we were heavily reliant on manual processes, spreadsheets, wiki pages, manual SQL scripts where we were updating data directly in production databases. What that led to is a lot of complexity and also a lot of risk. So with all those handoffs and all those manual processes, and you look at the extent of our menu, whether the variety of items that we offer around the country based on regional tastes, all of the pricing differences that exist because of different markets and the different price points that we offer items, nutritional data, municipal tax codes around the country, the data elements and the data points that we manage are well into the millions. And things are changing every day with new innovation. And new changes and new items that we're testing. And so needless to say, that's a lot of data to keep up with. And so we partnered with TIPCO, and we've solved our data management challenges with using what we call the Panera Data Pantry. And we've built that on TIPCO's EBX platform. It's our master data management system, and it's now a critical function to all of the systems around Panera that require data about our cafes, or our menu, or our inventory items. And so we can focus on those things and we can quickly pivot because now we know that the data is in place. We have those integrations tightly built. And so that when things change in the marketplace, we can react very quickly. So one thing I do want to focus on based on the nature of this event is our supply chain. We have distribution centers of our own across the country, and we also rely on third-party distributors to get products to our cafes so that our managers can serve our customers. And with the situation last year with the pandemic, there were challenges to that supply chain process. And one of the things several things we had to do very quickly. We had to adapt to more outside, off-premise consumption of our items, whether that was through drive-through. We launched a curbside pickup channel, and more of our items were going out to customers through delivery channels as well, whether it was our delivery system or third-party aggregators. And so with that, we were able to turn those channels on because we knew where our menu data was, and we knew it was in good shape because of what we had done with the Panera Data Pantry. Another challenge we found was that our customers weren't able to get some basic staple foods from their grocery stores because of supply chain issues. And here we had these inventory items that we used to make our items like blueberries or milk and those kind of staples that people were in need of. So our leadership came up with the idea of Panera Grocery. And in less than 2 weeks, we were able to take those inventory items and relabel them, repackage them, and price them in a way that was affordable to our customers and use our existing channels to get those grocery items to customers that needed them. So we're able to leverage our data in a way to unlock new business opportunities very quickly because of what we had done with TIBCO. So using our supply chain to our advantage, we're able to leverage all that data and adapt to those sudden business changes. Processes that otherwise would have taken weeks, we could do within days. And because of the innovation that we can now carry out, we're able to say yes to a lot more menu initiatives to our business. And IT as a entity is no longer in the way. We put the management of the data into the hands of the business owners, and we're able to implement changes to the menus and build a lot of more seamless processes, supporting even new locations spinning up a lot faster and not being the bottleneck within the IT department. Our data governance is also streamlined through the company. We use the workflow functionalities with EBX to make that possible, to keep our data quality high. And we also are able to use that data to provide our loyal customers with the quality food they expect. And while continuing to innovate on the menu side and continue to grow that customer base. And it's because of what we've done with TIBCO that helps make that possible. We look forward to future partnerships and continuing to innovate with TIBCO. And I want to thank you all for listening to me now, inviting me to share with you today. I hope you all enjoy the rest of this fantastic event. Jesus, back to you.
There's one line that I love in that story, right? Like, I don't know if you caught that, but in 2 weeks, basically, they were able to reinvent their business model, right? And make sure not to lose the investment that they had on inventory. That is just a great, great story. So really quickly, just to, some closing thoughts. Technology keeps being the propeller of progress in the world. There's no doubt about that, right? And as problems become more complex, right, like the solutions, they need to be more and more creative. Always keeping innovation at the core of everything. So feel free to stop by. I'll have a table at the expo hall, and I would love to chat with all of you. So thanks for your time.
All right, thank you, Jesus. Fantastic stuff. All right, last slide of the evening before we head downstairs. For networking, great demonstrations. Again, I want to thank some of our sponsors for enabling what we've got today. But for those of you that are working on all the great prizes, giving out at All Things Open, I know that we've been waiting for the code for this session. So I'll give you just a moment to pull up your apps and get ready for that. The code for tonight is Spacewalk 3. So all one word, Spacewalk, and then the number 3 at the end of that. So go ahead and punch that in. I'll repeat that again in a moment, but if you go out these doors, take a left, you're going to go down 3 escalators, and you'll be out. The food and beverages should be rolling out right now, actually. And please meet some people, help make introductions to folks that you might be able to help in your network, connect and make this All Things Open and RIoT community even more powerful through your participation. So thank you again for your attention tonight, and I look forward to meeting some of you downstairs.